So, I think that we should start very soon. So, good morning, everyone. I believe now we are live and streaming. So, good morning, everyone, and welcome to the Europe-Africa Space Earth Observation High-Level Forum. And for those who made it, welcome to Lisbon. For those online, welcome to this meeting today. My name is Hugo Costa, and I'm one of the directors of the Portuguese Space Agency. And it is with great honor and pleasure for me to be here at the open session of this event for the Portuguese presidency of the European Council. Today it's the first of 2 days event, today with more scientific level and tomorrow with a high-level forum at ministerial level. After 14 years of the last presidency of the Portuguese presidency of the European Council, and with a great event on Earth observation, we are now starting the second big event also for Earth observation. And the meeting today and the meetings that we'll have also tomorrow are the result of 6 months of hard work with a big team to make this happen. Lots of emails, meetings, documents moving back and forth through email. It was quite a hectic journey till we reach here, but it was also very fruitful, and we hope that the meeting today and what will be then presented tomorrow with the manifesto will be the stepping stone also for the future of the relationship between Europe and Africa. And I would like to thank, I have here a long list, but I think it deserves this list to be mentioned. Because this organization is not just between the Portuguese presidency, but also with our partners. And our partners are the European Space Agency, EUMETSAT, the European Union Space Program Agency, the European Commission and the different DGs involved, and of course the African Union. We'd like to thank also to BBE for supporting us and the organization, and numerous people that were always supporting us and sitting around the table. And I'd like to mention Teresa Tavares, Paolo Rogeri, Benjamin Coates, Vincent Gabaglio, Michel Massart, Anna Hakami, Catherine Guillot, Stefano della Terrabella, Astrid Koch, Ivan Coulis, Marie Menard, Miguel Bello, Meshach Niditiru, Dr. Jolie Wasambo, Dr. Tidiane Awatara, and Ines and Herminia from the Portuguese Space Agency. Thank you very much to all, because without you this will not be possible. And it is my great pleasure to be here sharing this table with Dr. Tidiane, and I would like to give you the floor. Also, welcome Tidiane, and it's a pleasure to me to be here and opening this session with you. Thank you very much.
Thank you very much, Hugo, and it is with a real pleasure that on behalf of the African Union Commission, and tomorrow you will have more appropriate people talking on behalf of the African Union Commission, because our Commissioner, Professor Sarah, will be online, and Dr. Mahama also will be in person here. Before that, I would like to take the opportunity on their behalf to thank all the organizers. As Hugo said, today is like the result of several months of working together to have an integrated and consolidated agenda for today and tomorrow. Yes, after, I would say, almost 15 years, we have to come together to review our achievements, to build on our achievements, and to look at the future. The future is made up of new challenges, new needs, and how together Europe and Africa can work to address the sustainable development of both continents through the use of Earth observation. And for us in Africa, we strongly believe in the fact that this collaboration should continue, and it is the same from the European side. Today, we'll discuss at the scientific and technical level, and tomorrow at the policy level, we will have, I would say, several things to discover, and we are 200% sure that our decision makers will help us to go through the process. That being said, Hugo, I cannot end my speech without, on behalf of the African Union Commission, thanking the presidency, because you did a lot, and Portugal, for this two-day event, is really leading very well with the support from all other organizations you have quoted, ISA, GRC, UMETSAT, etc., and African Union Commission. Once again, thank you and welcome to all people, all colleagues online. We are together, and together we have to build a strong case for Earth observation. Thank you.
Thank you very much, Tidiane, and I think now we can move to the first session of the day. The first session is Earth observation challenges, and I believe the first speakers are now online.
Yes, Hugo, this is Mark Dowell. I'll be moderating this session, so I can start if you agree.
Yes, please, Mark, welcome, and please, the floor is yours.
Good morning, everyone, both to the colleagues who are in Lisbon and to all of the colleagues online. It's a pleasure to start moderating this first session, where I think you'll see we have a lot of interesting speakers. This session is focused on Earth observation challenges, and the intention is to outline key challenges where Earth observation can play a role in addressing gaps and opportunities. As we heard from the introductory comment, that's a big part of what we're, the ambitions of the next 2 days, through both looking at applied research and downstream services in support of the African Agenda for 2063, and really building on the strong foundation that we've accomplished so far, but also thinking of elements that will be critical as we update our roadmap for future cooperation. And really one of the main emphases will be on building that last mile in the information value chains that we can provide to decision makers and policy actors on the uptake of Earth observation data and information. So this session is split into 3 key sections, addressing different thematic areas. We'll start with the marine areas of application, then we will address land, terrestrial areas, and then finally a broader area addressing climate, disaster, risk management, and atmospheric applications. And as I said, we have a very impressive lineup of speakers to address these issues. In the first part of this session on the marine issues, we'll be starting off with 2 colleagues, Hayley Evers-King, who is a marine application specialist at UMETSAT, and Eric Marshall, who is the GMES and Africa project manager at the Mauritius Oceanography Institute. So I believe they'll be speaking back to back, and so I'll pass the floor to Hayley, who will be starting off, and then we'll transition straight away to Eric. After each of these sessions, there'll be a brief opportunity for question and answer as well. So Hayley, the floor is yours. Thank you.
Thanks very much, Mark. Hopefully you can all hear me. Good morning. I'm just going to share my screen so you can see our slides. Okay, and that should be in slideshow mode. So I'm going to hand straight over to Eric to introduce what we're going to talk about today. Eric, please go ahead. Eric, I think you're muted.
If you're talking, we can't hear you, Eric.
Good morning to everyone. Can you hear me?
Yes, we can hear you.
Eric, that's fine.
So I'm Eric Martial from the Mauritius Oceanography Institute. During this joint presentation, Dr. Haley from UMETSAT and I will discuss about the main challenges in the marine domain on which Earth observation can have an important role to play. So I will start, the next slide please. I will start with a brief presentation of the Institute, the MOI. So the MOI was set up back in 2000, and the aim was to have a coordination about research and development activities related to the oceanography for the Republic of Mauritius. Although MOI is a national institution, MOI has been entrusted by the Indian Ocean Commission to participate in various projects funded by the EU. MOI has been the regional implementation center for the AMSD project, the MESA project, and now we are the lead in the GMES and Africa project. So over the past years, since 2008, MOI has been working with different institutions from Europe to build capacity and also to develop applications. We have been working with UMETSAT, the Plymouth Marine Laboratory, Mercator, and other institutions in various fields of oceanography. Next slide, please. Haley, on to you.
Thanks, Eric. So I'm just going to say a few words about the organisation I work for. Many of you will know us, but for those of you who don't, I work for UMETSAT. We're an intergovernmental organisation with many member states all over Europe and beyond. And we also have a lot of extensive international collaboration with other agencies, and most notably, and in context of today, with many nations throughout Africa. We have two main mandates. One on providing weather and climate data to our member states and our collaborators, but also a growing presence in terms of additional capabilities interacting with the European Union's programs in space, particularly the Copernicus program, for which we operate several satellites. And this is where my role sits. I'm, as Mark introduced, a marine applications expert, and I do a lot of work with the Sentinel-3 and Sentinel-6 missions, hence my involvement today. And this builds on my own personal research background using ocean data for different societally relevant applications. And I help people do that today with our data. So I'm going to start us off today with a bit of a discussion about what we're using in the marine domain when it comes to Earth observation. And I use this image you see here a lot when I'm talking about Sentinel-3. So you'll see it's a little bit Sentinel-3 bias, which is why SAR is in a bit of brackets there. But across the marine domain, we're using altimetry and synthetic aperture radar technologies, sea surface temperature methods of measurement, and ocean color to look at this wide variety of different applications in the marine domain, which I'm sure you will agree are relevant both in terms of being scientifically interesting, but having a lot of societally important applications, particularly when we look at the challenges that we face in terms of sustainable development, climate change, etc. So just to give you a context for the really wide variety of different applications that marine Earth observation data is being used for, and also how the technologies interact. And this has been exploited through a variety of different African and European collaborative R&D projects. In history, this list is by no means exhaustive. There's been so many amazing projects that have brought this data to where it is and the status that we're at in terms of it benefiting society. But just to highlight a couple of initiatives that you'll hear about in our talk and in further ones during this event, things like GMES in Africa, building on the MESA program, the various European framework programs such as FP7, Horizon 2020, programs by our colleagues at ESA, POGO, GEO, and different national twinning programs have all informed what's happened in terms of the marine research and development environment. And this has been built on by different marine strategies that have been present at a governmental level, both in Africa and Europe, with regards to things like the blue economy. And Eric will talk more about how the blue economy fits into marine Earth observation research and development later. The topics that have been covered by all these different programs that we've been involved in across the sector include key things that from a practical element make the data accessible to research and development scientists. So data access, we've done a lot with that UMETSAT, with our UMETCOS systems, for example. Validation of data, visualization, as well as building collaborative networks for capacity building, which is a problem across the sector. We have a growing need for experts who can actually handle and work with this data to bring its full value out. And in terms of topical applications, maritime safety, oil spills, illegal fishing, water quality, these are just a few examples of applications in the marine domain that are benefiting from Earth observation data. And this is really growing to be more interdisciplinary with our colleagues who work under the weather, climate and atmosphere sectors as well. So with that, I'm going to hand over to Eric to talk more about the continental socioeconomic context and provide some further examples of the marine applications.
Yes, so I believe that as we are trying to achieve the objectives of the African Agenda 2063, one of Africa's greatest challenge is how to develop and secure blue growth while ensuring sustainability and long-lasting societal progress. So let us have a look at the context for the continent. As you may note, 38 out of 54 African states or coastal states, a large part of the African population lives in coastal areas. Freshwater and ocean fish provide income for over 10 million Africans. Africa's maritime zones total about 13 million square kilometers. Lake zones of Africa cover approximately 240,000 square kilometers. Fish, as we all know, is an important source of food for over 20 million Africans, and more than 90% of Africa's imports and exports are conducted by sea. So this is why we believe that the marine domain is a very important aspect where, if we have the support from EU, this can greatly help our population. Next slide, please. So like I mentioned, the biggest challenge for us is to secure blue growth and sustainability. Next slide, please. So what are the key challenges as regards to the fisheries and aquaculture? Fisheries are crucial for livelihoods across Africa, but yet we still have a few challenges we need to overcome. Although technology can allow us to find fish, we have also to look into the aspect of how to reduce overexploitation, how to manage underused resources, how to protect the critical habitats and ecosystem from degradation, how to monitor nutrient buildup that may cause algal blooms. Also very important for our decision makers and policy makers to have informed decisions. We need to provide them with the necessary data. Another important aspect as regards fisheries, which I believe is the case all over Africa, is the low capacity to enforce existing policies and also a lack of means for surveillance and enforcement. We all know that with EU data, a lot of information, a lot of useful information can be provided to the decision makers and policy makers to address those issues. Next slide. Making trade and travel by sea safe and secure is critical, but yet we can see that as far as maritime and security issues are concerned, many countries lack enforcement vessels and human resources. We also have limited capacity to observe activities across their territories. We have limited information on the vessels that are moving around across the territories. Also, a very important aspect, search and rescue missions is limited in terms of means. We don't have enough resources to go out during search and rescue missions. Also, limited information available to ensure security of seafarers and fishers is a drawback as regards maritime safety and security. Next slide, please. Marine renewable energy, we believe, can contribute to our energy security and help reduce the production of electricity from fossil fuels. But there again, to tap into this technology, it's a challenge. We have noted data and knowledge gaps. We need to have more information that can assist African countries to explore the potential of offshore wind and wave energy. We need to develop or use different models to study the technical feasibility of using marine energy. And also we need to have access to the necessary technologies so that countries can move ahead and tap in this source of energy. Next slide, please. Another important aspect is climate change. We all know of the impact of climate change, be it on land or on the marine environment. Ocean acidification, coral bleaching, industrial pollution, sea level rise, all these impact on our environment, creating loss of livelihoods, food insecurity, biodiversity loss, and so on and so forth. So this is why we believe that for the continent, the mitigation of climate change risk is still important, and the contribution from Earth observation can help in achieving those targets. On to you, Haley.
Yeah, so this is a great challenge, I think, to finish on that section, Eric, because climate change is really a broad integrator of a lot of different marine issues where Earth observation can offer benefits, particularly where we were talking there about the resilience of important industries. Many of those you've mentioned in the previous challenges, but climate change presents a risk to all of these different industries, and we need to really integrate how we're using our Earth observation data in order to manage those risks going forward. So I was going to talk now about, sorry, let me just change the slide, about the research and development priorities going forward. And I think here, in terms of where we're at with how we're using marine Earth observation, we're moving towards similar statuses both in Africa and Europe, and we share a lot of common priorities in terms of our applications areas. The need for marine energy is ever present because of climate change, increasing fisheries management as we try and deal with exploitation and manage these industries sustainably so they can last us and help us to economically develop is really vital. But we're also looking at new applications such as novel exploitation of different types of aquaculture. I've got an example there of abalone in South Africa. Things like lobster and different marine sort of large fish species are new types of aquaculture that are coming online. And I think marine Earth observation offers a really great way to help us figure out where and when we can deploy these types of aquaculture. And that then leads quite nicely into discussions about marine management, monitoring and policy. Eric spoke a lot about the difficulties of enforcement, and Earth observation with its excellent spatial and temporal coverage and a growing body of freely available data and tools really offers us a way to get a handle on this very large and difficult to access environment, which is the marine domain for many countries. And our last point previously was about climate resilience. So Earth observation in that sense should offer us ways of future-proofing our industries, deciding where we put them, how we operate them, so that they can be resilient against changes that we expect from climate change. But all of this really requires very interdisciplinary approaches, things like participatory design, so drawing on the socio and economic principles that our colleagues in those sectors work on. Learning how to estimate and crucially communicate risk is vital for us in terms of designing downstream Earth observation products and informing our R&D agenda. And similarly, looking at socioeconomic valuation and trade-off analysis. There's sort of a gap between where we have our data and these activities that are going on, and how do we convert what we have as very scientific data into valuation indexes, indices, metrics that are actually useful for decision makers. This is a real R&D challenge, I think. And all of this requires good data synergy and also to a degree regionalization. And this is somewhere that we've done a lot of work historically in the marine domain between Europe and Africa, is looking at areas like coastal and complex waters, where we have a big diversity of what is actually going on in the ocean and how that's represented in remote sensing. And there's a lot of science to be done there to decide the optimal approaches for deriving products and for detecting things like for shipping and for pollution management, etc. We have a growing range of new technologies coming online, new sensors, for example, the new altimetry and SAR missions that are going up at the moment, potential for things like geo-ocean color, CubeSats, the new Earth Explorer programs that are coming through ESA. All of these will have relevance for the marine domain, and we need to know how, or we need to figure out in terms of research and development, how to integrate these into our operational and applied scientific techniques. Similarly, beyond the actual Earth observation sector itself, things like model assimilation, artificial intelligence, machine learning also have a part to play in how we really exploit our data to get maximum value. And I've titled this slide Potential Benefits, but I'm aware this is a little bit, this doesn't really say enough. Actually, we already have a lot of benefits that are coming out of the use of Earth observation between Africa and Europe. And some of the later sessions today, you'll hear from some of the GMES colleagues about the operational applications that have been going ahead. They're already showing real benefits. But if we progress our research and development agenda, we can, I think, increase these even further, particularly around a couple of areas. So reducing risks and increasing efficiency for things like food security, making sure that we're maximizing yields and resilience, whether that's fishing or land-based agriculture that has strong influence from oceanographic phenomena. Improving safety obviously has benefits for life, but also reduces potential loss to industries that has economic value as well. And the same with business operations, things like reducing fuel consumption for the fisheries industry reduces our carbon emissions, but also makes those industries more efficient, more cost effective. And similarly for aquaculture, fisheries, etc., knowing water quality and harvesting planning through metrics and things derived from Earth observation can be really beneficial. And this all speaks to effective management, informing policy, helping regulatory compliance, allowing for multiple use regional planning in the marine domain, responding to disasters, managing pollution, reducing costs in general for these approaches is something that Earth observation all has something to contribute to. And lastly, I made a point here that we have an opportunity here for innovation from growing capacity. So there's a lot of things, potential benefits that we don't know about yet. And if we continue to push innovation in the Earth observation domain, there's really no limit to where we can go. We don't know what wonderful things are going to come out of potential future collaborations and R&D. So hopefully all of this brings us towards meeting that challenge that Eric described of sustainable development and particularly growing the blue economy for the benefit of all stakeholders. And we will finish there. Thank you very much for your attention, and we'll take any questions.
Thank you very much, Hayley and Eric. Okay, so we can take some questions if anyone wants to raise their hand. Maybe while people are thinking about that a bit, I'd just like to dig a little bit deeper, Hayley, into the kind of this idea of the opportunities that can come out of new data science aspects. We know, of course, that the marine environment and ocean application, marine and ocean, coastal marine and ocean applications have kind of their own specificities as far as data management issues and things like this. So where do you yourself and Eric see opportunities, let's say, with the new aspects that are coming online as far as data management, data analysis, and so on? Thanks.
Thanks, Matt. That's a really great question. I think, as you say, there are a lot of new missions, a lot of new data out there. We have huge volumes of data. So one of our real challenges is actually being able to distill that information down into things that are meaningful. So in terms of focusing on our R&D, looking at how we can bring data together synergistically that maintains its accuracy is a real challenge for us with a lot of very different data streams in the ocean world. So our long track altimetry versus our long-term climate records, merging that event scale into the climate scale, while still maintaining as much scientific integrity as we can with those two sets of measurements is quite a challenge. And I think this is going to require focusing on things like using appropriate statistics, using machine learning, but also that solid basis of understanding of what is the physical or biological, in the case of different data streams, underpinning of our systems. What is it what sort of temporal and spatial scales do they tick at? And we need this very interdisciplinary approach to bring that together. So that's a challenge for us in Europe and a challenge for our colleagues in Africa. So something hopefully we can work together on. Eric, do you have anything to add on that?
Yes, just to add, I think when it comes to the marine domain, and when we are talking mostly about the small island states, the resolution of the data available is also important. And this is where the type of application or products that we are developing for those specific small island states should be relevant for them in terms of the resolution, so that the necessary actions can be taken based on those data and information which are provided. Because we know island states, just like states on the coastline of Africa, we all have the problem of coastal erosion. Maybe on the continent, we can have make use of Landsat data where the resolution is enough to really understand the problem. But when it comes to island states, this is where we need higher resolution data so that we can really understand the phenomenon which is going on and how these can be developed into reports or into products that can really be used by the different decision makers.
Thanks. That's very, very useful, Eric and Haley. And actually, again, Eric, I think what you're saying is has a lot of synergies as well with the way we see things going in some of the needs in Europe as well, which is really towards data at a much more actionable scale where we can make use of it in decision making. And I think, again, that's another area where we probably have a common interest. So I don't see any other raised hands, and to keep time, I suggest we move on to the next section now, which is addressing land and terrestrial applications. So thanks again very much to Haley and Eric for their interventions. So in the second session, we will have two speakers, Alan Bellwood, who is a colleague and the Deputy Director for the Directorate on Sustainable Resources at the European Commission's Joint Research Centre, and also Head of Unit for Agriculture and Food Security. And Catherine Nakalembe, who is Assistant Research Professor at the University of Maryland and actively involved in the GeoGlam initiative addressing agricultural and food security applications. So I'll pass the floor to Alan, and we look forward to hearing their intervention. Alan, the floor is yours.
Thanks very much, Mark. I shall share my screen. I hope. Let's go. Yep. And let's get straight into it. This picture that you can see on the screen in front of you is actually a very important historical image. It's the first image that was acquired by a European Earth observing satellite in 1977. It's the European Space Agency that owns the copyright to this image, and it's EUMETSAT that managed the satellite program now, Meteosat. And this is an important part because ESA and EUMETSAT are both key partners with us in a very long-standing relationship that we've had with the African Union on Earth observation over the land. The second message that that image gives us really is it emphasizes the very close nature of our neighborliness with Africa. Unfortunately, the European Union is actually under cloud on that image, but essentially it emphasizes how close we are. And that closeness is reflected in a very long history, a very rich back catalogue of research between the two groups. And we have the PUMA program, the AMES program, the MESA program, the GMES and Africa program. Now, all of that past is based on an old paradigm of Earth observation of the land, where you could get lots of spatial detail, but you could only get lots of images over a short period of time, and everything was offline and all the processing was offline. The key change for us today is the new paradigm. We just heard in the marine presentation the importance of spatial detail. You can get lots of spatial detail lots of the time now, and it's all in the cloud, and the processing is in the cloud too. So we're dealing with a new paradigm. Now, where does that take us then in terms of land? Well, the actual land resource of our two unions hasn't changed very much in millennia. The Africa Union has 30.37 million square kilometers of land, and the EU 4.47 million square kilometers of land, and that's pretty much a constant. The people living on that land, though, and using that land, there's some big changes. In 1973, the countries making up the European Union today had about 400 million people living in them, and the African Union had about 400 million people too. Run forward to today's numbers, and you've got 1.3 billion for the AU and a small increase for the EU. Go forward another 30 years, and you're going to end up with over 2 billion in the African Union, maybe a slight drop in the EU. But what that means in terms of land availability is there's going to be roughly 1 hectare of land per person in the African Union and 1 hectare of land per person in the European Union. And that means a lot of pressure on our lands. And Earth observation is already playing a key role in how we make decisions about how that pressure is alleviated. Choices in terms of land use and transparency in the way that those choices are arrived at. So let's start with the most fundamental, which is soil. Basically, my colleagues say no soil, no food. In fact, it's even no soil, no biodiversity, or at least a very different biodiversity, no soil, a very different climate system. It's a pretty fundamental thing. Earth observation per se isn't that useful for mapping soils. We have got a map. We've created a new map of the soils of the Sahara Desert, not exactly known for its contribution to food security, but very important in terms of climate and biodiversity and many other factors. But essentially, we only map soil when there's no vegetation on it directly. But we do use Earth observation to condition soil mapping exercises. And one of the big exercises that we're going on at the moment is through the Food and Nutrition Security and Sustainable Agriculture Program, which is supporting a transfer of know-how and knowledge and experience on what we've done in Europe with the Lucas soil methodology to the African context and building up a decent in situ data set. Now that in turn will then be combined with other Earth observation data sets for all sorts of different applications, not just for directly soils related one. One example is here from the World Atlas of Desertification, where we layer information on soils with other information on things like vegetation productivity, which come directly from the Sentinel-3 satellites that we heard about in the previous session, or tree loss, forest cover change, or built up area change. And this is another area where we've been working very hard at using Earth observation to create real evidence. And basically building up a data set, building by building, mapped using satellite imagery, we can create a database where those buildings are concatenated into urban areas, into cities, and then the JRC and its partners make these data available. So they're made available to other people. And that's the significant message there as well. Now, those data can then be combined in other data sets and with other information. So as the urban areas expand, that puts not just pressure on the land for houses and roads and things where you do the soil sealing, the land sealing. It's also extra demand for agri-food land to produce agricultural food and biofuels and so on. Energy production is a big key area in the Africa Union, where wood fuel plays a very important part in the energy mix. And so all of this is putting pressure also on protected areas and biodiversity. So we're using the Earth observation to monitor the changes and the pressures and the threats on national parks. And again, in the spirit of transparency and data sharing, make this data available broadly. Nowhere is this sort of layering of information seen more acutely than in something called the WEFE nexus, which is the water, energy, food, and ecosystem nexus, bringing together those different components. And we've been working for a number of years with a network of center of excellences across the African Union on building big data sets, pulling together all different elements of land cover change, hydrology, urban development, and so on. And these are produced in very rich map form and report form, but there's also a near real-time element to it as well. If we move to another big catchment area, to the Nile, we can look at change on a near daily basis. This was the situation at the headwaters of the Grand Renaissance Dam in May of last year, and step forward to May of this year, and you can see how the Earth observation is providing us with very accurate measurements of change. Now, obviously there's land cover change there, but there's also energy production change as well. So you have to look at the big picture there. The point about that is not that we're looking at the change of the Grand Renaissance Dam specifically. We're looking at that data set for the whole of the African Union, the whole of the European Union, and in fact, globally. So again, these data sets can be used for sharing in terms of reporting on local, national, continental, and even global scale issues. It goes beyond data sharing to actually sharing infrastructure. And right at the beginning, I mentioned Puma, Amis, Mesa, that series of projects that we've worked together with the AU. And part of that has actually been installing infrastructure and working with partners across the continent in actually developing the applications, working out what it is specifically in the land domain that we need to address with the new technologies that we have. And then the final bit of the story is not just sharing data and sharing infrastructure, but also sharing research. And this is brand new results from our colleague, Ben Kurtz from ESA. He only gave me these yesterday. And they've been conducting a survey in terms of research, relationships and demands and priorities, and have some very interesting results coming about where we have detailed information on where African scientists and European scientists are working together and where they're not. So we can see where there's very little connection today. And this provides us with information on how to move forward in terms of building what is a very rich past catalogue and taking that forward. So to conclude, in the old model, there's an English expression, you can't see the wood for the trees, but in fact, with the high resolution data, you can see the trees and the woods, rivers and lakes, individual buildings and cities. And in Europe, we're even linking this into smartphone geotagged photography where you can see individual plants and things. And I think the 3 pointers for the future are cartography is important, but we can now go forward and start looking at state and condition and behavior, looking at behavior as well as the state and condition, sort of traditional mapping. If you want, devote more time to time. And what all this means is that we have new power in terms of transparency, in terms of land governance. How is that 1 hectare per person really going to be used? And can we actually even look at compliance and assurance systems in future in terms of land governance? And then all of these new levels of data availability and processing power and sharing infrastructure and the growing networks there, both bilaterally and through things like AfriGeos and GeoGlam, are really allowing us to use this new technology, just as the previous session said, to address new problems and new issues. And I don't think there's ever been a more exciting time for the African Union and the European Union to use Earth observation. So AU, EU, and EU, let's move forward. So that's my introduction. And now Catherine's going to dive a little bit deeper in one of the subjects. So I'll stop there. Thank you.
Thank you, Alan. And Catherine, please go ahead straight away if you can share your screen.
I'm sharing now. Going to presenter mode. Let me know when you can see my slides. Is that good?
Yes, Catherine, we see your notes as well on top. I don't know if that's intentional or not.
Sorry.
Okay, that's fine. That's fine.
Perfect. So I'm really glad to be here because being able to link the policy context, I guess, for tomorrow, as well as with what's going on in terms of availability, presents an opportunity to kind of just talk about like what's actually happening in the space in terms of agriculture and food security, which will be the focus of my work under the GeoGlam, the Group on Earth Observations Global Agriculture Monitoring Initiative umbrella. And so I guess we all know this, and previous speakers have spoken about this. Food security is critical. It's important. It's probably one of the most pressing issues for a lot of sub-Saharan African countries. And there are quite a few things that we can do a lot better with where the technology is. And I'll dive into that a little bit and then talk about some of the challenges as to why we're not, where we should be. Just to give an example of how incredibly challenging and complex and more challenging things will get. This is just an example from 2019 that you have one climatic extreme impacting everything, including agriculture specifically. So you have one thing after another. What is events like, for example, Cyclone Idai that are devastating. This is a really good example from 2019. When this happened in Southern Africa, consequently in Eastern Africa, we had moisture pulled out of Eastern Africa. And while there was flooding and people needing shelter, people in East Africa who had planted their crops basically failed for parts of Kenya, for example. And we can monitor all of this from space. So we can look at damage extent of the cyclone, as well as understand the severity of drought in Eastern Africa. So you have all this water, for example, in Southern Africa, but impacting Eastern Africa. And so it just kind of means that there's this interconnectedness, and one thing affecting one part of the continent can lead to something else in another part of the continent. And we have to keep our eyes open, and satellite Earth observations offer the opportunity to do that. This is just an example of how severe the drought was in Eastern Africa after the cyclones in Southern Africa. There are efforts to monitor this across the continent and at scale. This map here in the middle, it's all these products are from 2019, kind of paying attention to what's happening with crop conditions on the continent. So we have around July, we have extreme, poor conditions that in the end end up leading to crop failure, for example, in Kenya. And the GeoGlam Crop Monitor Early Warning work has a group of individuals, experts who are using Earth observations to track crop conditions. And every month produce a report, and this report can have this type of insight about what's actually happening. And this is only possible because we have satellite data. So some of the reasons why there's potentially little progress and in terms of monitoring, for example, smallholder agriculture, is that in itself the system is really complex. So we have very small fields that require very detailed resolution data. We have lots of mixers that make it challenging to use satellite Earth observations. And so even with all the systems that we have, there's still incredible challenges, as well as other things that are not actually related to the data, the methods, and or where the tools are. And so with those systems, we can monitor any system. An example here is a smallholder system, an irrigated system, and larger scale agriculture. And so even though we can get those insights, monitoring smallholder agriculture is incredibly challenging. For example, being able to collect sufficient ground data to be able to model and provide information on crop yield, crop productivity is still not that easy. And so this slide here is just kind of summarizing like some of the challenges, not only having robust methods that are scalable for the complicated agriculture context. There's a huge gap in training data. Sometimes we need very much higher resolution data that's openly available. The limited use case and user-driven systems. So if an organization or a country wanted to do something specific, you need to develop a system to do that specific task, for example, sometimes. And then there's limited access to baseline data sets. But within institutions, from my experience working in Eastern Africa and a little bit in West Africa, there are legacy systems, as in the way things have been done, and there's very little adoption in some cases. There's limited requisite technical capacity in some cases. There are computing infrastructure and the investments that are required to get access to those computing infrastructure are not sufficient to be able to tap into all the massive data sets that we have access to now. In terms of policy frameworks that enable, so if we have products and information coming out of satellite data, the policy frameworks to enable actually, changing things or doing or implementing things that can support farmers are limited, and or sometimes they don't align. I'm just going to share some examples of some of the work under the GeoGlam initiative that are working towards addressing some of those gaps. So I did mention the crop model for early warning, which focuses on producing information on countries that are at risk of food insecurity. There's one for AMIS that focuses on countries that are bigger producers. So understanding both where there's limited production and then also where there's a bumper, higher production that can help, can enable stabilize markets is important, which is why these two systems are complementary. But the approach and the methods, as well as the framework of generating this information, has been successfully adopted in Eastern Africa with the IGAD Climate Predictions and Application Center. And we have national bulletins that use the same framework in Mali, in Tanzania, and Uganda, Kenya, Rwanda, as well as one is being developed for Ethiopia. We're doing a lot of capacity building, so training through regional organizations, working with ministries of agriculture, working with food security divisions, and ensuring that people can access those tools and methods and data that are readily available, as well as create interest in whatever might come available. In terms of systems, there's data. I think Alan has shown some of this, where you can go and make analyses, and they're really, really important because it means that you don't necessarily sometimes need in-house infrastructure, but can leverage what is existing. And also trying to address data gaps. Different partners within GeoGlam are developing underlying products like crop masks, crop type masks, conditions models, as well as yield models. And then my last slide is through a partnership with the UNFCCC, we're working to support the integration of Earth observations for agriculture and food security warning as part of the frameworks for countries developing their national adaptation plans. And of course, all of this is possible because of partnership. And I think this is really critical in terms of moving forward, leveraging what exists, leveraging what will exist, and building on what will exist together. I think that's my last slide. Thank you.
Okay, thank you very much both to Alan and Catherine then. I think those were very exhaustive presentations, covered many different areas and from many different points of view as well, both kind of scientific, the interface to policy, but also starting to look at kind of even some programmatic implications of this. I think I'm looking, I don't see any raised hands. So again, if anyone would like to make an intervention, please indicate this. I'm just going to start. I'll ask a quick question to Alan. Alan, on the last slide, you did refer to the fact that for some of the application areas, we're actually looking at combining Earth observation with other space-based technologies and capabilities, such as geopositioning. Can you perhaps expand a bit on this, on where you see areas of application that are not making use of just of Earth observation, but Earth observation together with other space-based technologies? Thanks.
Yeah, sure. I think actually Catherine showed a picture of two folks in the field with one with a tablet and one with a smartphone. And it's about linking those technologies. And actually, I can see some questions in the chat that sort of raise this issue as well, of how do we actually get this information that we gather with the satellites down to the level of the individual farmer, whether it's a yield estimation or whether it's something to do with. There are two aspects of it, I think. One is communicating directly information to farmers, and the other is more at a sort of governmental level. And we're working on both of those in the European context, where we're linking the Earth observation to, we call it geotagged imagery. So this is when you're in the field with your smartphone, if you use a system like GPS or Galileo, then you could link up the Copernicus program and the Galileo program, which is what we're trying to do in the European context, so that you can actually get assured, verified, fit for purpose photographs taken with a smartphone and link those directly to a satellite image. And this helps when you're talking about verification of, let's say the terms in which land use of a particular area is granted. So transparency in terms of land governance. So that's at a sort of governmental level. But I think there is the second level, which is this could also be reversed, and you can use it to get information directly into the hands of the farmer. And for me, this coupling of the two elements of space program is something that we've not explored as much as we can yet for the land management issues in EU and AU.
Thanks, Alan. Thanks, Alan, for that. And maybe I think that addresses as well the question that we had from the colleague in DLR to some extent. Maybe, Catherine, if you can address in a bit more detail this question on and maybe it's linked to what Alan's just said, but on how we really kind of address this kind of smallholder scale of farming through Earth observation. And Alan, I don't know if this is possible, but in parallel to that, there's a colleague who is asking if you can put back up the before and after image for Ethiopia that you showed. I don't know if you can do that while Catherine's responding, but we'll try maybe. But Catherine, go ahead if you could address this issue of really how we focus attention on the needs, let's say, of small scale farming. Thanks.
I think they're very critical information products that can come out of, analyzing satellite imagery that can inform, very broad policies, but as well as are useful for private sector service providers. And so if a person, if a company was trying to map out the market for where could farmers potentially increase their productivity through improved access to fertilizer. If you go backward, for example, we could map cropland, we could map crop type. We could develop models to kind of look at spatially disaggregated yield, which can inform, what areas are not doing great for a specific crop. Of course, it's challenging because sometimes, there are mixed crops and stuff like that. But if you had sufficient information, by doing this, you can identify why some farmers are not doing great. And you can then try to identify why they maybe don't have access to inputs that other farmers do. Is it the cost? Is it just accessibility, as in the suppliers are too far away? And so you can see how if I was a bundled service provider, this would be a potential market for me, which then, if I set up my shop within close proximity to those farmers that don't have this information and did a really good job at, disseminating knowledge on how others are performing and doing training, you can see how potentially, and it being a bundled service, then, farmers can access potentially better seeds, access to fertilizer, information, as well as potentially a market. So if I'm a bundled service provider, I could provide the market for the farmer to buy, I would buy their produce and sell it at a much better price. And so they're linkages, but there are multiple layers of information. So it's not just about the map products, it goes beyond that. And that's, I guess, the point I was trying to make about the policy frameworks, that if we identify that fertilizer is the missing thing in terms of increasing productivity, then what needs to be done for actually action for that to change? So, government funding things in that particular geographic area, and stuff like that.
Okay, thank you very much, Catherine, for that. Alan, maybe if you can be putting that image up again from your slides on Ethiopia. There are a couple of other fairly punctual questions in the chat on what structures you're involved with in Mali and on GNSS receiver capability. So maybe after this session, Catherine and Alan can respond to those in the chat. Alan, are you able to put your slides back up just for a minute?
No, I could, but I'm not going to because it will mess up the rhythm of the thing. But Joshua, okay. What I would say, Joshua, is that there are two things here. One is the Copernicus DIAS. If you find that on the web somewhere, you'll be able to go there and get access to the Sentinel-2 imagery that I used to show that change. It's all available through these systems. Or alternatively, you can go to the Global Surface Water Explorer, which was the data set I showed underneath it, which again is open to everyone. And that gives you a full record of change from 1984 to today, well, to the end of 2020, actually. We do it every day, but it's updated once a year to provide month-by-month changes in water everywhere in the world. So that's about data transparency and data access. I'll leave it there.
Okay, thanks, Alan. There's a question from Bill Hosak on what types of policy changes are in process to link new actionable data to improving access to capital and insurance. I don't know, Alan, is that something you can address? Bill, maybe would you like to make an oral intervention to provide a bit of context to that?
For the farmer, I think what it is that where we are right now is that with the Earth observation data flows that we've got, and as I said, the paradigm has changed now, where we've got so much data in a way and it's being processed in the cloud, that we can think of ways of beginning to address the sort of things that Bill has raised there. But you have to have a whole policy process behind it. I mean, in the European context, we've got more than 30 years now of using Earth observation in the Common Agricultural Policy as the basis for the decision-making process that we're involved in now. But I think, you know, that experience can be shared. And you can look forward to ways of using it. I don't know the answer to your question right now, Bill, in terms of what would be the actual policy change linked to capital and insurance, but it's to do with transparency and not just the data, but the knowledge derived from the data. What we're doing in Europe is going away from looking at images and looking at time. It was that point of devote more time to time, so you can actually look at what's going on in a field rather than trying to map the field, if you like.
Yeah, thanks. And I think as well, there's a dimension to that as well on the actual quality control. So it's not just transparency in the data itself, but also on the quality control that's been applied to the data, so that they become kind of some layer of confidence or level of confidence associated with the data products that are being used to derive information products. Okay, well, I thank Alan and Catherine very much for their interventions. I think that was provided a lot of breadth, but also some specific points on areas that I think we should follow through on as we think about what the future steps are in this collaboration. So I'd like to move now to the final kind of section, which is a bit longer, addressing kind of a fairly broad area of climate, disaster, and atmospheric applications. And we have kind of two subsections. We're going to go through each of these in one after the other, and then we'll take some questions at the very end of those four interventions. So I'd like to start by introducing another colleague at the Joint Research Center, Alessandra Zampieri. Alessandra is Deputy Director for Space Security and Migration Directorate at the JRC, and she's also the Head of Unit for Disaster Risk Management. After Alessandra, we will hear straight away from Dr. Gani Agbai, who is the Executive Director for the Center for Space Science and Technology Education. So first of all, I'll pass to Alessandra. Alessandra, the floor is yours.
Thank you very much, Mark, and good morning, colleagues. I hope that my slides are coming up on the screen.
Yes, they're up, Alessandra. Not in presentation yet. Yes, that's fine.
In presentation. Thank you very much. Well, climate change and the extreme events caused by climate change are systematically on top of citizens' preoccupation in all the most important surveys. And very rightly so, because climate change is hitting hard, it's hitting fast, and it is hitting non-traditional areas. We have all been shocked by fires in the Arctic or drought in northern region, in northern countries in Europe, for example. And it's not only the tragic consequences on human lives and human properties or the environment that should worry us. It's also, like a recent study by the Commission, the World Bank has proved, a study launched this week, it's also the impact on public finances which should worry all policymakers. In fact, it has been proved that just one big hazard, one big disaster like a big floods or a big earthquake or a big volcano erupting can put a big threat to the public finances of one country, leading to bankruptcy or the need to get funds from outside sources. So there are a lot of reasons why climate change has been worrying policymakers, and a lot of things have been done in policy terms, in scientific terms. Today we are here to understand if Earth observation can provide an answer and a solution to this issue. And all of you are all experts, you know that images from the sky cannot be the solution to this, but they play an enormous role in monitoring the situation. And this leads to understanding, because through the models, to the analysis of these images, and the combination with other data, the application of artificial intelligence, we move from the monitoring of the Earth to understanding of the phenomenon, and then to take actions, because in the end, this is what counts, and actions to be fast, and it has to be very impactful, because as I said, things are changing very quickly. With this in mind, we now move to see the key thematic challenges, first of all, linked to climate change, disasters, and the role of Earth observation. And if we apply this specifically to the African continent, one of the first things we have to take into consideration is really the fast population growth in urban areas in Africa. Cities in Africa accounted the highest annual population growth rates in the globe, exceeding 3% a year between 2000 and 2015. This data comes from Earth observations analyzed by our scientists here at Joint Research Center in the framework of the Global Human Settlement Layer. These data are freely available and are used by many countries to monitor and understand how this phenomenon is evolving. From this map that is extracted from the Atlas of the Human Planet 2018, just by the colors, you can see how Africa is the continent which experienced the fastest urbanization in the globe. In fact, Africa has increased its urban population from 631 million people in the 90s to 1.2 billion in 25 years later. And this is, of course, most of the democratic change has taken place in urban areas. And by the way, we are collaborating with the two African countries to help them assess the growth of their population, Guinea-Bissau and Kenya, through this method of the global human settlement layer, which allows overcoming the limitations of other source data that cannot be updated as quickly as Earth observation. Well, the fast population growth and often not well-planned or totally unplanned urbanization lead to an increase of the disaster risk, because people are settling in disaster-prone areas without really mitigation measures. And the change of climate exacerbates the situation with an increased occurrence of extreme events. For example, flood is the natural hazard exposing the highest number of countries worldwide. People exposure to flood increased between the 1990 and 2015 across all Africa by more of 10%. In 17 countries, the population exposed to floods has more than doubled. And in several of these countries, the population exposed, living in exposed areas has increased more than the one in not exposed areas. This is, first of all, the case, for example, for the Republic of Congo, Cote d'Ivoire, and Kenya. In almost half of the urban centers in Africa, the precipitation declined, and in the same period, and the temperature raised. And in urban centers where precipitation declined and temperature increased, the population grew on average by 40%. So it is very clear that the combination of these two factors, climate change and fast urbanization, expose population to higher risk in Africa. What can we do? What can Earth observation do to help in this field? There are certainly gaps. These are mainly scientific technological gaps, and they're really linked to the collection of information in a harmonized manner for climate observation, but also the natural and the built environment. And there is therefore a need for such information collected in a better manner for better decision making. Also, in the field of crisis management, there is need for better monitoring of natural hazards, but also of outbreaks, health issues, malaria, meningitis, locust outbreaks. So monitoring has to be improved. But we can be confident that the scientists and science go very fast in this field, will address all these gaps, and there will be quick improvement. Let's therefore concentrate more on what exists already and what can be used. Here you can see the Copernicus Emergency Management Service, which is, as you know very well, a service offered by the European finance and offered by the European Commission, and specifically for this management services, it is run here at the Joint Research Center. And it is a service which is offered not only for Europe, but it has global components like the components GLOFAS for floods, a GDO for droughts, or GWIS for the forest fires that are openly available to worldwide and to all authorities. With these two services, which are on-demand mapping and early warning and monitoring services. And there is a new component which will become a part of the family very soon. The global human settlement layer I mentioned before will enter into as a component of this service this year or in the beginning of next year. These services, as I said, are free and open and available to the whole world. And we will not do it for other areas of the world, but we can help other areas of the world to build their own capacity. And this is, for example, something we are doing with the countries in Latin America. We are helping countries in Latin America to monitor and build a system for fire monitoring and actions and early warning in the Amazon region with our help to replicate, with the use of this system, to replicate the same system, and the same can be done easily for Africa. I said before that the Earth observation can help us monitor, understand, and take action. And let's see, therefore, two examples of action that has been taken or can be taken and can be go further. These are also two very good examples of concrete use of Earth observation. And I'm particularly happy to say of African-EU cooperation to highlight priorities for thematic operational and research dimension. This first example that you see in this slide address the Earth observation support to produce clear energy. And we heard already this is really a top priority for Africa. Colleagues in the JRC use Earth observation and open source data to analyze the electricity access of more than 100,000 health clinics in rural sub-Saharan Africa. The satellite data was used to identify from nightlights which clinics already had access to electricity, location-specific solar radiation data to plan mini-grid systems, and also to estimate the population served via global human settlement layer data, again, using this data set. Another very interesting example is this collaboration of the European Commission, the Joint Research Center, with the Intergovernmental Authority on Development in Eastern Africa. And with this collaboration, we are developing a drought observatory for East Africa. And drought is one of the main worrying hazards for the whole world. And by the way, next week, we will launch together with UNDRR the GAR report on droughts, which will say and will issue recommendations on how to tackle these major hazards globally and worldwide. Based on the experience that we have gained here in the European Global Drought Observatory in the Copernicus Emerging Management System I mentioned before, this drought watch is implemented in Nairobi by HIDAC, and it's take special care for the adaptation of methods used in Europe to the African reality. To conclude, I would like to highlight these thematic priorities that, in our opinion, should be addressed, and they are operational and they are scientific. Operational, there is the need to build the capacity building, and all these examples I mentioned before show that there are already a lot going on, but probably we need to start at the earlier stage. We have to start at the stage of universities and institutions to really build an independent knowledge base to the ability to use free and open data, methods, and tools. And also, this can help teach how to develop services, because action comes with the operation of these services through take-up of free and open Copernicus information, also at the national, regional, emergency cooperation centers. Scientifically, artificial intelligence can do much more to help us in Europe, in Africa, and all over the world to analyze and use this data and develop also better models to do it. And also we have to work more on the weather, climate, population data to disease, to address disease outbreaks. Let me conclude by adding one point, which is not mentioned in this slide, which is really the engagement of public authorities in addressing more climate change induced disasters, because this can really have a big impact on the development of the countries, on GDP, and the ability of growth in financial and human terms. And with this, I'll pass the floor to you, Mark, or to my fantastic co-speaker, Ganji, who also has very interesting messages.
Thank you very much, Alessandra, for that. Very comprehensive, and I think it clearly underlines it's not just about sharing data, but it's also about kind of sharing the experience in implementing these tailored services for different regions. I mean, I think we could even think of some type of almost like a twinning program between the capacity that we've built in Europe with the corresponding services really being sustained to address policy and decision making in other regions, and in particular in Africa. So I'd like now to pass to the second intervention in this, who I introduced before, Dr. Agbai. Ganyi, if you can make your intervention, thanks.
Yeah, thank you very much. Still waiting for the, yeah. Thank you. The slide is yet to come up. Right.
Yes, I can see it.
Okay. Let's move to the next one. I try to put Africa in context. Africa, as we all know, is the second largest continent in the world. 15% of the world total population is African. And by the year 2050, it's been projected that it will be about 2 billion. And it's the second driest continent in the world. Well, something is being done right. When I check the average life expectancy now, it's 62 for male and 65 for female. When I compare that to 2004, it's 45.8 years on average. Looks something has been done right somewhere. In terms of developmental challenges, we have the basic necessities of life, which is about food, shelter, clean water, health and environment, healthy environment. These are all necessary, being used using Earth observation to solve most of this problem, combating disasters, diseases, population growth, employment challenges. There's massive insecurity, immigration. I say we are not starting from level 0 as far as the Africa and Europe collaboration in terms of the use of Earth observation data. Going back to 2001, PUMA, they've gone into MSD, MESA, and now GMS in Africa. And there are so many other initiatives in between. But what I want to bring up here is what are the lessons learned from the analysis of the output of these projects and interventions using Earth observation data to address African challenges. If we are moving forward, we need to have all this in mind and able to do it better. Right. Leveraging from the Agenda 2063, the Africa we want, it is clear from that the basic statement there is the shared strategy framework for inclusive growth and sustainable development and a global strategy to optimize the use of African resources for the benefit of all Africans. We can link this to one of the flagship projects of that document, which is about outer space, to develop its technological capabilities and to exploit outer space to defend its economy, security, and other interests. Under the aspirations, we see that Aspiration 1 is about a prosperous Africa based on inclusive growth and sustainable development, and the goals that relate to climate change and disaster is about environmentally sustainable, climate resilient economies and communities. And the priorities are clear there, with about having sustainable consumption and production of patterns, water security, climate resilience, and natural disasters preparedness and prevention. All these have solution in the space Earth observation data if used optimally. There are so many overlapping agendas which need to be put into consideration when we're moving forward with collaboration with Europe. We have the Agenda 2063, which I've mentioned, the SDGs 2030. We have the high fives of the African Development Bank. We have so many other initiatives. So many of these initiatives overlap each other. Well, all this needs to be embedded, integrated together. We also have to look into the African space policy, the African space strategy, so that what is being proposed will really fit into what is on ground or what has been proposed to be implemented in the whole continent. Well, I use this particular project, the multi-scale flood monitoring and assessment services for West Africa, which is a project being funded by the European Union and in collaboration with the AUC. This is a unique project in the sense that Africans are leading it within this West African sub-region, and made up of 7 institutions and 5 West African countries. This project is unique in the sense that it is a product and service program, so that mandated agencies on flood emergencies are really being asked to actually chunk out services and products. And the users or the beneficiaries are actually the DMOs, the disaster management organizations, and the local people. They have direct access to these service. An updatable flood event database is already created across the region so that we can do it in a similar way across the region. Flood forecasting assessment system is already in place, and the geoportal is about to be ready now. Image acquisition processing and analysis system is already in place. We can say that most of the data used or more than 90% of the data used are from the Copernicus platform. The damage assessment module is also on. This means that and a lot of capacity building was also involved. This gives access to the common man with regards to what is going to happen with flood disaster. There's a flood reporter which has been created. If there's an incident going on, you can take a flood reporter, take a snap, and it will be downloaded to the database in which further analysis can be carried on with flood forecast and flood forecast now. Now, the center in which I am the head, we are mainly busy with education, capacity building, postgraduate diploma program, and the master's program. Major intention is to develop through in-depth education indigenous capability in the core areas of space science and technology. I'd like to recommend that when it comes to capacity building, we need to develop competencies in order to efficiently respond to the societal need, which we believe Earth observation will go a long way in doing this. Then we need to demystify space, Earth observation data utilization, make it simple. We can go through this by intervention in the school's curricula, at the secondary school level, undergraduate level, especially for our young ones who are internet savvy. We need to give them, we need to allow them to play around with this data, and they will definitely do wonders with it. Awareness and sensitization is about domestication. The project we carried out is really to intervene in the way things are done in those ministries or agencies of government. Mandated agencies, decision makers, on how to utilize the developed best practice procedure for Earth observation intervention. Innovative approaches and partnership. That's the major goal in the SDG, or Goal 17. So in order to create a world where decision, well, when we look at the past intention of using Earth observation, it's meant to create a world where decision and actions are informed by coordinated, comprehensive, and sustained Earth observation, which is what the collaboration with Africa and EU is also aimed on. So we need to leverage on lessons learned from existing and past initiatives on space EO solution. We need to try to have global access to data, software for teaching and research purpose. The regional centers like our own academic and research institution as major mode should be the major nodes for incubation of best practice and capacity building. Internship and secondment exchange of staff, long-term and short-term solution. Urban areas and rural areas, you find that there's a lot of pressure on the urban areas. Those are areas we need immediate or short-term solution. The long-term solution are meant to be for the rural areas. With the pressure on the urban facilities is becoming high, and the urban areas may not be able to sustain this, so they also need to have a long-term planning to combat migration to cities. So there's need for transition from project-based to sustainable delivery of products and services for beneficiaries to build on, as is in the case of the Miss Mars projects, which I just presented. In conclusion, I'd like to call the cooperation in space knowledge generation and sharing, as well as in skill development, is now the norm rather than the exception for countries in a region that share mutual borders and face common challenges, as is the case in Africa. Africa is also close to Europe. Wherever it's happening in Europe, we affect, in Africa, we affect Europe. And that is very glaring from migration, which we are seeing. So if Africa is made to know how to best use EO data to take care and plan the environment very well, I think we'll see less of that. There's a need to engage in knowledge development and competence building to be relevant internationally and benefit from the global infrastructure on space EO solution to society challenges, and in order to gain access to common knowledge and experience. With access to the common knowledge and experience in EO solution, Africa will be able to contribute to solving global challenges like climate change through global partnership, collective effort, and personal endeavors. So thank you very much.
Thank you very much, Gany. That was good. And I think already you provide in your recommendations and conclusions material that we can extract directly as we're thinking about how to summarize many of our discussions today. I think as well your emphasis on the need of kind of building this as an integral part of the curricula in education is fundamental, as is this idea of transitioning from kind of a research project-based approach to sustained delivery of products and services. So thank you very much for your summary and also the kind of critical points you raised. So I'd like to move now to the last two interventions in this session. This from two colleagues addressing atmospheric issues, Pascal Moudi from the Centre d'application de prévision climatologique de l'Afrique centrale, and Federico Fieli, who is an atmospheric composition expert at UMETSAT. So I believe they have a joint presentation, and Federico is already sharing the slides. So the floor, I believe, first goes to Pascal. Go ahead.
Thank you very much, Mr. Moderator. Thank you to all participants. So our presentation is about atmospheric research for weather, climate, forecasting, and environment in Africa. Regarding the background of our presentation, we can quickly see that. Next slide, please, Federico.
Yeah, do you see my slide?
It's already been advanced. Pascal, yeah. We're already on background.
So African population, as you see, is the most vulnerable to climate change, variability and impact, especially in the least developing countries, as you can see in the map. So the sub-Saharan countries are really exposed to climate change. So we also have insufficient research. It's a major independent to growth development and advancement socio-economic development in Africa. So we can see that Africa produces less than 1% of the global research output. That is really critical. So addressing the barriers to conducting research in Africa is a step towards improving research capacity and output in the region. And regarding the different research area in atmospheric physics in the region. So as we are really exposed to climate change and variability, so model output needs to be really adapted to our reality. So data assimilation is one of the main challenges in Africa. So we need to do this data assimilation in order to improve the input, the initial condition of models. Air pollution chemistry and aerosol cloud interaction that also have some retraction with the climate variability. As in Africa, most of the rainfall is from convective mesoscale systems. So we need also to do small scale processes in the atmosphere. So doing physics parameterization in models. The main aims we need also in weather prediction and remote sensing for meteorology and climate application, and looking also to interaction of scale in climate simulation in order to do downscaling. And most importantly, regarding we need to have extreme events as our priority. Next. So some research projects have been undertaken in Africa. So past and current Europe-Africa Research and Development Network. So we have the DAKIVA project that investigates the processes controlling air pollution and atmospheric composition in weather and climate in Southern West Africa that influence the health. We also have the AMA project that was improving our ability to predict the Western and the West Africa monsoon and its impact on the intra-seasonal decadal timescale. And also the SWIFT project that aim to develop a sustainable research capability in tropical weather forecasting to enhance the livelihood of African population and improve economic development. So regarding the capacity development initiative, we have also the CLIMSA project that is ongoing now. We got the Sawidra project and the Puma, AMSD, and the GMS Africa that are leading to develop the capacity in regional climate center and national meteorological services in Africa. Regarding the Codex Africa, we have a group working in Central Africa region that got some research output regarding the influence of the weather station. So expected warming in Central Africa will range between 1.5 degrees and 2 degrees according to the Paris Agreement of Climate Change. So it is also critical for the region globally in Africa, meaning that the region will really impacted by global warming, and extreme event will be more frequent in that region. So the research development needed to improve operational products from regional climate center to decision makers are in various fields regarding aviation to agriculture, energy, integrated water resource management, and also emergency responses. So in the regional climate centers, we are having some products that are developed in ICPAC regarding the probabilistic forecast for drought monitoring. We also have some projects that are developed at AgriMed, AgMat, and the SADC and also at the CPC here in Central Africa. So all those projects are developed in order to monitor the impact of weather and climate changes in the region. So we need the support of research in order to improve the quality of this project in order to reduce vulnerabilities and impact.
Okay, thank you very much. I take now the ball. Pascal has already introduced the question of air quality. That is one important issue. I come from EUMETSAT, as has been said, and our colleague Haley has already presented what EUMETSAT is. So I just go quick to bring you with one point. So air quality is an issue in Africa, and these are data from the World Health Organization, and this is the level of the particulate matter that to which the population are exposed, and we see that the whole African continent is one of the most risk area, and that this goes, of course, together with the climate vulnerability. We have discussed and we have seen many times around during this morning discussion about the demographic and also the change of the demographic distribution with a much more urban population. And what we see here in this slide is how it is expected for the emissions, for the anthropogenic emissions to increase during the next years. So we really see a strong increase that goes up to 5 times more with respect to 2005 up to 2030, especially in the urban area, and for the species that are related to the anthropogenic activities, traffic, and to the burning. One important message that we got from the research projects, for instance, Pascal has mentioned the CHIWA, and one of the feedback from the CHIWA, and that this is part of a policy finding outcome, is that the uncertainty on the emissions that are key, for instance, both for the evaluation of the impacts and also for the evaluation of the evolution of climate and of air quality, are absolutely underestimated. This is an example of what is produced by road transport. That is, almost 50 times larger than the estimation that are used in the typical emission scenario. And this is why there is a lack of monitoring capability. In this map that comes from the UNICEF, are shown the maps in green, the points where air quality is measured with the station, and you clearly see a great imbalance between the coverage in Europe and the coverage in Africa. But in yellow is the fraction of the more younger population that is strongly exposed to the better quality. And I mean, a satellite can come to help and provide a support in the observations. These are two examples. The first one from nitrogen dioxide from a Copernicus Sentinel-5P. And we do observe that the satellite can give information on the total tropospheric column of this pollutant that is produced both in traffic but also in fire. We see the signature of fire in Congo. And also interestingly, with satellite, we can monitor other species that are much less difficult to observe from the ground, like ammonia. And ammonia is more related to cattle and to agricultural practice. And we do see that there is a hotspot of emission of ammonia in the region of West Africa and all the West African belt up to Sudan. And this is due to the intensive farming activities. This is even comparable to what happens in India, China, and in the most polluted area in Europe. I just give you an idea very quickly on what are the current and upcoming programs on EUMETSAT. The basic story is that EUMETSAT, that implements also the Copernicus program, is and will do much more, a lot for the atmospheric composition and atmospheric physics studies and analysis, like the one that we have presented, with a series of satellites with different generations, both on geostationary and on polar orbit. Do not hesitate to contact us to have additional elements. And I then leave you with the last slide that are the concluding remarks and some elements on the way forward that we have put up with Pascal. I don't know, Pascal, if you want to add a few words on this, or we want to have share at the final say.
Yeah, so as concluding remarks, we can quickly say that long-term homogeneous and reliable observation are needed for environmental, weather, and a longer-term climate monitoring in Africa. So we need to improve forecast. So Earth observation will help designing model conditions and then improve our understanding of climate and weather processes. So the sustainability of information data also are needed. So we need science support for quality monitoring and modeling, and the support for operational methodologies in order to improve the quality of forecast. And also partnerships, coordination, technology and support are needed, and the appropriate capacity building for African, knowing that technology are new and people are missing, are lacking capacities to monitor that equipment. So new satellite mission, as maybe you can conclude for that?
Yeah, absolutely. Yeah, thanks. I mean, we have already shown what is coming next. It is worth to mention as example the Meteosat third generation that will encompass air quality, composition, weather process, and also the continuous capability to increase the climate monitoring for weather phenomena. I don't take additional time. We are very late. Thank you.
Thank you very much to Pascal and Federico. I actually think everyone has been very good in keeping to time, so we're just slightly over, but I think that we've done very well. I know that some of the colleagues have been answering to questions in the chat, so I'm grateful for that, and I'm sure you can follow up offline with people. Maybe just one parting question. I was happy, by the way, to see Pascal mention the CLIMSAR project, which is a new project, which I think not only is addressing climate services, but also through a different model, really giving the competences to the regional climate centers as far as implementation. In Alessandra's concluding slide, she made the remark at the end of a kind of a common interest is really this shared engagement with the relevant authorities and how to better engage with them. And I'm wondering if there are models that we should be thinking of on research cooperation, on kind of programmatic cooperation on delivering products and services that are not currently being addressed. And if anyone has any final remarks on that, so kind of new models for kind of programmatic cooperation that you see emerging and that we could consider. Just a very quick remark from someone would be helpful on that. Thanks.
Well, thank you very much, Mark. Thank you to all panelists on this first session. So Mark Dole, thank you very much for being our moderator. We had with us also Miguel Bayo as the rapporteur of this session. I would just like to highlight one aspect for logistics. For those who are online, you could see that you have a translation service for French and also Portuguese. For those here in the room, you can also use if you'd like to. And I'd like to thank our translators to be here. They are doing a great job today, so thank you very much. I think now we will close this session and we'll have a 15 minutes coffee break. So thank you very much, everyone. I'll see you in 15 minutes. Thank you, Mark.
Good morning. Good morning, delegates. Good afternoon, depending on where you are. I think we can now start. It's time to start session 2. I don't know if the chair is around. Hopefully we can proceed, considering time. Yeah, my name is Joy Wasambo. I'm the project coordinator for the CLIMSA project here at African Union Commission. I'll be your moderator for session 2, which looks at GMS, which looks at Earth observation for evidence-based decision making. My colleague Michelle Massad from DG DEFIS will be...
Dear Dr. Joey, I'm sorry, it's from the organization. Can I ask you to please wait a bit because we are still on coffee break since there was a delay in session 1. So can we please wait a few minutes? I will get everyone in the room and we will warn you when we start, okay? I'm sorry, thank you.
Okay, that's okay, because I was looking at 15 minutes that the chair gave us all has expired. So wait for the chair, then once it's ready, let me know so we can start the session.
So welcome back, everyone. Good morning once again. I think we are now live. Yes, I can see myself. So good morning. Again, we are now starting the session 2. I'm sorry for this short delay. The session 2 will be about Earth observation for evidence-based decision-making. For this session, we'll have Jolie Wasambo, coordinator of CLIMSA, as our moderator, and we'll have also Michel Massart from DG DEFIS, that will be our rapporteur. So without further ado, I'll give the floor to Jolie Wasambo. I think you're online, so the floor is yours. Thank you very much.
Thank you, Chair. I literally started the meeting 5 minutes ago in your absence, but now we're back. Colleagues, as I said, this session 2 looks at Earth observation for evidence-based decision-making. What we're looking at is the provision of concrete examples on the applications developed in Earth observation as well as success stories, and also looking at services in the blue economy, climate change, agriculture and food security as examples that we can take from this session. So this session has 6 presentations. Each is being allocated 10 minutes, and we're already late we're behind our schedule by 10 minutes. So the 2 presenters in each session, you have to give yourselves time so that you don't go beyond your time, so that the sessions that are coming after us are not significantly affected. So how do we go along? First, I will take 3 presentations before questions and answers come in. So we have first 3 presentations. After those first 3 presentations, we have questions and answers. And then we finish with the remaining 3 presentations and questions and answers. Then we pass over to the chair. And now we're going straight to the first presentation, which will be made by 2 colleagues, Madam Catherine Giot and Dr. Tidiane Wata. Now I hand over the floor to Madam Catherine to make your presentation. The floor is yours, Madam. Thank you.
Thank you very much, Chair Jolie. Good morning all participants in Lisbon and online. I'm very happy to start this first session 2 on Earth observation for evidence-based decision-making. So my name is Catherine Guillot. I'm working in the European Commission in Brussels, and I'm in charge of science, technology, and innovation in the units dealing with regional and multi-country programs with Africa in DG International Partnership. So the purpose of my presentation today is to give you some elements of the policy framework and also to provide with the overall objective of the GMS and Africa program that we have already seen some part in the first session. I don't have a PowerPoint presentation, so I will just speak now before handing to Tidiane Ouattara for the Africa side of the presentation. So my presentation will be on 2 main points. So the first on the policy framework, and then on more on GMS in Africa. So for the policy framework, maybe first some elements at a global level. So we all know that science, technology, and in particular digital and space technologies are powerful drivers of sustainable and inclusive development. Space technologies have transformative potential to progress towards the achievement of the SDGs. And in particular, several UN conventions and agreements, such as the Paris Agreement or the Sendai Framework for Disaster Risk Reduction, make specific reference to scientific knowledge, including research, systematic observation of natural systems in a manner that informs data and services development and also supports decision-making processes. At a more European level, we also see that Earth observation is critical, both for the green and the digital partnerships that are also at the heart of the EU proposed strategy with Africa. And it's also an element of our programming for the future period 2021-2027. Maybe if we look more into the details, Earth observation is really seen as a game changer for the Green Deal. And as such, it has been included in the joint communication towards a comprehensive strategy with Africa. This document particularly highlights that space science and its application to Earth observation can play a fundamental role for African countries to achieve the SDGs, to boost economic growth and to increase resilience and adaptation to climate change. Africa and the EU face common opportunities and challenges in a time of global digital transformation leading to profound changes at economic, societal changes aspects. In another track, we have the just negotiated Africa Protocol of the Post-Cotonou Agreement that also confirms the importance of Earth observation. And this document includes a specific article on space and geospatial technology. If we look more at the future, we are at the moment drafting our regional programming for Sub-Saharan Africa for the period 2021-2027. And this draft programming also highlights the importance of space technologies and Earth observation, particularly under the science, technology and innovation and green transition priority areas. So this is the policy, some elements of the policy framework. But we know that this is already a reality on the ground based on the very long cooperation that we have between our continents. In particular, the Africa dimension of the Copernicus program on Earth observation is already a reality and is based on this bilateral agreement that was signed between the European Union and the African Union on exchange on Earth observation data. And we also have several concrete examples of Earth observation programs that we have already been mentioning in the previous session, and that we will look at them, like GMS in Africa, or the CLIMSA one on climate services, or the BioPAMA on protected areas. So maybe now we can look a little bit more into the GMS in Africa program. As I was saying, this program is the result of a long-term cooperation and commitment between African and European partners on Earth observation that started more than 15 years ago with different programs, PUMA, AMES, MESA, and now the GMS program. We are finishing the first phase of the GMS program and starting the second phase next year. And we are now preparing all this new phase. We believe that there's still a need to support coordinated implementation of policies deriving from Pan-African and international framework through the establishment of systems and development of capacities on African institutions. We have also
recording in progress.
We have also seen in this session one what was the challenges and the needs, and capacities is an important need that has to be complied with. So the overall objective of the GMS in Africa, the second phase, is to contribute to a more sustainable management of natural resources, and also to tackle climate change based on space science and technology application. The specific outcome that we expect from this program is that African organizations, policymakers, practitioners can make more effective use of Earth observation data to develop relevant operational information services at different levels, at national level, regional, and continental levels. The focus will be in particular on water and resource management, marine and coastal areas, based on the successful results of the first phase. The idea is really to focus on the information services value chain, from access to information, generation and provision of services, and engagement of capacity of users to ensure the use of these services. So to conclude, space and Earth observation data are important components of the digital and the green partnerships, which really are the heart of the EU proposed strategy with Africa and the just negotiated Africa Protocol of the Post-Cotonou Agreement. It's also part of our future programming, but we see also that we have to build on our partnerships are long partnerships between Africa and the EU based on these ongoing programs. And we look forward for a continued dynamic partnership with Africa. I now give the floor to Tidjane to give the perspective from the African side. Thank you.
Dr. Tidjane, you have the floor.
Thank you very much, Dr. Jolie. I think there is a short presentation I've shared with colleagues, if they can display that. Thank you very much. Thanks, Catherine, for your introduction on the why and how Africa and Europe are working together. Just, I would add, we are condemned to work together at the policy level. I would say Europe for Africa is the closest continent. Secondly, we are sharing historical facts. That means what? It means that we are condemned to continue the journey together, because what happens in Europe impacts in Africa and vice versa. That is very important. Secondly, colleagues in their previous presentations were mentioning the superficie of Africa, which is more than 30 million square kilometers, which is true. That is more than 7 times Europe. For us, it means natural resources and so on. But it is no more about exploring natural resources in Africa. It is adding values on what is coming from the natural resources and exploring them in a sustainable way. The third point, very important, why Africa and Europe don't have choice than working together, is about the population. In Africa, we are estimating about 1.2 billion inhabitants by 2025, which is almost 3 times what Europe has. For us, in terms of space, it is about a huge market. It is about a huge market. Earth observation applications, services, this is a niche. This is why we are speaking about Africa as the new El Dorado for space business, and mainly Earth observation and telecommunication. Now, I just want to move forward. The African development challenges, quickly. You will see the Agenda 2063 is a compass for us. This is where we have the African we want, in terms of vision, in terms of priorities. But the most important thing for us is an integrated, prosperous, and peaceful Africa. And the big question is how space, mainly Earth observation, can contribute to reach these objectives. I will not read what is there and what has been already underlined by colleagues. 2 things. The global challenges, climate change and variability, is condemning Europe and Africa to work together. The disaster risk reduction, the same. The post-2015 on sustainable development. It is also clear that all the challenges are multifaceted challenges, interlinked, transcend national boundaries, meaning not only one government can address that. Space within the Agenda 2063. Therefore, as you can see, space becomes, and for us today, Earth observation becomes one of the key pillars for the implementation of the Agenda 2063. And you can see here the linkages to the different activities within the Agenda 2063. But in saying that, the space policy and strategy come to make it real, the utilization of space for the implementation of the Agenda 2063. Colleagues, here and online, I would like to tell you something which all of us, Europe and Africa and other continents, should take into account when collaborating with Africa on space matters. The landscape in space arena has hugely changed in Africa. We have many newcomers building satellites, being involved in space matters. Secondly, we are moving from research and development to service applications or service delivery. What does it mean? In Africa, it is good to do research and development, but what is the most important for us is to deliver service to end users, to policymakers, to decision makers. They don't care about our science behind processing an image. What they want is the appropriate data, the appropriate information for them to make the decision in their business. This is why we are talking about evidence, decision based on evidence. And space, many Earth observations should provide them evidence and scenario. Second point, quickly, we have various stakeholders now in Africa. At the beginning, like in developed countries, space was a business of the public service. It was, it was millions of dollars. It was taking too much time. But with the new space arena, space now is affordable. Earth observation is affordable for all. Now we are moving from public sector to private sector, to NGOs, to even regional organizations that are being more and more involved. In our reflection, we have to take all that into account. Then the African space policy is simple for us.
Excuse me, you may conclude, summarize.
Sorry, I didn't hear what you said.
I say you may need to come towards the end now.
Oh, good. It will be very quick. The African space policy and strategy, two things here, called well-coordinated and integrated African space programs, creating a regulatory framework. And the strategy is just to implement the 2 points I mentioned, space-derived products and services, and creating an African capacity or capability. GMS in Africa is the pure example of the concrete use of Earth observation to provide services. And it is the unique program covering all Africa, Northern and Sub-Saharan Africa. I would say it is about 12 consortia, 122 institutions, 8 coastal area marine services, 11 water and land services. And what is important, I will not talk about the training, Meshach will cover that in a few hours, but it is important to understand that more than 800 Africans have been trained. And what are the services we are providing? Seasonal agricultural monitoring, wetland mapping, forecasting ocean conditions, water level monitoring, river navigations, water quality, land degradation, and what Dr. Agbaje presented to you, the flood. It is clear that that was very clear, deeply presented. What we want people and colleagues to understand, today and tomorrow, we have to think of how Earth observation can support every single African citizen to deliver its own goal or to get to its own goal. I will stop here. Thank you very much for your understanding and for your time.
Thank you very much, Madam Catherine and Dr. Tidiane, for those great insights on the policy and strategic aspects of the programs. It's still you now, Dr. Tidiane. You have to come in for another presentation on success stories on GMS and Africa. You have 10 minutes for that.
This is why I was surprised, because I think there was a miscommunication. We can come back to that presentation because it was an integrated presentation. I will quickly summarize in 5 minutes the slides. I went through quickly.
Correct.
Could colleague display the same presentation, and I will move to the slides. Yes, I was talking about GMS in Africa, and GMS in Africa, Catherine already underlined that it is about 30 million euro for 4 years and it's funded by European Union and African Union. And the headquarter is for this program is at the African Union Commission in Addis Ababa. And I would say GMS in Africa is the unique Earth observation continental program. The predecessor programs were covering sub-Saharan Africa, and for the first time, for an Earth observation program, GMS is covering North Africa and Southern Africa. And the principle, the big principle of the GMS in Africa, it is targeting continental priorities and regional priorities. And GMS in Africa is seen as one and the first African Earth observation program creating the integration between African institutions, African countries. This is why we came with the idea of consortia. One consortium is made up of at least 5 countries, 5 institutions from 5 countries. It were also including academia. It is very clear for us that Africans should work together to address continental challenges and issues. And Earth observation, GMS was like the laboratory for us, which laboratory is no more a laboratory, it is currently a concrete situation. Then GMS in Africa, seasonal monitoring and early warning assessment. That is led by the OSS, Observatory for Sahara and Sahel. My colleague Munir Mustafa is here today. He will have opportunity to talk to you deeply about that. Then we have also the Centre de suivi écologique of Dakar, wetlands mapping. The Centre de suivi écologique of Dakar is covering really the wetland mapping. One of or 2 concrete results, very interesting to underline here, are simple. 15 Ramsar sites in Western Africa were updated. You know, the data on this site were updated thanks to the GMS project in Western Africa. Secondly, the GMS project allowed to update the delineation of 2 new Ramsar sites that were identified by 2 countries, one in Burkina Faso, to be classified Ramsar sites. These are concrete examples to quote here. Then forecasting of ocean conditions disseminated as SMS. That is University of Ghana, and they succeeded in sharing with fishermen, traditional fishermen, the information for them to avoid going fishing when the security on the sea is not appropriate. And that is done through an SMS, through the leaders and the community in the African languages. We can come back again onto that if needed. Then we have the water monitoring for river navigation. You know the Congo Basin is the heart of the economy in Central Africa. Thanks to GMS in Africa project, SICOS developed what we call a smartphone, which is providing navigators or captains of boats information on where to navigate and if it is good to go, etc., etc. And all this information on the navigation business, you know, thanks to GMS, it has been improved. The water quality in Southern Africa by CSIR, again, GMS and Africa project is helping them to, you know, to give an idea on the water quality for the citizens and even for all socio-economic activities like tourism, etc. Then the land degradation with RCMRD in Nairobi, covering 20 countries in Eastern Africa, members of RCMRD, to give them an idea on, you know, awareness on land degradation, but at the same time, to be able to support land reclamation recommendations and policies. I would say GMS in Africa, in addition to these services, is about also infrastructures. We've succeeded, thanks to GMS in Africa, to empower 12 African institutions in providing them with e-stations, which is something built by JRC and UMEDSAT in support of the GMS implementation. Again, that is the demonstration of the collaboration, the fruitful collaboration between Europe and Africa through our different organizations. It is an opportunity for us, again, to thank the European Commission, to thank EUMETSAT, the European Space Agency, and GRC. They've been there from the beginning, and they are still continuing. The journey should continue with some concrete example, and GMS Phase 2 is coming, and we want, and we would like, to take some of the findings from the reflection and the meeting today and tomorrow to improve, to strengthen, or to enhance the GMS Phase 2. Again, Mr. Moderator, I'm so sorry for the miscommunication, but I'm done. Thank you very much.
Thank you very much, Dr. Tidjane, for those two interventions on the policy aspect as well as on the successes of GMS and Africa. It's really formidable. We'll come back to that, but for now, let me invite colleagues, Pierre, as well as Bennett. You have 10 minutes to present Earth observation in support to blue economy in Africa. And now I invite Pierre to take over. After that, Bennett will come up. You have the floor, Pierre.
Thank you very much, Chair. And good morning to everyone. Good morning, Portugal and the rest of the world. Thank you very much for this invitation. I am Pierre Bahurel. I'm the CEO of Mercator Ocean International, and we are running for the European Commission, the Copernicus Marine Service. I will share this. I'm very happy to share this moment with Bennett Foley for the University of Ghana. I will provide you with a few elements about this blue economy and how the activities that we are carrying out to develop this blue economy between EU and Africa, and Bennett will give specific examples. It's clear to me that we have these three pillar activities that are necessary, that we need to activate these three pillar activities that are fundamental for what we do at Mercator Ocean International, that are the data, the information, and the knowledge levels. And what we do first is to really describe the ocean, so to provide this ocean forecasting capacity, which is data, science, technology, operations, with the real-time monitoring of the ocean, and share this data. And this is something where we have a lot of investment on the EU side, but this is where we need also the data and the expertise from our African colleagues. So we have these collaborations, and as such, Bennett came to Mercator a few years ago just to develop a cooperation between the University of Ghana and Mercator. So this is the first thing. The second thing, which is very, very important for this blue economy, is to share the data as soon as you have something, to build this information and share it immediately. So we have all this open and free policy, which is important, and it stimulates blue economy that we will see later on. Open and free data. The fact that we want to support the users by marine experts to connect these people. And we have now thousands of users everywhere in the world, including, of course, in Africa. And they are entrepreneurs, they are scientists, entrepreneurs, policymakers, and we see the young generation now coming to play with this digital ocean. So this is something that we are developing. And last but not least, the third level is the ocean diplomacy, where this is very clear for the ocean and for the blue economy. We cannot do this without powerful frameworks. And so we are, of course, developing this with the EU, with Copernicus, but also with the African Union and the United Nations. And as you know, we just launched this week the UN Decade for Ocean Science. So these are powerful framework where we want to work. If I'm a bit more specific about the connection between this the action in the EU, so we are running this Copernicus Marine Service. It means a global coverage, so it means open and verified data everywhere and all along the coast of Africa, of course, but also elsewhere. This is a mix of observations plus models. This is state-of-the-art science. This is operational data, and this is the first asset that we share when we enter into this motivation of blue economy. There is a clear effect. We have thousands of users. I said it already. We have loyal subscribers, exchange and dialogue. And the last thing is that this is something which is very aligned. And we had this discussion before with Dr. Ouattara, align with the African Space Agency and this the blue economy, which is the equivalent. So this is something where we can really do a lot. A few examples of actions. First, we are opening cooperation with the Marine Consortia of GMS Africa. Tidiane just said that we have 8 coastal and marine consortia, so we try to really open the cooperations. We have a good example of this, and one of them will be really presented by Bennett just after me, so I don't want to spoil his presentation, but we have also this example with South Africa, for instance, where our data, our current forecast are used to produce the reforecast of such areas. So these are the thing that these data, they are available, and we want this to be directly discussed and used by the one that could develop operational systems locally, and we will have a great example from Bennett. The other thing is to let people know that this is possible, and as it was said by Dr. Ouattara, make sure that this information is ready, actionable, ready to use, and known and ready to use. And we had this great event a few months ago with Professional Anyang Agbo that I want to really thank, and also Dr. Ouattara. And it just to explain what we have, how we could use this data, and they are available to develop this blue economy. A great impact. I mean, this event, it was online and it has been viewed 100,000 times, and we have 3 times more expression on the social network. So a real impact. And I think this is something we must do together.
Recording stopped.
To inspire the youth, to showcase all these blue applications, because sharing these best practices will give good ideas to entrepreneurs, and this is what we will do just now with Bennett. And the last but not least, organize this network, fight together to have more data, in situ data, more observations. So this is what we do with the United Nations, with the G7, with the IOC, with the people that could play with this global ocean observing system. So we have and we can do more to explain the need for along the African regions. And we will do next week a special workshop with the IOC of UNESCO to empower entrepreneurs, scientists to play with all the data that we have already and the systems, and also learn how to implement coastal or local systems. So this is something that I'm very pleased to do with the IOC at UNESCO, which is the body where we want to develop this capacity, because with this we can reach really the experts where they are and start at their place to work together. That's all for me. Thank you very much. I give the floor to Bennett for a specific example.
Thank you very much, Pierre. Good day, everyone. My name is Bennett. I'm from the University of Ghana, and I'd like you to permit me to share a little bit of story about the contribution of the University of Ghana on the GMS Africa project to the blue economy of Africa. I hope you can see my screen. Okay, so for the University of Ghana, we're doing a lot with respect to the marine environment. We're focusing on coastal marine services. And I want you to imagine or think about you being a manager of a resource like a huge aquaculture system or a huge aquaculture farm where you have a lot of resources coming in, you are earning a lot of money on this aquaculture farm. But with this comes a lot of challenges. And in the first session, a lot of these challenges have been highlighted on. And so just a few of the challenges include IUU fishing, which causes the African continent to lose lots of money, lots of revenue. And in addition to that, if you are a manager, you know that you need to take concrete steps to stop this IUU, which may be stealing of fish in from your huge aquaculture system, or use of illegal means of getting things done on this huge aquaculture system or mariculture system. So the next issue will be the safety of the people you employ to work on this huge aquaculture system. When they go out to harvest the fish or to carry out maintenance activities on your cages, your nets, and all of that, they are faced by heavy weather, bad weather, which endangers their lives, as well as the resources, the materials, the equipment that they are working with. And as a manager, you know that if you don't check this, you're going to lose a lot of money, a lot of revenue. And the other one is with this huge aquaculture system, the water body is a huge resource that you are working with. But it also poses a challenge. This huge water body poses a challenge to the coastal environment where you have set up your factories, your houses, and all of that. The water is taking away the land and all of that. So you want to take concrete steps in managing the land and the resource, the coastal habitat, and all of that. So as a manager, what will you do? You try to find some solutions. And that will include, for instance, if you want to stop stealing of fish or illegal activities on your huge aquaculture farms, you employ surveillance, a lot of people, security to go and survey. But in this case, we are considering this aquaculture system to be the ocean, which is so huge, and so we will not be able to employ people, deploy people to go and monitor and provide security. So the best solution is to use satellite images to monitor, which brings an advantage. The same way you can use the satellite information to be able to monitor the weather information and forecast and provide your fishermen and workers on the conditions that will prevail in the next days for them to be informed. And that is where the GMES and Africa comes in to provide information, Earth observation information to decision makers and users to effectively manage the marine and coastal environment. And we at the University of Ghana, by contributing 3 main services, that is providing forecasts of potential fishing zone, which are overlaid with fishing vessel information, the manager is able to know which illegal activities are going on in the system and to direct the meager security resources to go protect this system. The same way we also provide forecast information on the conditions of the sea to fishermen, local fishermen, by simple means that they will be able to know what is going to happen at sea for them to advise themselves on whether to go to sea or not. And again, we provide coastal monitoring services on coastal erosion to be able to tell which habitats to protect, which areas to protect, the vulnerability of the coast. And this is being carried out in the 12 coastal West African countries, targeting different users. And these are examples of the services we provide, looking at providing potential fishing zones on the left, bottom left, an image of potential fishing zone with vessel track on it. And on the right, you have the list of vessels operating in the EEZ, where you can determine all the vessels that are in your waters. And as a manager, when you have this, you can go through the list and see that this vessel is not registered in our waters, so we have to go after it. At the same time, you will be able to detect if there is IUU fishing, illegal activities going on. And for the fishermen, we provide them with the early alerts, early warning alerts via mobile phone, simple mobile phone technology where you can get a text message, or if you have an Android phone, you can download the GMES UG mobile app and access the forecast information in the form of pictures, images, or text as well. And you complement this with use of flags to inform those who are not able to get these messages. We mount these flags on the beaches to inform them about the state of the sea. At the same time, these are example maps that we provide to coastal managers, wildlife personnel, institutions, to tell erosion, the rate of erosion, and which areas are more vulnerable to destruction, and for them to protect it. We also provide the ecosystem mapping service to tell land use changes over the period of time, so that the manager can tell which areas to focus attention on especially with regards to the mangrove system, where there need to be replanting, there should be replanting. Where you have to protect from cutting, you protect from cutting.
Should be concluding, Bennett.
Okay, so after all that, we also provide capacity building to several people to be able to use these products and services. And we also encourage the use of open source tools to develop, to get institute data that will support the satellite data that is used in order to validate the information. So in conclusion, we know there's the need to continually engage the users and policymakers to continuously or consciously incorporate the use of Earth observation products and services in their daily activities. And by doing this, you contribute to the blue economy, which helps in sustaining our sustainability use of the marine and coastal resources. And we would really like to thank the European Commission, the African Union Commission, and the GMES and Africa program, and all the partners who have contributed to this success. Thank you very much.
Thank you, Bennett. Thank you, Pierre, for that presentation on EO and the blue economy. And the three presentations that I've just listened to, they have highlighted critical issues starting from the policy aspects, programming, as well as successes that GMES has registered, and practical issues on the ground as presented by Indian Ocean, or the Mauritius Oceanography Institute, as well as Ghana. So now, colleagues, there is a question here which has been raised, and the question goes to Dr. Tidiane. The question is saying that it recommends the collaboration that GMES, it is appreciating the services that the GMES is providing, especially in the marine sector, and on this monitoring of the meteorological conditions at sea. So the recommendation is that they would want to see more collaboration between GMES and Africa and national meteorological services, especially on issues of area warning systems. This is being proposed so that would help to avoid duplications and conflicting messages, as well as competitions in issuing area warnings. And so the question is, in such circumstances, what would GMES therefore do to help close the gap in area warning systems? So that's the question, Dr. Tidiane.
Yeah, thank you very much, Dr. Jolie. I'm smiling because, in fact, this question should be for you and I. You know, Dr. Jolie is the coordinator of GFCS and CLIMSA. I would say the answer is simple, and Jolie, you know that. We first, at the coordination level, will work to make sure that we are integrating our activities. Secondly, to avoid the duplication. Secondly, we will be aligning our resources to address common priorities, because it is clear that there will be vertical issues. We'll handle that separately, but for all the common issues, we'll do that together. And the spirit of GMS in Africa is simple. We want all organizations to work together, be meteorology, be not meteorology, because the danger right now is to start separating the themes. And also, Earth observation is a cross-cutting matter. You know, from the same satellite data, you can address several applications. Therefore, it is in our interest to be inclusive. And it is a very good recommendation. We will start working on it, but we are also calling upon the willingness of African institutions also to come to us, because we cannot cover all of these institutions. But at the management level, at the African Union level, Dr. Jolie, yourself, and myself will be working together. We'll also make sure that our senior managers work together. We support them because they're working together already on the policy matters. We'll make sure that we are supporting them in a consolidating and integrated manner. That is what I will say. It is a very good recommendation.
Tidiane, for that great answer. For sure, indeed, it is about working together, which we are really working together, and I can attest to what Dr. Tijana said. There is another question here that comes to say that this mode of GMS and the like is really unique and novel. But the concern, therefore, that is being raised is about sustainability. So the question is, do these activities within the GMS and Africa continue after the funding period? I think that would be our final question that I have before we move to the next presentation. Dr. Tidiane can quickly give a brief on that one, then we move to other presentations.
This is another interesting question, and this is why GMS in Africa is a little bit original. At the beginning of the program, we made it mandatory. The co-funding is mandatory, because when someone invests his money in a business, he doesn't want to give up quickly. That is one thing. All the consortia under GMS in Africa have provided co-funding. That is one thing. Secondly, in terms of sustainability, we wanted the organizations to take the ownership. What does it mean? It should be aligned with their own priorities. We should not come with something. This is the bracket I can open. During the collaboration between European Union and African Union, or Africa and Europe, this collaboration should use Earth observation to address the African needs. When you address my priorities, when you address my needs, I'll take the ownership. Once I take the ownership, that is one of the solutions toward the sustainability. And the third thing we are also asking under GMS in Africa, it is to make sure that the subject matter or the services that are provided by the consortia address regional, official, and well-known priorities. How do you know that? With the involvement of regional economic communities, but also regional development organizations. Again, we have to align the policies, we have to align the strategies. Most importantly, we have to make sure that institutions are taking the ownership and also they are investing in. The last point of the sustainability resides in the human capital development. Not only the human capital development, but also the utilization of people will be training, people will be supporting. We have to be able to use them properly, because Earth observation is not new in Africa. After 30 and 40 years, how many thousands of Africans have been trained, but how many of them are still working on Earth observation matters? Because sometimes after the training, they move to something else. Now that is the human capital utilization. We have to be able to optimize that.
Thank you very much. We really now need to enter the other session, but there are two more questions for you, Dr. Tidiane. Keep them on mind, or you can answer them on chat, or toward the end of this session, if you have some time, I'll give you some time to briefly clarify, but on chat you can also respond. One is on, is it possible for other academic institutions to join GMS? And then the regional economic, there is another question which is asking, is saying that ECAS Regional Climate Centers experience the need to join GMS. And as I would write, it tried to this day. So it's also looking at the same, it's about the same thing of taking on board other institutions. Look at that, and I'll give you some time if you have at the end so that you can respond to that. So for now, we move on to Earth observation and food security in Africa. And our first presenter will be Felix from DG JRC, and will be followed by Mustafa Mimuni. So Felix Rimbo, you please, once you make your presentation, hand over to Mustafa. The two of you have 10 minutes starting from now. You have the floor, sir. Thank you.
Thank you very much, Mr. Chairman. Good morning, ladies and gentlemen. With the next presentation, we move back from the oceans and the deep waters to firm ground. The idea is to look a bit more in depth about what Earth observation can offer to policymaking and decision-making in terms of specific evidence. It's a shared presentation by Mustafa Mimuni from the Observatory for Sahara and Sahelian. And he's the head of the remote sensing and GIS laboratory, and also the technical coordinator in OSS for MES in Africa. My name is Felix Rembold. I work with the Joint Research Center of the European Commission, and I'm in charge of food security in the D5 unit. So I think it is the previous presenters have made my work very easy in introducing the reasons why Earth observation is important for food security in agriculture, and why the information need regarding food security is so high in general, but in particular in this moment. A lot has been said about climate change impacts and extreme events already on agriculture and on vegetation in general. But we also know from the global report on food crisis that the numbers of people affected by food crisis is at a historical height. And this is due to the combination of the drivers that have been mentioned with the effects of the economic crisis, which has been caused by COVID-19. So because of this combination of factors, we are really looking at an improved need or a heightened need for evidence. And this is crop monitoring information, agriculture information, but not only to plan for better interventions. And on top of that, there is the major question about food systems transition towards more sustainability. That can, of course, not be answered by Earth observation alone, but in our experience and in working with many of the partners who are at this conference and not only, we can say that Earth observation provides a very important contribution to making available evidence to decision makers in all the sectors that are part of agriculture and food security, which have an important geospatial component. And those go from land administration, land governance, to the monitoring that has been mentioned already many times, to crop mapping, land use change, and to risk management. And what is, in particular, what kind of information is useful for decision makers and policy makers related to those sectors? Well, again, it's many different categories. It goes from baseline data, accurate map at a certain moment in time, to the seasonal monitoring information that changes during the season, to change information, for example, for land resources and land use, to information that has, as it has been mentioned, that helps capacity building. So for all that, with Copernicus, there are contributions, and it has been shown already at the international level. There's major progress was achieved thanks to the crop monitors that have been made available by GeoGlam since a couple of years. They are mainly based on Earth observation and on the contribution of both national and regional local experts, as Catherine has clearly explained. And what I would like to say here is that as much as the crop monitors summarize very well the contributions by the different parties from regional and national contributors, it is still very important that each of those partners continues to work and invest in its own systems, which feed into the international and multi-stakeholder information, such as the one of GeoGlam. For example, in the GRC, we have developed our own early warning system, which every month provides information about agricultural hotspots in food insecure countries, and every 10 days provides warnings about droughts, delays in the season, water deficits, and vegetation anomalies. And with Copernicus data, and in particular thanks to the Sentinels, we can now go down to the field level and really look at, for each single field, whether there are any problems, water stress, crops which haven't been planted, crop failure, and so on. So this is really a game changer. And the technology that we have used for that platform, it enables us also to work very closely and to improve together with partners at the regional and national level in Africa, their own systems. I have two examples here. One is the platform launched by ICPAC in March for Agricultural Watch. This is directly based on ASAP technology and uses Earth observation. And in May, we produced in the GRC our first quantitative yield forecast at the province level, which is entirely based on machine learning and artificial intelligence. Also next week, there is training with 80 participants from North African countries on yield forecasting with statistical methodologies. So yield forecast is definitely a major application of Earth observation technology. Finally, I would also like to mention this project, which has started this year, and which is a direct contribution of Copernicus to GeoGLAM in Africa at the national level. The idea is to support countries in improving their national crop monitors by improving the baseline information and specifically the crop type maps, because where crops are every year is still a major question that we need to answer, and that there's limited information in the countries. So this is about mapping 3 areas of 100 square kilometers each with Earth observation, but also there is massive field data collection involved. And the field data collection campaigns are right now ongoing in 3 countries, in Tanzania, Uganda, and Kenya. And it's extremely challenging with the COVID mobility restrictions, but it's also very rewarding to see all these data coming in from the field. So with this, I finish my part of the presentation and I hand over to Mustafa Mimouni. If it's okay for you, Mustafa, I can continue to move the slides and you just tell me when I need to move to the next. Mustafa is on site. Over to you.
Thank you so much, Felix. So GMS in Africa is a user-driven project, is user-driven initiative. OSS is an international intergovernmental organization. Our mission is based essentially on knowledge transfer, capacity building, and raising awareness. We count on board 26 African countries, 7 non-African countries, and 13 member organizations. So in the framework of GMS in Africa, we develop the service on agricultural seasonal monitoring. As I said, it's user-driven, so we have to think about what decision makers and agricultural managers want. They want to improve crop monitoring and forecasting through very specific questions, kind of where crops grow, how good they perform, what is the amount of water used in irrigation, is there any other pressure, is there any other crop anomaly. So what we have done, we co-design operational EU services. We try to tailor them to the end user's needs. The idea is not to bring black boxes, but to set up user-friendly platforms for intuitive information delivery, which is well adapted to the different levels of users. And as in every project, it's good to develop things, services, products, platforms, geo-services, but it's relevant and it's mandatory to ensure capacity building and raising awareness, because if people, they know how to use the service, it will give us more sustainability for the next slide. So during this process, it has been done since the beginning of GMS and Africa. We involve the end users from the beginning, from the idea about the service until the end. It means, sorry, Felix, the previous slide, please. Yeah. So we involve end users from the conception node, from the idea about the service until the final release of the deployment, and there is an iterative feedback collection during all the steps. Also, key players in the region are engaged, and we think about communication and raising awareness as a transversal action to take into consideration during all the phases of the project. Next slide, please, Felix. So what we have done, we developed 3 services, one on agricultural seasonal monitoring, one on water use in agricultural fields, and the third one on land degradation monitoring. The idea is that people, they just use some platforms to get information. Just in few clicks, he will get the map, he will get the anomaly, he will get the product itself. And with the different users of the service, we are arranging to get national and regional products based on the local products. Also, we have taken into consideration the integration of in-situ data for model validations and product for model calibration and product validation. So we undertake some field visits along with the partners and the users on the field to ensure an efficient and realistic seasonal monitoring. So the services are well tailored to end users' needs. They are aligned with the national strategies and regional policies because they are coming from an expressed need by our end users. So the geo services are through different platforms like MISBAR and MISLAND, who has already been operational and has been, we have trained the end users on their use. And the idea also is to involve the end users in the co-designing the services through the partners' engagement and end users' involvement. Next slide, please. Yeah, thank you. So for MISBAR, what is MISBAR is, first of all, it's a data processing relay. So all the payload regarding the data collection, processing, and interpretation is done very simplified through this platform. It's done in a kind of daemon processing. It provides an easy access to a very wide range of EO data, ranging from geological Earth observation data, from meteorological data, etc. And it allows also to undertake some multi-scale time series analysis at the parcel level and going up to the regional level. So people, they just the users just connect to the platform. It's easy, free of use. Select the parcel or the region and undertake multi-scale time series analysis. They don't need to be an expert in remote sensing, since all the processing and all the analysis is being developed in the background. It helps also to undertake some agriculture and water abstractions monitoring. As you know, agriculture is relying, especially in North Africa, is relying mainly on groundwater resources. And groundwater resources, we identify so many pressures, and we have lost so many aquifers because of this pressure. So the idea is to monitor illicit abstractions and also to raise awareness on the added value of remote sensing or Earth observation data towards that. And for decision makers, we thought about very customized bulletins. The idea is that he hasn't to get into the platform to deliver its own services, but we deliver these bulletins at a monthly basis in very defined areas. So decision maker, he see at monthly basis, he can monitor he can monitor and assess the agricultural campaign without any prior knowledge. So just define the geo services, and we will get these optimized bulletins. So the idea is not to is to hide the complexity of the processing chains and offering in user intuitive interfaces. Next slide, please.
Should be concluding, Mustafa. Excuse me, please. You have to conclude now.
Okay. In two words, different strategies for addressing the capacity building needs, ranging from training of trainers, training the end users on the service, and training of IT experts on service administration and maintenance. The idea is to ensure that the partners and the end users are able to use these platforms and services, and it's kind of a key measure of sustainability. And I will conclude directly. Next slide, please, Felix. As conclusions, I will say that new opportunities and good collaboration between Africa and EU, thanks to the Copernicus data and services and GMS and Africa platform, GMS and Africa framework. And we said that access to data and processing remains a challenge across African countries. So there's need to stronger support to scientific computing platforms, free access to DAES or any other cloud platforms. Also, there's a huge demand for agriculture and food security monitoring information, as well as for capacity building, especially which increased during the COVID-19 pandemic, because people, they want to get information without being on the field. So field data and agriculture statistics sharing is still not obvious, but we need to support by other parties. So in the framework of developing operational services, we need some institute data for calibration, validation, and this remain a good, let's say, a real challenge. And there's demand for additional involvement of GRC in technology transfer and training for and with Africa. So the idea is that all the scientific, let's say, outputs should be adapted to the African context, and the technology transfer must be undertaken. And thank you.
Thank you very much, Felix and Mustafa, for your coordinated presentation on Earth observation, on agriculture and food security. Let's move forward now to Earth observation in support to climate and disaster resilience in Africa. Here we'll be looking at presentations from UMETSAT from Job, as well as from Dr. Guled Atan, the Director of IGAD Climate Predictions and Applications Center. I hand over now to Job to give your speech, and then you leave some part of it, sometime Dr. Guled Atan to finalize the presentation within your 10 minutes. You have the floor, sir. Thank you.
Okay, good afternoon. This is Dirk Schulz from UMETSAT. I'm the Climate Service and Product Manager supporting services in the area of climate from UMETSAT. And this is a joint presentation with Dr. Guled Atan, who is the Director of ICPAC. We will have two parts, and the first part will be given by Guled Atan, and he will introduce himself and his institution. Guled, please go.
Thank you, Sir Schulz. You can go to the next slide. Good afternoon, all. I think ICPAC doesn't need a presentation. But one thing that I will add to this slide is that we cover 11 countries in East Africa, as north as Sudan, as south as Tanzania. Next. Our climate services that rely on Earth observation are many, but I selected these 6. The region is data sparse, and the network of data collection actually sparse. And Earth observation data offers an economical and quick way of collecting data. Next. No, go back. I want to give you a few examples of products that we use that are aided by satellite data. And the two products that you see now side by side, one is on drought monitoring. What goes in this is rainfall data, vegetation status, and a whole host of the, other things. And it's used for a drought monitoring. Basically, it's color coded from red, severe to green, above average. The slide B is on a product that actually we get from UMETSAT, and we use for prediction of flash flood on areas that are receiving well above average rain, and as an indicator of the danger of flash flood. All this data, as you can see from the URL down the slide, it is in our East Africa Hazard Watch website. Next. We use the Earth observation data for a simulation of a numerical weather prediction, and this is the forecast of 7 days. It aids the numerical weather prediction on the initialization stages. Next. An exciting product is that as some of you might know, we have a desert lox invasion that is taking place in this region for the last 2 years. One product that we're producing is a forecast of where the swarms will move on, and this is basically done through a weather forecasting model and vegetation index, vegetation health that are both aided from Earth observing data. Maybe this is not complete. If you touch again, yes. So you can see this is the final product. Next. I will leave for your shows. I think I'm on my time, five minutes.
Yeah, okay, thanks, Clyde. Then I continue and present the EUMETSAT part. And behind all this data delivery that you just saw being used for several applications is, of course, a strategy how we really systematically work on the data and serve services, but also decision making. So, of course, EUMETSAT is operating a large amount of spacecraft, all operational weather satellites in Europe. We have a big fraction of product producing entities. So it's, of course, at the headquarters in EUMETSAT for all the real-time products, but also for climate data records. And we have a network of satellite application facilities. And I will show a couple of examples of their products, in particular from the land surface application, SAF, and also the climate monitoring SAF. With that, we serve a lot of services. So this is a climate-centric slide, but it's serving national climate service providers, but also European-wide providers like the Copernicus Climate Change Service. But it also supports research on climate like the WCRP and assessment in the political sense like the IPCC. And from the data that we provide, you can do a lot of analysis on climate variability, trends, extremes, and processes as well. And then in the decision making, so the services provide this for policy making, of course, in the UNFCCC and all the other application areas. And we have touched upon a couple of those earlier today and continue doing this throughout the day. Okay, on the space segment, one of the backbones, and I was very grateful to Alan Bellwood in the morning showing the first Meteosat image in 1977. So you see here the long list of Meteosat missions starting in 77. So it's far more than 40 years now. And basically every data bit of those missions is being used. And this will be continued with the Meteosat third generation for at least the next 20 years. So there is data security for up to the mid-2040s already, given that the launches will go well and the systems operate in space well enough. So that's a very long perspective that you can use for weather and climate services. Some examples, a product in development that EUMETSAT together with French colleagues from Ligos, CNRS in Toulouse is a global convection system monitoring, in particular on mesoscale convective clusters. And you see just the brightest temperature image on the left, and then you see the clusters on the right, which are characterized in how big they are and how long they reside and where they move. And this is perfectly being usable, to do climatology, of course, and figuring out about extremes in the appearance and strengths of those clusters. But it can also serve, of course, early warning on weather hazards, as it can also be run in real time. And we're just on our way to establish a full resolution climatology for all the geostationary ring that, of course, involves also Africa, but also the Indian Ocean as well. A second example is from our land application SAF. So combining surface temperature retrievals with the vegetation anomalies. And this is done for one example that you can see in the lower left for a big anomaly in the land surface temperature in South Africa in December 2019. And on the top, you see a time series of this anomaly with very high anomalies in the 2019 timeframe. So all the red is positive. So this is all from the Meteosat second generation starting in 2004. Of course, we know also the fraction of vegetation cover from the same sensor. And then of that, you can see basically the consequence of the temperature anomalies on the vegetation cover, which has very big negative anomalies due to the heat stress at the surface. So this is a really powerful Meteosat. The second example is you can also link the evaporation, of course, to the vegetation state. And this shows the reference evapotranspiration. So that's basically the atmospheric water demand, what the plant needs to evaporate. And this is for December 22 in the Horn of Africa. And you see pretty high evapotranspiration and also the anomaly map. You can combine that with radiation measurement on what is available for photosynthesis of the plants. And out of that, you can really create a map where you can see where vegetation growth was above and below average. So these are powerful tools actually to support analysis of past seasons, and may have hold also some promise in looking into seasonal outlooks. The last example I will show you is about solar radiation and solar energy applications. Our climate monitoring staff has actually built a big climatology of the solar radiation at the surface from the whole Meteosat series starting in the early 1980s. And this is used in a GIS tool at the Joint Research Center. And using that tool with the background data from the climate monitoring staff, you can really derive a photovoltaic potential. Like on the right, you see this for Ethiopia. And there you can see a really plan where you put your power plants or how you need to orient your roofs and the cells on the roofs. Egypt, this is another one, has used the data as well to produce a solar radiation atlas for Egypt, which is depicted in the example below. Okay, conclusions. I think it is clear that 40 years of Meteosat data over Africa are a real key source of information for weather and climate services and really complement SPARS and situ observations. The data products are powerful to support weather climate services, improving early warning capability, but also fostering resilience against climate change. And I think everything that is related to food security and flood warnings are really important for this resilience. The MDG will be launched in 22, and then we will have 2 more decades of unprecedented observations. And the MDG missions offers lots of opportunities, but also challenges, because this is a different scale of data sizes, even more when we try to combine this with missions in polar orbits, such HumanSat mandatory programs and Copernicus missions. So we heard earlier speakers talking about these challenges and using cloud architectures. HumanSat is also doing similar things, bringing the data into the cloud to really ease usage of the bigger data volumes that you cannot easily transfer anymore. And HumanSat is ready to work with the European Commission and the African Union Commission and the user community in Africa to continue to improve weather and climate services. Thank you very much.
Thank you very much, Jock and Dr. Gule Dartan for that presentation. Let's move quickly to the final presentations. We'll now be having a case study showing European Space Agency's Earth observation activities on developmental applications. And we have 2 presenters on this one. We have Benjamin and Masirikari. So let's move on. Benjamin, you have the floor to start the presentation, and then hand over to Masirikari Maslanga for him or her to finalize the presentation. You have the floor.
Thank you very much, Jolly. Thanks for the opportunity to present here our approach to co-design Earth observation applications in Africa, together with our African and European partners. This is a joint presentation with the Resilient Academy in Tanzania. So our colleague Misidikade will take over the second part to show an illustrative example how these kind of cooperation can work in an urban environment. How is that working? So ESA, besides building the Copernicus Sentinels and making these vast amount of data accessible, is also having quite a bit of different programmatic activities, different programs supporting from science all the way up to the application level to make sure that the Earth observation data provided by the different satellites are actually being put into best use. The 2 programs which I would like to highlight here with special relevance for Africa is on one hand side the EU Africa initiative. It's a new initiative we are just launching. It is focusing on the research and innovation part, building communities and applications within Africa, but on a very much African-European partnership basis. On the other hand, we have the Global Development Assistance. That is done in partnership with the international finance institutions like the World Bank, but also obviously with many on the country level and regional managed agencies, which are working together with the World Bank or the African Development Bank. So these two programs actually are quite complementary. They're moving from research all the way to Earth observation mainstreaming, and we do that together with the African Union Commission, our colleagues in JRC, DG INPA, and DG DEFIS, but also here in Africa, mainly with the World Bank and obviously with the African different stakeholders. And ESA is very much committed to support GMS in Africa. We're already working very closely together. And for the second phase, we have already formally committed to support with these two programs, the program. So just one step backwards, since 2002, ESA was already very much involved with African scientists, making sure that the satellites data can be used to look after water resources in Africa. During that time, 90 plus different research projects were implemented with 150 African institutions. And you see that was addressing and working, collaborating with scientists in Africa across the whole continent. But also we try to translate the science into open source algorithms, making sure that we could leverage this information, this knowledge and this expertise into products. And we work together here with national hydrological department, for example, in Namibia, in the Volta Basin Authority, or also with the Nile Basin Authority, Nile Basin Initiative, sorry, more on the flood assessment, but also water quality in the Lake Victoria, in South Africa. And we went up to the reporting obligations in the Lake Chad Basin Commission, where we try to make sure that these kind of different Earth observation data not only left on the research side, but actually went into reporting obligations, so supporting decision makers. And most recently, we moved from these kind of, let's say, science studies into the cloud computing area, using the DSS to make sure that these kind of capabilities can be scaled to national and also regional level. And we worked together with GMS in Africa, in Morocco, and then also on virtual trainings. So from Tiger, we moved on now to EU Africa, as I already announced. That is a new initiative, basically, extending the Tiger experiences. You see here 3 pillars. The research development part is really about working together with African and European scientists on paired research type of tandems. They really will get some dedicated fundings, and there will be later this year a research call for African and European scientists to work together to develop new open source tools and algorithms. But at the same time, there's also a space academy and this a digital campus to support the training of scientists and EU experts in Africa. Also, that will be explained later in the capacity building session. All that is based on the extensive experience and also investment from ESA to use platforms, cloud-based platforms, to really make sure that the ICT capabilities are used to really make use all this vast amount of information coming from the open access data sets from the Copernicus system. So in more concrete terms, why is it not moving? EU Africa has a number of activity types. So the research facility has just been launched, and we will see in the next session how that is being actually used on the DIAS. That is also making link to the cloud infrastructure support. You saw this morning presented by Alan, the African user survey, which we are just conducting in the moment with hundreds of feedbacks. Thanks a lot to everybody online from Africa. And we bring that also then into different projects, research projects, from explorative type of activities up to continental demonstration. And we will do a continental range land with its 20-meter resolution to, starting this year. From the more R&D exploration of the data, we go here now to this, what I called the Global Development Assistance, but we actually already started in 2008 to work with the World Bank with different demonstrations of Earth observation services to bring this into the international financing institution projects. And there was some question about sustainability that helps very much to work in partnership with these type of financing and investment in the different countries. And that moved on into the Earth Observation for Sustainable Development program with 25 million supported. And you see here 8 different thematic projects being supported, very much looking into moving existing capabilities into pre-operational demonstrations in the countries, also mainly in Africa when we work together with the World Bank. And you see the different thematics applied here. I'll give you in a second some examples. And now this last year, we started with the Global Development Assistant to really mainstream these type of capabilities in the operational working processes as best practices. And you see some programs on the left-hand side, which we support, and the Resilience Academy will be the one example being demonstrated by Ms. Elikale in 1 minute. So just before we go to the urban case, I wanted to give you some other examples from this is just 3 examples out of a multitude of demonstrations. Here we work with the irrigation and initiative in Sahel. It's a several hundred million infrastructure investment from the World Bank. And we supported that with different Earth observation data sets to plan and design their investment. And that's is ongoing. There is also different on national level, different applications supported. On the marine coastal part, there is the West African Coastal Area Management Program from the World Bank. And you see here some examples here, for example, with oil spill coming from an oil refinery in Senegal, or the coastal area changes depicted with high resolution optical data sets. But also from the flood and drought risk monitoring part, we partnered with the African Union African Risk Capacity program to make sure that we could use flood mapping to support their parametric insurance approaches, so to bring that kind of Earth observation capability to augment what is existing in the same we used here with drought monitoring, where we leveraged the essential climate variables supported from different programs we have also within ESA. With that, I would like to hand over to Ms. Elikale, who is one of our partners in the Global Development Assistant part. He is the coordinator of the Resilience Academy in Tanzania. This is part of our cooperation with the World Bank. Ms. Elikale, take over, please.
Thank you so much. I would like to present to you how we use...
Just a small interruption, Chief. As you start, we are almost running out of time, so just keep...
Yeah, I will give as quick as possible. So I'm going to present about how we use Earth observation data, combining with citizen data to produce flood modeling. Next, please. So flooding is a very big problem in Dar es Salaam. And we need to demonstrate this problem by making scientific flood modeling. But it's very challenging because the city is growing very fast and we need to do a lot of calibrations frequently. So it's challenging a lot because the city is changing. So we need Earth observation. Next slide, please. We understand that Earth observation can provide a lot of input for environmental, meteorologic, infrastructure and land cover, terrain model, terrain data, and build extent data. So as I said, because the city is changing a lot, it's challenging to get this data, so Earth observation would be very useful for this. Next slide, please. Now, the Resilience Academy have a program that is teaching students. When the students are joining into the Resilience Academy, they're able to learn different skills and tools. At the same time, they're able to do field data collection. Next slide, please. Especially in the program, we do mainly 2 things. We extract data and we also add data. By extracting,
we use satellite imagery as a background to digitize different type of data. And also we do field data collection in order to add data needed for the model. Next slide, please. So this is just as an example of what we do. So example number one is we extract building infrastructure update for satellite imagery in order to for exposure in the flood resilience academy, flood modeling. The other example, number two, is we extract from household survey the history of floods to calibrate the history of impact of floods. And the third example is that we collect drainage condition data to get drainage network. Next slide, please. The fourth example is we try to model soil erosion in order to get a detailed surface soil map. And the fifth example is that we extract canopy and to digitize tree cover data from satellite imageries, but also we're doing field visit to tag the trees. And the last example is we try to extract community feedback in community narrative in order to develop different scenarios, but also plan and from getting like a feedback from community. Next slide, please. So this is like the last slide to show that so Earth observation could be very important in to provide data that characterize the city and terrain, and also if we add that the community data that we collect from the fieldwork from the community, that like flood marks in history. And at the same time, we are able to produce flood scenarios for flood management. And therefore, if we combine all together, we can produce this kind of scientific flood modeling. So, and this flood modeling could be used for better flood management. Thank you so much.
Thank you very much, Benjamin and Msirikari. We really have run out of time, because I've got sessions coming up. So I'll immediately hand over to the chair, only to say thank you, all presenters, and request all presenters to go to the chat. There are some questions and comments. I see questions for Benjamin, Dr. Tidiane, OSS there. Go to the chat and respond to them. And now, because of time and some other sessions that are coming, let me hand you over to the chair so that he can release us for lunch. Chair, please, you have the floor.
Thank you very much, Jolie, and really appreciate your work moderating this session. I know you started late, so we made the work a little bit more difficult to you, but you did it perfectly. So thank you very much for moderating this session. Thank you, of course, to all the speakers, also for keeping the time, and for the great inputs that you gave us for our discussions also tomorrow. And thank you, Michel Massad, to be our rapporteur in this session. So now I would like to close the morning sessions. We are now breaking for lunch. We should convene here in about 45 minutes. It's going to be a quick lunch. But thank you everyone here in the room, and also the ones that are following us online. I'll see you in 45 minutes. Thank you very much to all. So everyone, we just need to leave the room and go till the end of the corridor, and the lunch will be served at the floor. Okay, thank you. Hello, good afternoon, everyone. Welcome back to this session. As you know, we ended a little bit late the previous session, and therefore everyone here had to move very quickly to join us. I would like now to start the afternoon by inviting Driss El Ardani, Director General of the Center of Royal Teledetection Spatial. He will give us We will start with his keynote speech, and I would like to welcome you, Mr. Driss, and please, the floor is yours, and welcome back. Welcome.
Hello.
I think we have an issue with the sound from your side. We cannot hear you. Can we understand what's the issue with the sound? As we try to solve this small issue with the sound, so just a brief summary to all of you that are listening to us. We will have 3 sessions this afternoon, so we will hope to keep up with the schedule so we don't end very late during the program. I don't know if we have the sound fixed, and we can have now Mr. Driss El Ardani. I think perhaps you have to close your speakers or... I think we have a technical issue with the sound. So in order to progress and not having everyone waiting, I will suggest that we move forward with session number 3, and by the end of this session, we will invite then Mr. Idris Hadani to join to give his...
Is it okay for the moment?
Yes.
Well, I changed my device, so...
Oh, perfect.
Do you hear me? Do you have the camera?
We can hear you. I don't know if you have the camera. Yes, we do. Perfect. So the floor is yours.
Okay.
Great.
Can I share my screen so to present my slides with you?
Yes, you should be able to share it. And we now can see, yes, we can see your presentation.
Okay.
Perfect. Yes, we are good to go.
Okay. Thank you very much. I'm sorry for this delay and for these technical issues. First of all, I would like to thank the organizers, both the Portuguese party as the African Union party, for inviting me to take part in this important event and to give this presentation. I will try to stress and underline some ideas and some thoughts about the role of space technologies for digital development in Africa and emerging countries in general, trying to underline the opportunities and the challenges. First of all, let me just remind that the process of digitalization, of modernization started, I think, 3 centuries ago with the financial revolution at the beginning, and then in the 18th century with the industrial revolution, but a sort of acceleration was produced starting with the space era. Since the humanity was able to go to space and to build space infrastructures, I think this process of modernization and of development was accelerated. And the second inflection point was started at the beginning of the 2000 years with the explosion of the information age, which I think is the starting point of digitalization, as far as 3 elements was combined: the infrastructure, telecommunication, and production of information. And then later, by the development of internet and connectivity infrastructures, this process was also accelerated more and more. And now we are entering a new era, which is the era of artificial intelligence, which is, I think, the latest stage of digitalization for the moment. And within this context, space could play an important role to support and to enable this transition, digital transition, mainly in African countries. As far as the digital revolution is now infiltrating all the sectors, as economic sectors, as well as society, and all the sectors of development are now based and dependent on the digital industry and the digital technology. The digital revolution, mainly through space technologies for the African region and for developing countries and emerging countries, is a sort of opportunity to develop new business potential, new business models for development, create prosperity, create jobs, etc. And this issue was confirmed and demonstrated by a lot of projects and programs, either in Africa and in other areas and regions of the world, that demonstrated that space technology could and had played a key role in driving digital transformation in these countries. But we have to recognize at this level that the African continent lags behind other regions in terms of adoption and digital maturity. We are now witnessing some advances in specific sectors. For example, the financial sectors is one of the most developed, digitally speaking, in Africa. But I think other sectors related to geoinformation, for example, and all the aspects related to industry, etc., still to be behind other levels in other regions. But now, space can offer what is called an unparalleled instrument to overcome global challenges, mainly in emerging countries and in Africa especially. And also space is an enabler for economic transition. I think it's an opportunity for the Africa and for the emerging regions right now to be able to fulfill the gap and to develop a new approach as far as digitalization is offering new opportunities and is also offering the possibility to fill gaps and to gain time in terms of development. And space technologies, all over the range of space technologies is offering this opportunity to Africa and to emerging regions. Let me now stress some trends that are characterizing the space development all over the world, and especially in our region. The globalization of the space sector is accelerating, and this trend is more witnessed in Africa, for example, as far as for the last 2 or 2 years, we witnessed that a lot of countries have been launching space programs, launching satellites, launching space strategies, creating agencies, etc. And all over the Union African institution, this space strategy and space policy that was adopted by the African Union in 2016 is offering a very specific and a very encouraging framework to develop this activity in Africa. So the globalization of space sector is accelerating. This is the first trend. And we can maybe give some numbers to demonstrate this, as far as by the end of 2018, more than 80 countries all over the world have been developing space activities at different levels. And Africa is one of the most important regions that are developing these activities. The second trend that is important and could support digitalization in our region is that we have a growing perception of the usefulness of space at different levels. Also, as well as on the political and strategic level, governance level, there is an awareness, a raising awareness that space could help and could support the development of our countries, as well as different other levels of our countries, such as the public or universities, etc., are more aware and more open to perceive space as an important and as a useful support and a useful tool to ensure growth and to ensure development. This growing perception of the usefulness of space is also perceived through some elements that we could stress here, that a lot of African countries that are involved in space activities see this as a mean to develop national prestige, but also as a mean to have a political advantage on different levels, technological, commercial, and diplomatic levels, etc. The second element is, I think we do not need more to demonstrate this, that space can bring several social benefits to many socioeconomic sectors in different regions. And this is more true and is more verified in Africa and emerging countries, that many socioeconomic impacts from space investments are becoming more visible and are now, let's say, integrated in different programs. As a consequence of these two elements, that political advantage, social benefits that are brought by space, space is observed or is perceived as an agent for economic growth and development, as I said. We can stress this through the elements that space development, which is impacting different sectors, and digitalization is one of them. It could contribute to save costs in doing the same things more efficiently, as far as concerned development, agriculture, development, health services, infrastructures, climate change mitigation, etc. This also can contribute to deliver new products and new services by a greater value, and also by enlarging the possibilities that are offered and using specific resources. This is also a means to develop a sort of dynamic and integration among sectors, different sectors of the economy, which is provide productivity, efficiency, etc., etc. As far as digitalization is a core element, and space is supporting this situation, will offer this synergy as this integrations. And all of this could help, as I said before, to better manage environmental, heat, social outcomes that are necessary for the development. And also, I think this is important as far as private sector and entrepreneurial initiatives are encouraged in our regions, that space could offer a potential of profitability to all these private actors that are trying to penetrate or to enter this sector and to develop added value services derived from space technology. The third trend is the increasing maturity and the falling of costs and technology. I think we reached a stage where the space technology, digitalization in space technology, and the possibilities offered by space technology have reached a very high level of maturity. And also at the other side, accessibility in terms of costs are more easy to reach today for emerging countries. This is due to the integration and the advances between information and communication technologies, advanced in other areas as miniaturization, power system empowerment, 3D printing, sensor development, etc., etc. The third trend that is characterizing the space development is a change in national policies, both at two levels. We see that emerging countries, mainly in Africa, are more and more open to invest and to develop strategies, but also developed countries and fair nations that are having the technology and the know-how are more and more open to cooperation, to share technologies with developing countries, with a role which is more visible for the private actors, industries in developed countries that are willing to support emerging countries, mainly in Africa, to develop new policies in space and new programs in space. As I said, there is more flexibility in export control, and also more policies to support and to promote domestic industry in this region. But within this context, within these trends that are offering a favorable landscape for our countries to develop space applications, to develop through this space technology, the digitalization of our countries, and to promote this digitalization, to support this digitalization. I think we are facing 4 or 5 challenges that are important to tackle and to discuss, so we can be successful in integrating space technology in the process of development, and specifically in the process of digitalization. The first one is that we have, as a specific area with specific characteristics and needs, we have to create the right and specific business model to develop space applications, to develop Earth observation applications, to develop the process of integration of space in digitalization. This model should be adapted to the African needs and requirements. I think that we have some experiences trying to duplicate what have been developing in other countries, but I think this is very important as a challenge to take in consideration. And this kind of fora is an opportunity to discuss these issues and to gather all the experiences and the expertise of the African space actors to develop this new model, which is adapted to the African needs. The second challenge, I think, is that we need to strengthen and consolidate the role of the private actors in our region. I think we have witnessed a beginning of some specific initiatives in African countries coming from private actors, from private companies to invest and to be involved in space. But I think it's behind the expectations, and it's also behind the potential that is offered by this technology in our region. So I think this is, one of the most important elements to be developed, offering more opportunities, offering an initiative framework to strengthen and consolidate, develop the private sector in Africa, and to initiate cooperation, South-South cooperation in this field. The third challenge that we have to face and to succeed in this approach, to succeed in this endeavor, is to create a sort of balance with this asymmetric relationship between conventional actors and new actors, which means that the role and the importance of the conventional actor as government and national institutions is dominant, is predominant. But I think we have to open more space, to give more space to new actors coming from private sectors, coming from R&D initiative, coming from cooperation, so we can create a sort of symmetric cooperation between all these actors that are involved in space and in digitalization. The fourth challenge, which is from my point of view, is very important, and I think it is aligned with the objects of this conference and this forum, is a better capitalization of bilateral and multilateral cooperation programs. So I think that we have been reaching very interesting results and developing very important activities through this bilateral cooperation between Europe and Africa. And I think the perenniality and the continuity of this cooperation is a very encouraging aspect. But I think we should take time to evaluate this approach and this process, and to develop a framework that will push all the actors and all the participants to capitalize on this cooperation and to set up a sustainable and durable ecosystem in Africa that could be totally operational in developing space applications, space technologies, space industry, and then promoting digitalization of our countries.
Mr. Driss, I'll ask you to conclude, please, because we are...
yes, I have 2 minutes.
Thank you very much.
Rapidly, I have two more slides and I will conclude.
Thank you.
The pillars that are important to develop space, to develop digitalization and synergies in our countries, in our emerging region. First one, the resourcing. I think that we have to mobilize and to dedicate suitable and consequent resources to this process. The second pillar is to develop capabilities in terms of human resources, expertise, experts, etc. And the last one is governance. These three pillars, in my view, are important in this process to reach this objective of space development, and also for giving the opportunity to space to support, develop, and promote digitalization in our countries. This is, I think, a few thoughts and elements that I have been trying to share with you, and I hope that we will have the opportunity to discuss these ideas during the discussion sessions. Thank you.
Well, thank you very much, Mr. El-Adani Adris. So I think you have set up the scene very well for the next session. So thank you very much for having the time to join us and to accept our invitation. So moving forward, we'll have now the session number 3. It is the digitalization and knowledge platforms from technology to solutions. And for this session, I would like to invite as moderator Catherine Guillot from the International Aid and Cooperation Office at DG INPA, and also as a rapporteur Benjamin Coates, the head of Sustainable Initiatives Office at ESA. So Catherine, I understand that you are already connected and with us, so I'll give you the floor, and welcome to the meeting. Thank you very much for joining.
Thank you, Hugo, and welcome to this third session on digitalization and knowledge platforms. After the two sessions this morning on Earth observation challenges and Earth observation for evidence-based decision-making, the purpose of this 1 hour session will be to share information and initiative and experiences on digitalization and knowledge platforms. We will have 5 blocks of presentation followed by a short question and answer session. So let's start with the first session, which is the use of national research and education networks known as NREN that have been established in Africa and are interconnected with Europe. These networks provide an efficient solution to access high volume of Earth observation data for users that need to download this data. So the presentation illustrates this through a concrete case with the use of UMedCast terrestrial by RCMRD, thanks to the Ubuntu Alliance network. So we will have three speakers. First one, Vincent Gabalio from UMedSat, followed by Matthew Tubuka, CEO of the UbuntuNet Alliance, and then Teddy Mwangi from the RCMRD. So please, Vincent, the floor is yours.
Yes, thank you, Catherine. Can you hear me?
Yes, very well.
Yes, thank you. So welcome, everybody. Good afternoon. It's my pleasure to be here with you for this afternoon session. So indeed, I would like first to highlight that this presentation was indeed jointly prepared with RCMRD and our colleague from Ubuntu Alliance, and to echo the keynote speech, I think this is one of the openings that the Earth observation community is doing towards the telecommunication world in order to tackle one of the main challenges that we have is how to make sure that African users can get access to the data. This has been for a very long time one of the major challenges and one of the first hurdle, I would say, for the use of Earth observation in Africa. And now with new programs like Copernicus or the future Meteosat third generation, there is a growing quantity of data and the access to the data remain a challenge. This you can see on this slide some of the quantity of the data that are accumulated. Today, by example, Copernicus, this is one figure I found out 2 days ago. The Copernicus is 250 terabytes per day. So even if you have a 10 gigabits connections per second, you need 60 hours to download 1 day of Copernicus data. So obviously, we need to find other solutions. There is obviously the cloud computing, and we'll speak to that in the next section with the DIAS. They is changing the paradigm with the issue of users not downloading the data but going to the data, but it does not reply to all type of user needs. And if you still have an unstable internet connection or some stringent data access requirement in terms of timeliness, you might not be able to satisfy your needs just based on cloud computing. So downloading of the data still remains an important aspect for some users or application in Africa. So at UMedSat, we have developed several sets of data access mechanisms or services. Some are pool services based on UMedView, like browse view by browsers of the data, or data store where you can access and download the data with some tailoring also before if you want to download only a part of the data. And we have also developed hosted processing, so cloud computing, both with the European Weather Cloud or Wikio in the context of Copernicus. What I would like to concentrate in this presentation is the push service. It's something which is very common, I would say, in television, when you have a lot of data, which is videos, to broadcast to a large community of viewers. You use this type of technology. And we have applied that at UMedSat in several years, starting by using digital video DVB technology broadcasting by satellites. And since a few years now, we have partnered with the National Research and Education Network to have what we call the UMedCast terrestrial. So for us, it's a way to be able to disseminate in a very short time a quite huge quantity of data to several users in a guaranteed way. So it's a one-way data push mechanism, and it transfers either users with poor internet connection or users with stringent requirements in terms of data access. So we have called that, we have the UMETCAS satellites, which is well known to Africa because all the Puma or the e-stations that were deployed under Puma, MESA are using this technology, but we have also now started working with Géant in Europe and NREN in general to have this data push service through what we call UMETCAS terrestrial. And I will now pass the floor to our colleague from Ubuntu Alliance to explain how this NREN network has been further established in Africa and interconnected with Europe.
Thank you very much, Vincent. So yeah, as Vincent has mentioned, I'm going to talk about the role of research and education networks in providing infrastructure that you can use for data transfer and data transport in Africa. For your information, we have 3 regional research and education networks in Africa that provide dedicated connectivity to research and education institutions across Africa. And we do this through the member national research and education networks that we have in many countries. We'll see shortly soon. So the 3 regions are Ubuntu Alliance, which is covers the Eastern and Southern Africa. On the map there, you can see in orange, that's Ubuntu Alliance. And then we also have Wakren, which is in green on the map there. Wakren is for the West and Central Africa in green color. And then to the north, the Arabic side of Africa, we have ASREN. So these are the 3 regions of Africa. And through these 3 regions, we have very dedicated connectivity to Europe. We have connection from Ubuntu to Europe. We also have connection from ASREN to Europe, multiple links through France, the Netherlands, and UK, but also from Wakren on the west side to Europe. So we are well connected with the global world. Maybe we can go to the next slide, Vincent. So now here you will see that indeed we have many countries with presence of research and education networks. Starting with Eastern and Southern Africa, we have 17 countries with the NRENs. Botswana at the top of the list there is the newest addition, where they were established just in December and became a member of Ubuntu Alliance in January this year. So we have Burundi, we have DRC, we have Ethiopia, Kenya, Madagascar, Malawi, Mozambique, Namibia, Rwanda, Somalia, South Africa, Sudan, Tanzania, Uganda, Zambia, and Zimbabwe. And we are trying now to also set up in new countries like South Sudan, Mauritius, as well as Eswatini. In West and Central Africa, Wakren, they are in 11 countries, and they're also expanding beyond those 11 countries. Currently, they have established research and education networks in Burkina Faso, Cameroon, Chad, Cote d'Ivoire, Ghana, Guinea, Mali, Niger, Nigeria, Sierra Leone, and Togo. And also for ASREN, now I must clarify this, that ASREN also covers the Arab side outside of Africa, but here now we're talking about Africa. The Africa side, they have 4 countries, Algeria, Egypt, Morocco, and Tunisia. And all the 3 regions are expanding, and you can reach us very easily. For ASREN, you can reach through my brother, CEO of ASREN, Yusuf Torman, through email torman@asren.org. And for my region, you can reach through my email, ceo@ubuntunet.net, or for Wakren, through my brother, CEO of Wakren, Boubacar Barre, through ceo@wakren.net. And we will direct you and connect you through the national research and education networks. We can go to my last slide. Now here you will see the impact of the EU-funded project. It's called the Africa Connect project. This started a number of years ago, and every phase of it has 4 years. We are now in the 3rd phase, which started in November 2019, going through all the way to 2023. So I just want to share with you some of the key results and perspective on what we've achieved through the EU-funded project. This Africa Connect project is up to nearly 40 million euros for the 3 regions described earlier on. Some of the results to date are that 19 countries have been connected across Africa, and more than 1,600 institutions have benefited, with 5 million end users consuming the services, and up to 40 research organizations collaborating through this. And we support AfriGeo community as well, and we've built capacity for up to 1,000 engineers, and we support the NRENs to help their universities to move to online learning. As we know, with COVID pandemic, it's difficult to have physical education. Thank you, Vincent.
Thanks a lot. My name is Teddy Mwangi. I work for the Regional Center for Mapping. This is an institution that is based here at Nairobi in Kenya. The main mission for Regional Center, it's ideally, if I could be able just give a small brief, is to promote sustainable development through generation, application, and dissemination of the information and allied information, communication technology services and products in the member states and beyond. So just to proceed, I'll need to speak about the collaboration that we've had with the local NREN. The local NREN in Kenya is called Kenneth. So we got into this engagement so that we can be able to be getting volumes of data, the ones for research, which are important to our institution. So the first thing that we got, we had to have an MOU agreement with Kenneth for this specific connection for the internet bandwidth and connectivity. So we can proceed, Vincent. So in the image that I've displayed, I got it from a document that was shared with us from Kenneth. This now just portrays how the Kenneth network is connects to the institutions in Kenya. It connects to both universities and also other research institutions. So this particular image was captured, and the statistics were captured in 2019, September. But now probably the statistics have been able to grow because we already have like 2 years that have passed. So in our collaboration, we had to get the terrestrial service implemented at Regional Center, and this one was done in collaboration with other institutions like UMETSAT, as well as UbuntuNet, that helped us do the configuration that was a bit technical. And finally, we were able to start streaming the data to our institution. So proceed, Vincent. So I'll need to indicate like the equipments that we have at our place. We got these equipments from these partners that have been funding the programs for the GMS and Africa. So this particular station, we have two sets of them. We have the one that downloads data through the satellite connection. And then we also have the one that uses the terrestrial system, whereby the data is pulled through the NREN, the local NREN network. So the advantage with having to pull the data through the local NREN is that you can be able to pull volumes of data that are quite a lot as compared to what you can be able to download via the satellite receiver. So, and then again, the speeds, we can indicate that using the terrestrial system, the speeds are better, and we can be able to download a lot of data, especially if it happens that your institutions have a bigger bandwidth capacity. So in this case, we have like, for one set that we have like the one for terrestrial, there is the PC1, PC2, and PC3 that we are supposed to, that is configured with the latest version of the terrestrial. Of course, it is using the CentOS operating system that is configured to use the terrestrial system. So the advantage with this particular system over the other one, I've already indicated. Initially, we had some challenges with implementing the terrestrial system because at that particular point, JRC had only provided a window-based version that only runs on one PC in order to be able to download via the terrestrial. They didn't have the Linux version. So let's proceed, Vincent. So example of the use cases of the data that has been used, we've been able to develop rangeland decision support tools. We've been able to use the data from the terrestrial station to create the land degradation.
May I ask you to conclude, please?
Yeah, and then we also have land productivity analysis tool. Then we have wetlands monitoring assessment and land use, land cover. So those are the use cases from the data that we've been able to receive from the A station. Thank you so much.
Thank you, Teddy. As a very last slide, and if there is one key message to retain, so please get in touch with your National Research and Education Network contact points, because it can be a solution for you to get access to more data than you can get through your normal internet, or even offer an alternative, a complementary alternative to cloud computing solutions. So you're welcome to do that, and thanks for your attention. Thank you.
Thank you, the three of you, for your intervention, and just would like to highlight how important is the complementarity and synergies between the projects, as we mentioned now, between the Africa Connect, for example, and GMES. So thank you very much. So let's move to the next session on the DIAS presentation. So this session will introduce you the data and information access services, and a number of examples of how cloud computing can be used in the African context. We will have four speakers. So the first one, Bethlehem Rosic from ESA, followed by Luciano Lupedia from the National Space Program Management Office in Angola, and Pascal Lazaradis from WIKEO, and to finish, we will have Serkan Girgin from the ITC. So the floor is yours, Bethlehem, please.
Good afternoon. Yeah, can you hear me well?
Yes, very well, thank you.
Okay, so I'll just try to share the screen.
Lem, should I do it from my side? I have your slides. Right, here it comes.
It's there we are, I think. Can you see it well?
Perfect.
Okay, very good. So good afternoon. It's the intention here is to provide a brief overview. I think it's a 5 minutes presentation, basically. So very high level overview of the DIAS as they have been implemented and are being operated by ESA. Just as an introduction, the scope of the DIAS was to create and enable a European Earth observation data ecosystem useful for research and business, and to have a common European approach, open not only to Europe, of course, to data exploitation with Copernicus at its core. That's an initiative that has been taken by the European Commission. Now there have been 4 DSs that have been put in place by ESA, starting operations in June 2018. You have here the 4 DSs, Mundi, Onda, Soblu, and Creo DIAS. They have, today they are all in operations, and the current contracts are ending in December 21. So on the question, what's next after December, at the moment, I will say the current baseline is that the contracts are ending on this date, and the continuation of the services is on a self-sustainability basis by each service provider under their own confirmation. To confirm to complete the picture on this, also to mention there is a fifth DS, of course, and that will be the scope of a following presentation, I believe, which is the DS operated by EUMETSAT WCAO. So we are talking about the DSs, and what are we really talking about? So the DSs at the end are a platform to provide access to all Sentinel data, Copernicus data, plus additional complementary data, which might vary from one DS to another. Very important aspect from the DS is that the data offer and the service offered by each DS is a public offer, and every DS is publishing their own offer and their own characteristics. This offer is, of course, evolving, and it's evolving according to the user demand and to the every DS strategy. Something to highlight is that there are a number of common services for all the DSs, typically the data discovery, data download, and the data view, which are complemented on top of this by some specific services, again, that may vary from one DS to another one. But in all cases, all DSs on top of these free services, they also provide access to resources for local processing of the Copernicus data and all the data that is available through the platform. And service platform is fully public. So just quickly an overview of the status of these 4 DSs being operated by ESA, just to provide an overview of each of them. So that's, you see CREO DS, some few figures about the status of the CREO DS operations. In particular, you see the number of users that are registered there, over 7,000 users registered, and you see as well the volume of data which is available through CREO DS, about 22 petabytes of data, mostly including Sentinel-1, Sentinel-2, that's most of the volume, and Sentinel-3. For Sentinel-3, it's basically all the Sentinel-3 data mission which is available. So full Africa cover for the full mission. For Sentinel-1, you have, for Africa in particular, is all the Sentinel-1 GRD data is also available directly online. And of course, all the full archive of the mission is also available in a asynchronous manner. And there is also all Sentinel-2 archive for the level 1C directly available, and the full mission of Sentinel-2, including level 2, available also in an asynchronous manner. It's rather similar for the other DSs. You see the status of Moody DS, for example, and there you see the volume of data which is directly available in a synchronous manner online is about 7 petabytes of data. So the data offer is slightly different from one DS to another, but you see that you have access to the full archive also through Moody. See also, in addition to this, some other figures on volume of data which is being downloaded and the activity, the level of activity on this platform. SoBlue, quickly on the SoBlue status as well, similar to the previous ones. You see that the volume of data there which is available is slightly different. It's about 5 petabytes, and the focus there is mainly on Sentinel-1 and Sentinel-2. And to finish on this overview, you have the overview for ONDA, where you see the volume of data available is about 30 petabytes, which cover the full mission data for Sentinel-1, 2, and 3, so full Africa coverage for all mission data and for all product types. Some of the data being available, accessible in a synchronous interface, and other data, older data available in an asynchronous interface. All the information to access this data and the protocols and API for access is available on each platform specifically. And this concludes this overview of the status of the DS operated by ESA. Thank you for your attention.
Thank you. Please, I invite the next speaker, Luciano.
Good afternoon, everybody. I think I have the hand to translate the presentation. Good afternoon, everybody. I will do my presentation in Portuguese. I think the translation is available. If that is, don't pose a problem to anyone. A apresentação vai ser baseada no caso de Angola, no que é o sistema de observação da Terra e de que forma a plataforma DIAS tem sido utilizada. Começo por apresentar aquilo que é o GGPN. O GGPN é o Gabinete de Gestão do Programa Espacial Nacional, é a entidade a nível de Angola que gere toda a carteira de projetos que englobam o projeto toda a carteira de projeto no âmbito do Programa Espacial Nacional, em que a componente de observação da Terra é uma componente muito importante. Dentro daquilo que definimos como Estratégia Espacial Nacional de Angola de 2016 a 2025, ela se centra em 5 pilares, sendo que a observação da Terra assenta nos 3 pilares, em que nós temos como objetivo poder providenciar produtos e serviços baseados na observação da Terra a nível nacional. Para tal, existe a necessidade da criação de infraestruturas e o treinamento e formação de técnicos especializados. A nossa primeira iniciativa no âmbito daquilo que foi a criação de infraestrutura e criação de competências foi a plataforma OpenGeoLab, que é uma plataforma que permite que pesquisadores e desenvolvedores de softwares tenham acesso a dados de satélites para desenvolvimento de serviços geoespaciais, em áreas como processamento de imagens, análise e visualização de dados e cartografia. Como já foi referido pelos diversos apresentadores antes de mim, quando estamos a falar de observação da Terra, o volume de dados necessários para certas aplicações e a infraestrutura de rede necessária para poder fazer o processamento desses dados é enorme. Devido a tal facto, nós evoluímos junto com os nossos parceiros para integrar aquilo que acaba sendo utilizar os recursos do DIAS, no caso a plataforma Wikio, em que junto com os parceiros pretendemos formar 10 especialistas e utilizar as ferramentas de cloud computing disponível do DIAS e o acesso a todos os dados do projeto Copernicus para, a nível nacional, podemos nos introduzir e criar competências para que possamos apresentar às mais diversas entidades aquilo que seriam as diversas aplicações dos dados de observação da Terra, como observação marítima, planeamento urbano e gestão de recursos naturais. Ainda no âmbito da cooperação com os parceiros a nível do DIAS, esperamos formar em breve cerca de 10 especialistas que vão trazer valor acrescentado para aquilo que nós estamos a desenvolver e esperamos aplicar. É o que nós chamamos de programa de sistema de observação da Terra, que é um projeto em que, a nível nacional, buscamos ter capacidade de armazenamento de dados e processamento, mas interligar o nosso sistema nacional com a plataforma DIAS, que é para poder utilizar e fazer a utilização de todos os dados disponíveis, todos os dados do Copernicus e as diversas ferramentas disponíveis. E assim vamos conseguir fornecer os diversos serviços a nível nacional. Basicamente, era uma breve apresentação sobre aquilo que estamos a fazer. Muito obrigado a todos.
Obrigada, Luciano. Thank you very much. I would like to invite the next speakers and Pascal and then Serkan, but I really would like to insist to the speakers to stick to the 5 minutes allocated because we are running a bit late. So thank you.
Yes, sure.
Thank you.
Thank you. Okay. Okay. Okay, so hello everyone. WICO is born with a partnership of three well-known actors for Copernicus services, with Mercator Océan International, SMWF, and EUMETSAT. Together, they provided their know-how to manage the implementation of WICO, and for Mercator Océan International, they are in charge of the user development and management activities. For SMWF to implement tools, which are available in WICO, and for EUMETSAT, they are in charge of the implementation of the infrastructure. Recently, the European Environment Agency, responsible of the Copernicus land monitoring, joined the WICO core partners. WICO architecture is distributed architecture implemented in 3 countries. Dedicated link between sites allow to have a large bandwidth to access to the data. The WICO solution is complemented by a capability to use a public cloud called Elastic Cloud and allow to have a large infrastructure at disposal for data and services providers. It's also important to say that a strong support is offered to WICO users from the usage of the Copernicus data through the expert of the WICO partners up to the IT support given by the WICO consortium in charge of the operations of WICO. WICO DIAS, by its open architecture, is also open to federate new partners like national entities or commercial companies. They will automatically benefit of all WICO data offers and services. It will be also possible for this new partner to share data and services with the WICO community. We have a good example with a new partner with the ODC in charge to provide HPC resources to WICO users community. This offer should be publicly available end of the second or beginning of the third quarter of 2021. But who can be interested by her DIAS? WICO is also turned to a new group of users like developers to promote the use of Copernicus data with development framework directly available from the WICO website. But also all other users from student to international institution, as you can see in the schema, can be interested by WICO. Okay, up to now it sounds good, but what about the cost to use WICO? Funded by the European Commission, most of WICO services are available free of charge. From the search on download data via the use of development framework like Jupyter Notebook, up to the promotion of the WICO users added value data and services in our future marketplace, they are free. Webinar and support desk are also available for free. For user who wants dedicated infrastructure for its business, a commercial contract has to be signed with WICO consortium in charge of the commercial exploitation of WICO. Today, WICO community is around more than 3,500 registered users. We have had regular webinars with 800 participants from 60 countries. From the website, you have at your disposal access to 6 hours of video related to tutorial and webinar recording, and also to 20 Jupyter Notebook, which allow you to familiarize with the use of Copernicus data and to prototype your own algorithm. How to integrate WICO in the past or current initiative of programs in Africa. Indeed, WICO is complementary, for example, with Puma, AMSD, and MESA solution deployed in Africa. WICO brings new cloud technologies that can be used to develop and run data processing in WICO, and then get and share results via the current platform like AMSD and MESA, or simply to access to the large data offer of WICO to make processing in our own local current platform, even if it's not the spirit of the DIAS program. It's also complementary because WICO allows to access to plenty of data and information like webinars, sample algorithm, and technical documentation. For the remaining time, we would like to show you the WICO website and invite you to create an account and to start right now to play with the system and to join the WICO community. Okay. Here you can see the web portal, that it's a public portal that you can reach, even if you don't have any registered account. This is the web page, the welcome page. In this screen, you can see the data viewer. In fact, you can search, retrieve, and view data. Here you have a sample of Sentinel-2 MSI true color data, but also here we can show you seawater velocity. So you can do it even if you don't have any account on the web portal. If you want to download it, of course, you will need to be registered. Here you have access to the catalog, and you can choose and select the product that you would like to see or to download. We have around 223 data sets available in Wiki. And then I spoke about development tool. Here we have a Jupyter Lab. We have 20 notebooks available for you to train to use Copernicus data. You have here a sample of a notebook with in Python, and you can have access to the data via a single API called Harmonized Data Access. You can search, retrieve, download, process data, and see the result directly in your Jupyter notebook. And as you can see, we only use a web browser. We don't use any additional tool to use the data. Thank you. That's it for us. The presentation is finished for us.
Many thanks, Pascal. I will invite Serkan to this presentation.
Thank you very much, Ms. Guillot. Can you please stop sharing your screen?
Yes, thank you.
Thank you very much. In this short presentation, I want to give you basic information about the Innovation Lab of the EU-Africa Research and Development Facility, which is currently under development, and when finished, will run on the DIAS platform. EU-Africa Research and Development Facility is a new initiative of EU-Africa, which aims to support African-European collaboration to enable an active research community and to facilitate innovation processes to further develop EU capabilities in Africa in a continuous manner. The initiative aims to support capacity development through research and also for research, so targets to improve the quality of scientific studies. This approach is complementary to not only the EU-African activities, but also other related programs such as GMS and Africa, and will contribute not only to the researchers, but to a larger community of Earth observation experts in Africa in general. The initiative has a long overarching plan for more than 10 years, but the first phase, which includes establishment of the facility, development of the necessary infrastructure, and implementation of the initial activities, will be completed in 3 years by a consortium of 6 partners led by ITC, based on the experience gained through ESA's Tiger initiative in the last 15 years. Within this first phase of 3 years, there will be 3 main activities. And at the core of these 3 activities, in fact, there is the ICT infrastructure and the DIAS platform. The first activity is to offer technical and financial support to 30 research projects that address African Earth observation research challenges related to water scarcity and food security. 15 12-month projects on each topic to be performed by African and European research tandems will be supported not only by direct funding, but also by providing necessary ICT infrastructure and technical and scientific support. The ICT infrastructure, which is called Innovation Lab, will be in fact a cloud-based Earth observation data analysis and computing platform that will be implemented on the DIAS. In addition to the computing platform, a digital capacity development platform will also be implemented to provide domain-specific training through face-to-face and online courses, webinars, and a massive online open course. The platform is called Space Academy, and the target is to provide training to at least 2,000 participants. You can find more information on the web portal of the project. The Innovation Lab aims to simplify access to data and other products, and to use open science algorithms, models, and tools to produce useful information to help to find solutions to African challenges. The provided virtual research environment will allow users to develop, test, run, and optimize their research code by making full use of the Copernicus DIAS infrastructure. Here, the key point is the collocated data storage and computing services provided by the DIAS. which allow fast data exploitation and analysis, especially for resource-intensive analysis tasks, such as machine learning involving big data sets. The research environment is designed for easy data and code sharing. It is also adapted to low bandwidth internet access. Therefore, it will enable active collaboration and co-development of African and European research tandems. The 30 projects will have high-performance feature research environments running on the DIAS infrastructure that are tailor-made for their needs. They will also receive one-to-one dedicated technical support, but the participants of other capacity development activities will also have access to the Innovation Lab. The main component of the Innovation Lab is the Metris-Re, which is a platform as a service solution developed by the CS Group that is based on Jupyter Lab, which provides multi-user interactive code development environments. Metris-Re is complemented by GitLab for code sharing in line with continuous integration and continuous development principles, and the Nextcloud for sharing research outputs and data sets. Although interactive prototyping environments and notebooks are becoming the mainstream for data analysis, we recognize that research activities may also require more advanced capabilities. Therefore, web-based integrated development environments and remote desktop access will also be provided. A wide range of scientific, geospatial, and Earth observation-related tools will be available for interactive development purposes. In addition to that, traditional analysis software such as Snap and QGIS will be also available through remote desktop connection. If necessary, the users will be able to further customize their research environment according to their needs. In order to access Earth observation data available on the host DIAS and also other DIASes or other data sources, a unified mechanism will be provided through EODEC package. And the platform will also support GPU-enabled and distributed computing frameworks. The project started in March this year, and the Innovation Lab is under development since then. A prototype version for testing will be available in the coming months, and our goal is to provide the final version at the end of this year, before 15 research projects will start in February 2022. Please feel free to visit our website or contact us for more information. Thank you.
Many thanks for this joint presentation on DIAS. And yes, of course, if you need more information, please contact the speakers or put your question on the chat. I will now go to the next session that will focus on two different tools: the Africa Knowledge Platform and the Knowledge Center on Earth Observation, which are tools developed by the Joint Research Center of the European Commission. And I would like, therefore, to invite Ivan Kulish, who is the head of unit for Knowledge for Sustainable Development and Food Security. Ivan, please, the floor is yours.
Thank you very much, Catherine, and good afternoon to all the participants. Can you hear me well and see the presentation?
Yes, perfect, thank you.
Okay, thank you very much. So I will indeed present two specific instruments which are in support of Africa-EU cooperation and which leverage the geospatial data and information. And just very shortly about what is GRC, for those that do not know us. GRC is the knowledge and science service of the European Commission. And our mandate is to do a scientific research in order to create an independent and robust evidence in support of Commission policy and political priorities. And then in order to broker the science into policy making and into policy process, we have specific instruments. For example, here you can see that we have several knowledge centers, as we call them, through which we use the scientific evidence to bring together scientists and policymakers. And I will present indeed two such instruments. One is still to be launched and one has already been launched. So the first one is the African Knowledge.
Could you put your presentation in presenting mode so it will be easier for us to follow?
Sorry?
The PowerPoint, to put it on the presenter mode?
I thought it was on the presenter mode because I am looking this on the presenter mode, sorry. Then obviously I'm not sharing really the, let me see if I can tweak this in Just a sec.
Otherwise, it's fine. We just see your notes and we see your slides.
Well, what I can try to do, I can certainly try to bump the. Can I make this bigger? Yes, I can. Sorry, if we do it like this, and I will kill the. Yeah, is this better?
It's better.
Okay, thanks. And I will actually move this, minimize this as well. Okay, so the first platform that I will talk about is the JRC Africa Knowledge Platform. And let's say the purpose of the platform and the history of the platform is the JRC has a long-standing collaboration, scientific collaboration through which we work on Africa and with African scientists and policymakers. And we work on a range of topics, from energy to protected areas to risk management, food security, climate, migration. Now, here we have a typical situation where you have a lot of excellent scientific knowledge, which, however, remains quite fragmented and sometimes difficult to access. If we put this in the context of the current policy needs, which are very much going in the direction of integrated policy analysis and joined up policies, we felt very much that it's necessary to bring together these different resources we have on Africa and create an entry point on social, economic, territorial, and environmental development in Africa. Now, how does this platform work? It's very much geospatial oriented, and it has four main components. I will briefly present three. The first is data sets. Then we have tools and stories and partners. So the data sets, we basically have a catalog of currently over 150 data sets, mainly curated and produced by JRC, but very often, but in some cases also integrated with external data sets. And what we can do is to search, visualize, and overlay these data sets on the map. And we can also produce specific country profiles and statistics. Here we see, for example, in the middle, we see tropical moist forest. Here we see photovoltaic energy access. And indeed, it's a broad range of indicators and data sets which can be brought together. The other two things which I'll very briefly highlight. The first one is the tools. We have specific tools, analytical tools, which allow users to go deeper on specific topics. Here we have an example on key biodiversity areas. We also have tools on desertification, on water, on COVID, and on armed conflict, for example. And the final feature that we are developing are so-called story maps. They are very interactive and very visual stories, which help to raise the awareness around certain topics, but also offer an example of how evidence is brokered into policy-making process. Now, where are we today? So we are building this robust source of evidence for Commission services. It is very much still a demo. We are about to launch, we plan to launch in the second part of the year. Currently, this is very much focusing on supporting the Commission services, but we see very much in the perspective of partnering with additional stakeholders. This is an evolving platform, and we see as the ultimate, let's say, ideal scenario, a partnership with African Union. Okay, and then the second mechanism that I will briefly present is the Knowledge Center on Earth Observation. This is very much the European Commission, a Knowledge Center for Earth Observation, with JRC co-chairs with DG DEFIS. And it is a new initiative which was launched in April this year and builds on 20 years of experience on Earth observation within the Commission. Now, the JRC has been very much involved since the genesis of GMES. We have accompanied different phases of development and evolution of programs, and we have increasingly supported the DGs in their use of Earth observation. In 2016, the Space Strategy for Europe puts a lot of emphasis on uptake and encourages very much the Commission to promote the use of Earth observation in policies. Now, this is already happening, and the Knowledge Center is there to further reinforce this and to further catalyze this. Now, when we say the uptake, what does this mean? As we can see, we have this very, very rich picture here with two sides. In principle, what we know from the experience of Copernicus is that Copernicus really offers an opportunity to provide strong support and strong evidence for a range of policies. The Commission priorities, in particular, Green Deal, Stronger Europe in the World, and digital priority, all are there to be very much modernized and to leverage the Earth observation. However, Earth observation also brings a certain complexity. It's a big volume of data. It's sometimes difficult to understand and to navigate. So what we need to do in order to really to tailor the evidence for policies is that we need to have a filtering mechanism which can look at this complexity and produce the very specific ways in which Earth observation data and information can be taken up in the policies. Therefore, the motto of our Knowledge Center very much today is from monitoring to understanding. The way Knowledge Center is set up is that we see two pillars. The first pillar is very much on policy uptake and coherence. It's there to enhance and enable the uptake of Earth observation in policies. It's there to look at the policy needs and then to see how much current Earth observation mechanisms are fit for purpose. The second pillar is focusing on mainstreaming R&I. It's about prioritizing research and innovation needs on Earth observation. And then in the middle, you can see a lot of arrows that flow to the middle and come to the middle. We need a very rich and vibrant network of external partners and the broader community to accomplish these activities. And we see this Knowledge Center as a space for continuous dialogue, both within the Commission, but also with external stakeholders. If we think about KCEO and the international context, the KCEO obviously has primary focus on Europe and its policies, and therefore also for EU development policy and strategic partnerships, such as the EU-Africa partnership. In addition, the KCEO could provide a forum for discussion on priorities on EU with international partners and organizations. And also we can use it to understand how to use Earth observation with regard to international agreements. And then in the end, there is also, if you want, an inspirational and knowledge sharing aspect, where we can look at the Knowledge Center as a space where we can harvest and promote the best practices for developing tailored products and services for policy. And we can do this obviously in a dialogue with our partners at the international level. Thank you very much, and apologies for not being able to do the presentation mode. I thought I selected it, sorry.
It was fine, thank you, Ivan, and many thanks for the presentation. Very interesting to have information on these two tools developed by the JRC. I will now switch to the next talk that will introduce a major initiative of the European Commission called Destination Earth. And I will give the floor to the three speakers. The first one being Stefan Seaman from DG Connect, then Gordon Campbell from ESA, and finish with Paul Kounet from EUMETSAT. So thank you for sticking also to the timing, please, because I know that we are a bit late. Thank you very much. Stefan, the floor is yours.
Thank you, Catherine. Yes, it's a pleasure. Good afternoon. It's a pleasure to talk to you about this new initiative we are working on. Oh, let me. Oops, yes. So what this initiative trying to do is to support three flagship initiatives of the European Commission: the Green Deal, the European Green Deal, European Data Strategy, and the shaping of Europe's digital future. And these challenges are really reflected in the objectives we're trying to address. So the Green Deal means that we have to have more interactive and highly reliable knowledge generation systems for decision makers to use. This in turn will create or will increase the need for more data to be accessed fast, but also will need a new combination of unprecedented prediction and simulation capabilities, which we're trying to build as part of a digital future in Europe. So this is all very well covered within these strategies. The initiative itself, we divide in three core elements. The first thing is the federated cloud-based modeling, simulation, and analytics platform, which we call often the core platform itself. Then the digital twins, these are the models of human and environmental activities on the planet, and they need to be on a new level of resolution and quality required for the Green Deal. And then, of course, there's data. As we heard the whole day already about, we are creating more data, we need to manage this data and have this very easy to access for our users. The funding for the project is from the digital regulation, which will cover the implementation, but the Horizon Europe program will support with funding for research and innovation activities to support the development of digital twins. So if you look at the architecture, you can see on the left side what important part this core platform will be, because it will be where the user comes and where the user gets access to the digital twins and the output, can control them, and the underlying infrastructure which will support all these activities. But not only that, but the users will be able to develop new applications, services, right next to where the data is, where the digital twins are running. So this is all what we heard already about cloud services will be all happening here. Very key to improve the quality of the forecasting and give decision makers much better data and information. The knowledge we can generate are the digital twins. So there's already 2 digital twins we have described and planned for. There's one on weather-induced and geophysical extremes, and then one on climate change adaptation. But these are only the beginning. There will be much more twins, which will about oceans, biodiversity, urban planning, which will combine with these twins and will build a bigger system in the future. This all will be, as I mentioned already in the previous slide, will be supported by Horizon Europe calls for the development of digital twins. So a quick word about the implementation. The implementation is led by the European Commission and especially DG Connect, but this is in close collaboration with many DGs at the European Commission. So DEFIS, RTD, JRC, you heard just, they're all involved in these to bring all the different developments together and ideas. We have 3 strategic partners we're talking to at the moment about the implementation. There's ESA, ECMWF, and EUMETSAP. Their specialities and their knowledge and expertise really maps very well to the 3 areas I described. We divide up the work of the initiative. I'm not talking here now more about it because Gordon in a second will be much more in detail what each partner will deliver. We're at the moment in the process of agreeing, finalizing the contribution agreements with these partners. And of course, we are very keen to make also use of the abilities of European industry, get them involved. And I mentioned already twice the research and innovation programs, which we're trying to bring into this one. Quick word about the timeline. As you see, we're just getting started, and we divided the timeline in rough 3 phases. The first phase over the next 2 years, starting this year, we'll be looking at the 2 twins I just described in the previous slide on the extreme weather and the climate adaptation, and the core platform, of course, because that has to be ready for more twins, which will come in the second phase from 2023 onwards. Also in that second phase, we will start to engage with public sector's users to get started, to get feedback and evolve the system. And then really in 2025, as I mentioned, there's more twins coming. Then we work towards a full digital twin of the Earth through a convergence of all these multiple digital twins of the platform. So I'm handing over now to Gordon because he will now talk more about the partners and the role.
Thank you, Stefan. Good afternoon, everybody. Can you hear me?
A bit quiet, yeah.
Okay, let me try and put the input volume up a bit. Is that better?
That's better, yeah.
Yeah. So you'll keep the slides, yes, Stefan?
Yes, yeah.
Yeah, okay, thanks for that. So good afternoon, everybody. As Stefan's saying, there's 3 implementing agencies putting together this whole digital twin destiny concept. ESA as the lead organization responsible also for what we call the core service platform. So that's how do the users interface with complex high performance computing based models. How do they do all the analytics, etc., as well as the underlying sort of infrastructure management, etc. The two core elements for the current phase, the two core digital twins, one on extreme weather, one on climate change. This will be managed by ECMWF, and these will be generating really huge quantities of data. We expect this to be a game changer in itself. In addition, there will be bringing in machine learning based improvements into some of these modeling capabilities and looking at optimizing workflows so that some of the more expert users that can interface directly with HPC capabilities are enabled to do that. And the third element in there is the so-called data lake. This is being managed by EUMETSAT due to their long experience in terms of managing operational data systems. And that's really putting where all the data are going to be, the data, the input data that are going to be used for the models, so from all the different Earth observation sources, as well as all the data that are being generated by the ECMWF models, and all of the other data that we're going to be needing as well in order to do the analytics around what the digital twin engines are generating. Can you go to the next slide, please, Stefan? Okay, so just a little bit more detail on each of these elements. So, like I said, I mean, a lot of the user interface infrastructure, if you like, is under the ESA control, as well as this sort of an advanced environment for interactive modeling. So, I mean, what tends to happen, what the sort of current state of the art is we have climate models doing forecasts against particular scenarios. We would be looking at how can we make that a bit more flexible and responsive to actual user, individual user needs for doing, in particular, things like what if analysis. So if there's going to be some sort of change against a scenario, how can we see how the climate climate parameters are changing, and then how does that impact in terms of some of the more downstream focused thematic domain models, so things like land allocation optimization, or crop yield and crop prices, or forest management practices, etc. So modeling these type of elements that are driven by the climate change or the climate models will be an element in this platform. So it's not just Earth system modeling. We're looking at ecosystem, human system, everything all being linked in the eventual implementation. Can I have the next slide, please, Stefan? Okay, so I say the ECMWF will be responsible for the actual digital twin engines, the high performance computing implemented models. So like I say, the first one is on weather-induced and geophysical extremes. So we'll be using that for things like forest fire, floods, etc. And the second on climate change adaptation, really looking at evolution such as soil moisture, sea level, etc. So that the Earth system climate parameters, as well as upgrading and extending these models to new parameters. Having some level of machine learning in there as well will be absolutely essential in order to ensure that we can respond to some of the particular user needs, and also looking at how we can ensure adequate infrastructure allocation to support the different modeling elements. And the next slide, please, Stefan. EUMETSAT is also, so as I say, they'll have the data lake. This is just an overview of how the data lake is interfacing in there. So we'll be basically, for now, it's the first two digital twins will be providing all these data, as well as data from the different Earth observation systems that will be used to drive the customized analyses and user interfaces. So things like Sentinel data, national Earth observation data, non-Earth observation data as well. Some of the things like population data, soil databases, etc. A lot of these things will be, we need to look at how we can integrate these into the data lake as well. And it's not just the data, it's also the aspects of supporting the data access, so things like online inventories of all of the different data sets that are there. Can I have the next slide, please? Just a little example of how this can work. We're running a couple of precursor activities as well, just to get a handle on some of the technical issues that are involved. So this is an example where we've been using a high performance computer-based land surface model called Jules. It's the UK system. So that's been generating climate data, in particular soil moisture, against particular scenarios. And we've been using a sort of an emulator-based AI capability trained on the Jules model to look at how soil moisture in particular parts of Africa changes with response to different forcing systems. So you can see there the main elements: a high-performance computing-based, sophisticated model, and the user customized analytics capabilities still, being really driven by the data coming from these high-performance models, but with a sort of a more interactive capability than is traditionally the case, where you just get, you get the models and you interpret them how you want. Next slide, please. I think I hand over to Paul to summarize the EUMETSAT contributions.
Thank you, Gordon. So in 1 minute, one message from EUMETSAT on Destination Earth is that we will do what we know how to do. So basically, we'll make sure that we can share as many data as we can through cloud and federated infrastructure, and make this data available to Destination Earth everywhere, including in Africa. This is something we've done already with the WIKEO, so you've seen, and all these data will support the different digital twins, some of them being highly relevant to Africa, like the climate one, but also the one which is planned on the oceans and which will be very, very important to Africa. So in short, we have really 35 years of experience of operational interface with users in Africa. We are delivering data to Africa and we'll continue to do so. And on top of this, we will contribute to the training component of Destination Earth. And with this, I give the floor back to Stefan for conclusion.
Thank you, Paul, and thank you, Gordon. Yes, and last but not least, I mean, how could that make a difference also for Africa, users in Africa? So, as already mentioned, I mean, the implementing partner, of course, will look out and engage with users in respective thematic fields to build the system. And so there will be a lot of engagement possibilities there. Then also the Commission itself, we will set up a scientific wiki, which will allow scientific users across the world, there's not a European limit here, to engage with us, also to see which direction we have to take, and also to see what opportunities we have generated. And last but not least, and it was just mentioned by EUMETSAT, is that of course there will be training possibilities, because this will be quite a different way of working. There will be new possibilities, which of course we want to make users too used to. So there will be a lot of training opportunities there. But as you have seen, this is a really young, new initiative, so please bear with us, but we're looking forward to all the feedback we can get on this one in the future. So thank you very much, and I give back to the chair.
Yeah, thank you to the three of you for this comprehensive presentation on Destination Earth. I would like now to quickly go to the last session of the session 3 on the perspective on African needs on digitalization, and I would like to invite Andisa Nhila, Managing Director of Earth Observation of the South African National Space Agency. Please, Andisa, you have the floor.
Thank you very much, Catherine, and I would like to take the opportunity to thank the organizers as well for inviting me to this to this platform. I'm just going to quickly share my screen and make sure I am on. Can you confirm for me that you can see full screen?
Yes. Perfect. Thank you.
Okay, thank you very much. So my task really is very easy, since we've had such gracious speakers in front of me covering some of the exciting aspects around digitalization, but also, sorry, I've got feedback, so I can hear myself speaking, which is, let me just see. Okay, perfect. So the speakers before me had already touched on some of the exciting elements around digitalization that are happening either in Europe or even in the continent, and also some of the needs actually have been started to be touched on. The question really that I started to think about when I was putting this together was the moving on from the notion of the dark continent, and this comes from the perspective of, are we starting from scratch, or are we building on something that already exists within the continent? And is a continent as dark as the notion tends to be put out? Of course, when you look at this image, you might be tempted to think that it is a very dark continent indeed, but actually it's not. We say we're already on the move when it comes to digitalization in the continent. If one looks at simply the statistics around the increase in mobile phone penetration, especially the innovations that the mobile phone technology have brought for us in terms of the financial sector, which we would like now to take those and put them in much more broader and other sectors within the applications of the mobile technology. The continent has high performance computing capabilities, world-class. One of those systems or centers sits in South Africa. Ghana has similar platforms, so does Kenya and Zimbabwe. The satellite and drone technology, I mean, this is what we've been talking about since this morning in terms of the applications and the kind of data sets that are available, as well as the data exploitation platforms. In South Africa, we're talking about Digital Earth of South Africa. We've just heard now about the DIAS system from the European perspective. And of course, we have a growth in data scientists. The Zinti platform hosts over 2,000 data scientists throughout the continent. If you have a challenge, a societal challenge that you want the data scientists to look at, including those that could be solved by Earth observation, you put the challenge online, and the data scientists come on board and work on giving you multitude of solutions. Entrepreneurship and innovation, we cannot stress this aspect. We cannot stress this aspect more. There's a lot of innovation that's happening in the continent. One of the examples I've got on the screen, there's a water volume system that's developed by one of our SMEs that gives you a water quantity on all of our major dams in the country, enabling the Department of Water and Sanitation to make immediate decisions. Green technology, as we know, we are in the technology space, but we want a green environment. And there are solutions that are used to make sure that services are quickly delivered to those who are struggling, especially when we're trying to address the triple challenge of poverty, equality, and unemployment challenges, especially so when we're looking at the urban and spatial planning sides. Availability of cloud services, the establishment of the massive data centers within the continent, one of those which has just been put up in the Western Cape. Actually, we have two, because for the square kilometer array, we also have a data center that's been built, and most of that technology for the square kilometer array has been built by South Africa with the South African engineers and technologists. One of the major platforms that globally we have in Africa and Europe as well contribute and also benefit from is the Group on Earth Observation, with the notion of a system of systems that was to be developed. Here we're talking about Digital Earth Africa as an example of a continental Earth observation program that is using Sentinel data, Sentinel-1 and Sentinel-2 already on analysis-ready platform. Through these platforms, we also get the cloud credit programs, which have enabled more of the remote sensing or Earth observation community to start tapping on the algorithms and data analytics and playing in that environment within the cloud, and therefore not only building capacity in terms of access to infrastructure, but also building capacity in terms of the analytics side. The GeoKnowledge Hub, the JRC has touched a bit on this in terms of what the JRC is working on. The idea around the geo when it comes to the Knowledge Hub is to making sure that when we're talking about knowledge, whether we're talking the science behind the Earth observations or we're talking about the algorithms that drive the digitalization, we're talking talking about elements that are reproducible, replicable, and generalizable, because only then we can say we're building capacity and we are truly on the move towards digitalization. And of course, we cannot do this without collaboration and ensuring that individuals and institutions are appropriately enabled, and that's where activities like AfriGeo are playing a role in. Most often when we talk about the digitalization, we tend to talk about it on the sidelines around the equality, diversity, and inclusion. And Geo has started to drive that technology needs, even Earth observation needs to ensure that it puts out products and services that empower through accessibility. But the biggest question, of course, with the task that I was given was how do we scale? How do we scale? And African countries need not be any different from any other global countries in terms of understanding that investment in technology and education are critical for digitalization, as we've been hearing so far, but they're also the pillars of the economic growth, because as much as we talk about the knowledge economy, at the core of the knowledge economy is knowing that you're actually putting the right investments in your technology and you're putting the right investment in education. And of course, the investment in technology, we have to see technology as not only just being tech, but it also must be the institutions and the people that the technology is meant, the tech is meant to service. Access to internet, I think with the UNRANs, this has already been touched on. Most of the time, as I've said in my last slide, we talk about the penetration of the mobile within the continent. But one of the things we need to note is that only 9% of that is connected to 4G. We're not even talking 5G yet. And most of that is connected to 2G. So the solutions we're putting forward through digitalization, we need to make sure they're actually taking into cognizance the level of the internet access. The cost of data is crippling in the continent. There are countries where you have to pay about $30 US for 1 megabyte of data. Truly not affordable. So when we put these solutions out, we need to know that we are faced with these challenges. How do we talk about digitalization when 82% of the learners in the continent lack internet access, or have no computers at home? Personally, myself, the first time I touched the computer, I was at varsity. It was first year at university, the first time I touched a computer. And it's sad to think that a couple of decades later, that reality is still there for most learners and within the African continent. And we also need to look at building inclusive digital skills. So you can put the technology in there, but if people cannot use the computers and if people cannot code, so we start talking about coding for girls, for example, to try and close the gender balance within technology, but it's also building these inclusive skills that you're actually needing to have. And enabling entrepreneurship, we know that Africa needs to have its own industry, especially when it comes to the space space sector, because this is the only way that we can accelerate digital access. And the enabling mechanisms around this is the finance, and the business incubators and the space incubators. One of the things that Dr. Aldrisi addressed earlier on is around this notion of coordination and collaboration. He talks about these shared business models, but we need to look beyond these business models. We need to talk about the markets and the finance. Africa is not just a market for the international community to go out and seek markets outside the continent itself. Maybe to close, because the shared data infrastructure is something that that's been stressed on. We need to be intentional when it comes to equality, diversity, and inclusion, because if we're not intentional with all the digitalization that we're putting in place, we're likely going to increase the digital divide rather than close the digital divide. And we would likely be taking the continent back to this notion of a dark continent instead of moving it way out of the notion of the dark continent. That, I think, will be my last slide. Thank you very much.
Many thanks, Andiswa, for your presentation. Very, very, very interesting. Now, in principle, we have a question and answer session, but I think that we don't have the time. I would like to see in the chat. I haven't seen a lot of question or any question. So I think I will hand over to Hugo in Lisbon in order not to delay more the other sessions.
Thank you very much, Catherine. Thank you very much, Benjamin, also for being our rapporteur. It was not easy because we have great speakers today, and so it's very difficult. We'd like very much to hear them. So thanks for moderating this session, and without further ado, we are quite delayed, so let's move forward to our session number 4, Future of Earth Observation. For this session, we'll have as moderator Kizito Odiambo, from CEO of Agribora, and we'll have as rapporteur Vincent Gabaglio. I will ask for all the speakers, if you could please keep with the times. This would very much help us to keep focus also on your presentations, and to save us some time. So I will give the floor now to Kizito. I believe you're now online. Thank you very much for accepting moderating this session, and the floor is yours. Thank you.
Thank you very much, Hugo. Good afternoon, ladies and gentlemen, both online and in Lisbon. Welcome to session number 4 on the future of Earth observation. I'm very pleased about what we've been able to hear so far in the past 3 sessions, and I thank all the participants and speakers. My name is Kizito Odiambo, and I am your moderator for this forward-looking session. I am the founder and the CEO of Agribora, which is a German agri-tech company that is developing satellite-based products and services for smallholder farmers in East Africa, and I send you many greetings from Kenya today. I'm excited about the presentation and discussions we are going to have, and this session is going to focus mainly on what is planned in the future of Earth observation. So going into the future, with what we have had this morning and also this afternoon, we are going to be looking at systems such as Copernicus 2.0, the Meteosat 3rd generation, and the Atlantic constellation. And of course, we are going to focus on the interactions between Africa and Europe in this context, which make it even more interesting, especially also for me, who is an enthusiast of Earth observation and a young person, looking at what I can expect going into the future with Earth observation. It has been an enriching discussion so far, looking at how we are trying to address the issues of Earth observation and evidence-based decision-making for the Sustainable Development Goals. We've been looking at the infrastructures, the DIAs, we've been looking at the digital twins. And so this is a very important session for us to help us look at what are the opportunities as we go forward with already the challenges that we have identified, but also the opportunities that we are already working on from different agencies and organizations. Without further ado, I would like to invite our presenters for this session. We are going to have 2 joint sessions and then 2 further presentations from ISA and SANSA. I wish to now invite the presenters for a joint presentation on Meteosat 3rd generation challenges and opportunities. This will be presented by Phil Evans, the Director General of EUMETSAT, together with Madam Marianne Diop-Kane, the Program Manager of AMCOMET, which is the African Ministerial Conference on Meteorology from the World Meteorological Organization. I wish to welcome you both for this session, and I believe, Phil, you will be taking the stage. The floor is yours. Welcome.
Thank you. And good afternoon. Good afternoon, everyone. It's a great privilege to be talking to you this afternoon on such an exciting topic. Firstly, I'd just like to say a big thank you to the EU Portuguese presidency for organising this important event 14 years after the GMES Africa event that was held in Lisbon. And I'm very pleased to attend, and EUMETSAT is very pleased to participate and contribute in this event, because as many of you know, we have a long-standing cooperation with Africa, which is the bedrock on which we can build our relationship moving forward to new missions, but is a relationship that we will need to foster further maximize the benefit that we'll get and society will get from our new platforms. As has already been said, I'm very pleased to share this presentation with Marianne. If you can move on to slide 2, please. So EUMETSAT has been operating Meteosat satellites over Africa for more than 40 years. And that continuity of coverage and the link between subsequent missions is incredibly important to our users in Africa and indeed users everywhere. And continuity of this data coverage is incredibly important. And this is one of the benefits of having a long-term operational program, such as we are fortunate enough to have, that enables us to have this continuity. These first 40 years were covered by Meteosat first and second generation, and we are very soon to launch and then make operational Meteosat third generation, which will be serving Europe and the African continent for another 20 years. I'll talk a little bit about the new platforms in a second, but it's worth thinking that these platforms have a technology that's 20 years in advance, nearly, of Meteosat second generation. So we could anticipate, and indeed we'll deliver significant improvements in performance. Next slide, please. You will have seen in previous sessions how data from these satellites are used for climate, weather, marine, and environmental services. And these are just some of the potential applications. I think as we've touched on before, having a connected, informed community of users and the ability to innovate and generate new services is incredibly important to make sure that society maximizes the benefit from these platforms. And here we see a few relevant examples. The ability to, in real time, track and improve the forecasting of severe weather events, estimating precipitation and subsequent soil moisture content, detecting severe convective events and therefore being able to predict upcoming flash flooding events that can be so devastating and so impactful on local communities. Supporting, and this is a product from Ahmad, supporting the development of dust monitoring, and obviously the linkage through to health impacts there. And there are a wealth of other valuable services and applications that deliver benefit to African society. Next slide, please. The new Meteosat third generation is, as the slide said, it's arriving. We're expecting to launch at the end of next year, and formal operations of this system will start from 2023. And we expect and hope that the sequence of these missions will provide continuity of data for the next 20 years. The platform actually includes two types of satellite. It has Meteosat Imager and Meteosat Sounder. And I will now talk a little bit about the Imager platform, as it is here that we provide continuity with the current Meteosat second generation, while bringing really crucial and exciting improvements that will, I believe, be so important to our African users. Next slide, please. From the Imager, the crucial improvement, I suppose, is enhanced spatial resolution and enhanced timeliness. If you look at the two images on the slide, you'll see a comparison between the image resolution that's available now and the image resolution that will be available under the new system. A 1 kilometer resolution that we'll be able to update every 10 minutes. And you can see just visually the incredible difference in performance. And this, both directly as imagery and through products and services developed off the back of this imagery, is likely a really significant impact. Next slide, please. Oh. The second major improvement I just wanted to touch on with the system is the lightning imager, which is the first time we've flown an instrument of this type, which basically is able to detect lightning flashes over the region. And as I'm sure you're all aware, there's very high flash density over sub-Saharan Africa. And actually flash detection is incredibly important as a method of supporting forecasting, supporting the understanding of severe and location of severe weather events. It's a very good diagnostic for that. And in particular, it's critically important for the operation of transport, particularly aviation and operation of safe aviation services. So this, I think, is a critical and exciting innovation for the region. So I think very briefly, I think these illustrate some of the critical and exciting new enhancements that the new platforms offer. And at this point, I'd like to pass the floor to Marianne for a presentation on how Africa intends to tackle the challenges and opportunities presented by Meteosat third generation. Thank you.
Thank you, Phil. Good afternoon, everybody. Thank you, moderator. Thanks, Phil, for this quick history of Meteosat satellite and the few opportunities and benefits that MTG can offer. You see that MTG will be shortly launched by the end of this year, early next year, and data will be available from 2023 to 2040. And we need continuity from MSG. MTG will offer a lot of additional capabilities. The lightning imaging, improve time and spatial resolution. We're going to have data every 10 minutes at a resolution of 1 kilometer or even less. This is going to be really lots of data. From MSG, we are having 1.5 megabit per second. And for the first MTG, data will be triple 10 times, 35 megabits per second. And the atmosphere will be improved. We're going to have a better monitoring of the environment, better representation of the wind, better representation of convection, and the lightning, as just Phil said it. So this will improve definitely the monitoring of the weather system. We are going to have a better numerical weather prediction and early warning systems. But what are we going to do with all this data? Even with MSG, Africa were not able to use all of them. So we need to prioritize. And this discussion has been going on with RADEC, the WMO Africa expert group on satellite data dissemination. So we've been prioritizing, and we kept recommending and emphasizing the need to increase the capacity in Africa, both in terms of human and infrastructure. Next slide, please. So this ended up with an Abidjan declaration during the user forum in 2018 at Abidjan. And the Abidjan declaration has been signed on the 24th of September by the Minister of Transport of Côte d'Ivoire, the AMCOMET chair, the Minister of Agriculture of Cabo Verde in charge of meteorology, the AUC commissioner, as you can see in the picture, Excellency Joseph Asarco, and the regional economic commissions. This Abidjan declaration had been submitted to the AMCOMET fourth session in Cairo and has been endorsed and submitted later in 2019 to the AUC Specialized Technical Committee, and it did endorse it as well. Next slide, please. The Abidjan Declaration, so the signatories of this declaration encourage and support the strengthening of the African capacities to ensure a smooth transition to MTG. We shouldn't be having a breakdown of data access from MSG to MTG. and further strengthen the African capacities in satellite meteorology by exploring the feasibility of developing and establishing an African meteorological satellite application facility, as we are having in Europe. It's high time for the Africans to be putting hands on the satellite products and develop tailored products for their users. These many projects had been going on for 20 years or even more, but I think that this declaration really wants to build the capacity of Africans and make them develop products for their users. Further, the Abidjan Declaration calls on engaging with the European Union to put MTG and AMSAF in the joint EU-Africa strategy and call on WMO and UMETSAT for technical cooperation. It further encouraged to develop an action plan and constitute a joint working group to monitor and facilitate the implementation of this declaration. Next slide, please. So this Abidjan Declaration, as I said, had been approved at the AMCOMET session in 2019 and approved at STC. And the joint working group has been established in Abuja in October 2019. It's composed of the African Union Commission, the REX, including the Indian Ocean Commission and UMA, with their technical experts. It includes as well the European Commission, UMETSAT, WMO, and AMCOMET secretariats. And UMETSAT and AMCOMET secretariats are the secretariat of the joint working group. Several meetings have been going on, and the joint working group has agreed on an initial concept for an MTG Africa program that will ensure, as asked by the Abidjan Declaration, to ensure a smooth transition from MSG to MTG and implement an African meteorological satellite application facility. So this concept, I would say, is just a continuation. It will be a successor of the other project, the Puma one, MSD, and MESA. But this one has something slightly, a new component that is establishing the AMSAF, really capacitating Africans to deliver, to produce their own products, and with a very strong research and development component to be able to develop products needed in the African continent. So this initial concept has also been submitted at the 5th AMCOMET session that took place in March this year, 2021, and it had been endorsed. And during this AMCOMET 5th session, the new strategy, updated African integrated strategy on meteorology has also been approved. And this includes a component on MTG in the second strategic pillar, where strategic pillar on data and infrastructure. And we want to make sure that Africans, particularly the National Met Services, have good access to Meteosat data, and particularly the MTG. So this African Abidjan Declaration, as I said, had been up. Next one, please. So still in terms of preparation, a joint webinar has been organized by UMETSAT and African Union Commission and AMCOMET on MTG. It's not just to, it was not just to prepare a concept, prepare a project for Africans, but we have to explain them what MTG will offer them, what opportunities they have and the challenges. And this webinar had taken place on the 31st of March, 2021. You have a very good turnout, about 400 participants registered, very good participation from from Africa, about 44, I think, countries out of the 54 registered, and most of them were from the National Met Services, more than half, followed by universities. So you see the interest of the African on Meteosat data on MTG it covers very well the African continent and offers a lot of opportunities. Next slide, please. So to summarize, you've seen that MTG will provide a continuity of the already existing 40 years of weather and climate observation over Africa, and it will provide unprecedented quantity of observation over Africa for the next 20 years. We have a lot of opportunities for Africa, as MTG, in synergy with Copernicus, can improve Earth observation-based services for agriculture, water management, fisheries, health, transport, disaster risk reduction, and climate. But we have more challenges, which are mainly in terms of data access, infrastructure, human resources, capacity to receive and process the new MTG data. But what is good is that we start preparing a long time ago, and African ministers and institutions are fully aware of the importance of transition to MTG and have already approached the European Commission for a joint effort to support transition to MTG and establishing an African meteorological satellite facility as in Europe. I will stop there. Back to you, moderator. Thank you for your attention.
Thank you very, very much to both of you, Phil and Marianne, for your presentations, and particularly the outlook, especially on the improvement of performance and the continuity of data that we are expecting for the next 20 years. And we wish that mission a success as it launches in the next year. I have not seen any question yet in the chat, and due to the time limitations, I would take the initiative to invite our next joint presentation, which is going to be on the Atlantic constellation, and a presentation by Mr. Miguel Bello, the CEO at Air Center, and Mr. Stuart Bernard, the Chief Scientist at the South African National Space Agency, SANSA. Mr. Miguel, the floor is yours. Welcome.
Thank you very much. Thank you very much, moderator. And well, the Air Center is an international organization to develop scientific and technological application, mainly based in Earth observation in the Atlantic region. We have member countries in Africa, like South Africa, Namibia, Angola, Nigeria, Cape Verde, Sao Tome, and soon Morocco. We have countries in Europe, Portugal, Spain, United Kingdom, Norway, and soon France. But we have also countries in America, like Brazil, Colombia, Mexico, United States, and soon Canada. We are running many Earth observation projects on the Atlantic, dealing with energy offshore, dealing with desalination, or detecting plastic on the ocean from satellites. But today we want to present our flagship project, the Atlantic Constellation. The Atlantic Constellation is to be developed in very close collaboration with the Portuguese Space Agency, but also with several countries of the Air Center. Those countries so far is in Africa, South Africa, and Nigeria. In fact, South Africa play an important role, and Stuart Bernard from SANSA will give later on the view from South Africa of the constellation. But we have also countries in Europe, like Portugal, Spain, United Kingdom, and Norway. And in Africa, the countries are Brazil, Mexico, and Canada. Well, the idea is to do this by the industry and by scientists from those countries, and to be used at that wherever the constellation overfly your country, you get full control, and you share so that the cost of deployment is just a fraction, because it is shared between many countries on the Atlantic. Let's go to the preliminary constellation definition. What I'm going to present is still preliminary. It has to be reviewed by the 9 space agencies and has to be reworked. But first of all, how do we set up the requirements? It comes from our missions. We have 5 missions, and the 5 missions are mapped to requirements. First mission is clean and productive basin stories that give us needs of coastal erosion monitoring, ocean pollution, water temperature increase, sea level rise. Second is resilience to coastal natural hazards. That means climate change monitoring and mitigation of natural disasters like tsunami, flooding, earthquake, volcanoes, fires. The third mission is sustainable food production, leading to requirements like sustainable fisheries monitoring, fisheries protection, sustainable and optimized aquaculture, or algal bloom detection. The next mission is improve management of marine and coastal resources. That implies biodiversity monitoring, communication system for ocean animal tracking, but also the monitoring of seagrass, corals, and sargassum. The last mission is an improved environmental and maritime monitoring, which leads to ocean atmospheric cryospheric interaction, coastal chain adaptation analysis, ocean pollution and acidification. Well, all those leads to a very long list of requirements. And those requirements are mapped to physical measurements. What are the physical measurements which allow us to give a solution to those needs? Well, we did a list of those physical measurements, which is sea surface temperature, ocean chlorophyll, hyperspectral, multispectral imagery, vessel monitoring, all those lists. I'm not going to go to the detail. An important thing is, which is the spatial resolution, which is the revisit time, which is the latency that we need. And all those measurements, including currents, a wave, a wind, for most of the application, like tsunami alert, like algal bloom early warning, they need a very high revisit time, many times less than 3 hours. What that means, that we need a constellation to be able to provide such a high revisit time. We do not want to duplicate what Copernicus is doing. We have sophisticated sentinels giving valuable data, but this is complementary. We're looking to complement sentinels with lower quality measurement, because that will be done with smaller satellites, but with a very high frequency that complement the existing sentinels. Well, what type of sensor do we need? Those are the sensors which match the physical measurements, which is AAS and VDS for vessel tracking, hyperspectral, multispectral optical imagery, GNSS reflectometry, and Internet of Things transponder. There are other highly interesting sensors like ADS-B, microwave atmospheric sounders, microwave radiometer, infrared sounder. But for us, this is nice to have because we want to have small satellites. Then we prioritize passive sensors in order to be able to work in smaller satellites with respect to highly sophisticated active sensors. Well, we did the preliminary constellation design. We selected an orbit altitude of around 670 kilometers with 3-day repetition cycle. This is a compromise, a trade-off. I mean, the higher, the better coverage for vessel tracker, the lower, the better resolution. And in a compromise is this 3-day revisit. This is the field of regard of a single satellite in a full day. We select orbital planes to give 3-hour revisit time. We need 4 orbital planes. This is the optimum selection of the orbital planes. And if you allow an off-nadir angle of 30 degrees, you need 4 satellites per orbital plane. If you have 4 orbital planes and 4 satellites, that means 16 satellite constellation is the optimum design for the performance we want to have. This is to be sure that every orbital plane say every single point of the Earth. This is the field of regard of satellite 1, satellite 2, satellite 3, and satellite 4 of the constellation. Then every single plane can see any point of the Earth at every passage. Those are the orbital elements of the 16 satellites. And this is how the constellation will look like. This is the AES vessel tracking monitoring, and those are the region which is covered by each satellite. That's in a 2D, but better to see it on a 3D dimension. You see, there is a very frequent data of every corner on the Atlantic Ocean. And we did a full performance analysis. The global mean revisit time is 2.9 hours. That means it satisfies the requirement of less than 3 hours mean revisit time. On the equator will be over 3 hours, but on the pole, we have less 20 to 30 minute revisit time, which is very nice for ice monitoring. Regarding vessel tracking, the gaps we have has an average of 13 minutes. That means it's also very good performance. You have only 30 minutes gap in vessel tracking. We also design the ground segment. It must be so sophisticated because we want 1 hour latency. I mean, it is not a sense to have less than 3 hour revisit if later on you have latency of a day. That means sophisticated telemetry, telecom and ground stations. Collision avoidance, space debris collision avoidance is important because we expect to do collision avoidance maneuver for space debris normally once every month for that systems. This is a simulation using 3 stations, using Azores Island, Santa Maria, using Sweden, Kiruna, and Fairbanks in Alaska. That's the way we will cover that. We have contact with every single satellite, every single orbit. This is the number of contacts we have in 3 days, the repetition cycle. If we do zoom to see something, that means we need 1 antenna in Azores, and we need 3 antennas in the polar stations. How many data we can download? We can download 43 gigabytes of data every 3 days. That means a huge amount of data for the ocean. What type of sensor? There are existing COTS sensors. Those are cameras which are already available and manufactured in the countries member of the Earth Center. Those are manufactured in South Africa, in Brazil, in Europe. I mean, there are existing COTS which are able to be used in this constellation where there's no need to reinvent the wheel. In summary, we are planning multispectral, hyperspectral camera, Internet of Things, and AES receivers, and GNSS reflectometry. We did a full power analysis. We need between 25 to 30 watts of power. There are some planes very well illuminated. We don't need deployable panels, but there are 2 planes which have bad illumination. We need to deploy some panels in some bad illuminated planes. We did a full constellation control. This is the altitude control. That's the eccentricity control, argument of pericenter. We have full control. Then we can control the constellation with a very low cost in terms of propellant. This is the mean local solar time maintenance. We can keep it in plus minus 10 minutes just only with passive. That means by introducing some delta in the inclination and some delta in the ascending node. Those are the orbital elements with the deltas that we need not to do maneuver to change the plane, to keep in that for 7 years. It can be kept 7 years with no big modification. An important thing is to be clean. We cannot make a constellation which stay there forever so that we put problem for space debris. We need to be compliant with United Nations regulation for space debris, and all our system can be in orbit only 25 years. That means at the end of the life, we have to do a maneuver to put it down. We need 52 meters per second maneuver to make an end-of-life disposal of the satellites. That means the total required propellants, that's funny, but most of the propellant is needed for space debris. We only need 10 meters per second to keep the altitude, but we will need 50 meters per second to clean the space, and we need also about 3 meters per second to avoid collisions on space with other spacecrafts. In total, if we have a sophisticated low-thrust electric propulsion, we only need 130 grams of propellant. What that means? That means that we may have small satellites of the order of 12 to 16 use size. We may have also only panels with 25 to 30 watts of power. We need only a battery of 5 ampere hours. We'll need a downlink capability of 100 megabits per second. We'll need pointing accuracy of 0.1 degree. We need also a capability to do off-nadir pointing plus minus 30 degrees to have an electric propulsion. As I said, this is the very preliminary Atlantic constellation. We look forward to collaborate with Africa, with the African countries, European countries, but also with America to make feasible this constellation at the Earth Center. Thank you very much. And now we go to the view from Stuart Bernard from SANSA, which is the complementary view from Africa of this constellation that we are working with. Please, Stuart.
Thank you very much, Miguel, for that excellent introduction. So I think it's important to get the viewpoint from collaborative partners. The collaboration and the scaling aspect is a key part of the constellation attractiveness. And I'd just like to go through and present the view from SANSA, as to why we would find the Atlantic constellation such an attractive option. So, that. So of course, we're very interested in the observations at new scales. This is very important, those downstream benefits of getting to, overpass times of 3 hours or less at new spatial scales, perhaps new information density from hyperspectral sensors. That's critical. The community capabilities and the downstream that those would bring would be very important. Obviously, one of the main things we're interested in is the upstream African space industry development. And I think this is where we're starting to introduce a new aspect of innovation into the European-African community interaction. And then, of course, the scaling of the infrastructure that Miguel spoke of. So in the long run, we'd be looking at, towards the sustainable development of the South African space industry from SANSA perspective, the products and services, but also contributing to the geo vehicles, the geo Earth observation platforms, and particularly where possible, the full, free and fair aspect, which is key to the community capability. Sorry, there we go. So why is SANSA interested in small sats? Well, pretty much for the same reason that everyone else is: low costs, modular, very rapid development and evolution cycles, the ability to bring new technology on board. And this is particularly true if, for example, you have something like a concurrent design facility that allows very rapid design changes, and South Africa is investing in that. South Africa has a strong nano and microsatellite heritage. I think we're due to launch our third CubeSat, which is a maritime domain awareness satellite, next year. And another critical part of the thinking is that in addition to the use of domestic industry builds is also, of course, the use of our own domestic mission user requirements. And that's an important part of the collaboration. So currently there are two models that we're looking at to develop the constellation. They're converging. They don't need to converge very quickly. The flexibility is good up to a certain extent. So this would be a minimum constellation requirement with a contribution of domestic builds, or, for example, common multilateral spacecraft that might involve South African sensors, UK buses, Portuguese subsystems, etc. The way we'd like to see it going is to start with multiple Pathfinder missions. This is best practice, I think. It allows an evolutionary approach. It minimizes the risk. It lowers the overhead for investment in the constellation. So obviously we'd prefer either a domestic build or bi or multilateral options for a South African built Pathfinder. This is why we're suggesting multiple Pathfinders. And obviously, again, looking at our domestic and industrial development. The main mission types that we are seeing interested in is approaching the high resolution. So this is really more of an imaging application. You can see a very wide range of applications there, and there's scope for that to be a disruptive commercial offering. And then two more science-driven sensors, hyperspectral moderate resolution sensor. Miguel spoke about the availability already of cameras, and we would try and actually push this a little bit up towards, as much as possible in, for example, a 16U satellite, but to try and get to some reasonably high precision radiometry, and then also look at high resolution thermal sensors, of which I think there is a little bit of a gap in terms of the new space landscape, and look at those as variants on fall free and open if possible. So I did speak about the user requirements. I won't go into this in any detail, but obviously we need to be informed by our own programmatic and mission strategy with regard to the upstream, and that will then inform the more classic kind of sectoral user requirements, and would also, for example, include, again, if we took a hyperspectral, for example, a kind of detailed analysis of what kind of sensor you would need both for water and terrestrial applications. So we would see a convergence that would look something like this. There's a convergence pathfinders that would include a user requirement developments and convergence on those into a kind of phase one, building the constellation. And then, of course, part of the attraction of new space sensors is to be able to evolve your constellation. So down the line, we would see the ability to add new technology, adapt the spacecraft, evolve those. And thank you very much.
Thank you very much to both of you, Miguel and Stuart. Very interesting and enriching approach to look at the design and the user needs that have been used for the specifications, particularly for the Atlantic constellation. Thank you very much for your presentation and for showing us your work. I have, if there are any questions, please send them into the chat. I have not seen any questions at this point. I see one question that has already come in for SANSA. So Stuart, would the data be accessible free of charge to Africa? Can you take that?
Yes, I think that would depend upon the data. So we would be very keen to make as much of the data free and fair as open. We particularly see that as relevant to Africa. There are aspects, for example, around the higher resolution data where we would have to consider exactly how disruptive that would be. And of course, it would be a constellation decision. So there would have to be consensus on how we arrived at that. But in principle, we would aim to open it up as much as we possibly could.
Okay, great. Thank you. Thank you very much. We do not have any other questions, so I will thank the two speakers. One thing that I'm also noting from the chat is to just have a communication strategy to make known, to make the data known, which data will be collected and how that is going to be available. Thank you very much once again to you, Miguel and Stuart. I would like to now invite Mr. Simon Yutz, the head of Copernicus office at ESA, to share his presentation with us about the Copernicus evolution and new Earth observation technology. Welcome, Mr. Yutz.
Hello, yes, can you hear me? I'm trying to share my presentation, but it asked me something on open system preference. I hope it doesn't take too long.
Yes, Simon, we can hear you very well here from Lisbon. We don't have yet your presentation, and let me know if you have any issues so we can try to solve it from here. We don't have much time, so perhaps we will have to skip the questions. Maybe the questions can then be sent by email, but Simon, floor is yours again.
Thank you. Can you show my presentation, which I sent, because it seems that on my, I don't know why I cannot share my screen.
No, apparently there's, the presentation didn't reach the...
No, I sent it.
The team, we are trying to solve it. I don't know if you can give access to Simon to share his screen.
Very strange. I did this before, so whiteboard cable.
The team here is trying to solve the issue. Give us a bit more.
I sent to Ines presentation. So
yes, Ines, she's affirming that she received. We're trying to see if...
Simon, I do have your presentation. If that would be okay, I can share it from my side, if that's possible.
Yeah, please do so, because
perfect.
I'm very sorry for that.
We can see now.
Okay.
Yes, we can see now the presentation. So
if you can go to the first slide, yeah, please.
Perfect. Just a moment, it's coming up. Okay.
Yeah, we can see it here. Perfect.
Yeah, can you go to the first slide, because it's the fourth or so, what you're showing? Before to the first slide further. Yes, here. Okay, next slide. Now to the second slide. So ESA has several threads of development for Earth observation satellites. And here on the left, you see the Earth science missions, which include also the Earth explorers. And on the very right side, you see the meteorological program where ESA develops the satellites, and EUMETSAT, our partner, is operating them. And in the middle, you see the Copernicus program and the space segment of it. And if you look into 2021, you see we only started with the first 8 satellites, but there a lot to come. And overall, as you see, overall, ESA is operating 16 Earth observation missions, but 38 are under development. And the next first generation Sentinels are already ready to be launched. And then comes, of course, the so-called expansion missions, which I will talk about. And we have also a line which is the next generation missions, which come and is an improvement of the first generation. Next slide, please. And here you see the launch dates of the first generation. In green, you see when they were launched, and you see we have still a lot in store. So this makes sure that there is a long-term data provision to our users. I don't go now in detail, but you see these are radar missions. Sentinel-1, Sentinel-2 is high resolution optical, medium resolution optical and altimetry. Sentinel-3, Sentinel-4, 5 and 6 are atmospheric chemistry missions, and Sentinel-6 is a high accuracy altimetry mission, and we have a precursor which is already was launched in the atmospheric chemistry mission, which is Sentinel-5P. Next slide, please. And then we have another line which we started to develop already, and we have contracts to industry, and these are the so-called expansion missions. So we have a CO2M mission, which is an anthropogenic CO2 monitoring missions to look into the causes of climate change. We have crystal, polar ice and snow topography altimeter, which looks into effects of climate change. We have CHIMRE, passive microwave radiometer, which we will use to determine the sea surface temperature and look very detailed in the ice concentration. We have the LSTM, land surface temperature mission, which will be used in agriculture to determine the water amount and productivity in agriculture. We have CHIME, a hyperspectral imaging mission will be used for food security, and this will be particularly interesting for Africa. It looks into the soil properties, mineral prospection, biodiversity. And then finally, ROSE-L is a L-band SAR mission, which is to differentiate between vegetation times, looking into ground motion and moisture. Next slide. And here, just to give you an idea, the Sentinel data, Copernicus Sentinel data are free, open and full. All data are available to users on an open access hub. And only on this hub already, we have more than 430,000 users. These are data users. This is only a tip of the iceberg, because you have to imagine that in Copernicus, we have also core services in different areas, and the user of these service information products can go in the billions, because our data are also picked up by geolocation applications like Google Maps, where of course there are billions of users using Copernicus data. There are many apps which using this, but these are the direct user using, starting from the basic products we have, and you see here the download volume. So it's very successful. Next slide. Now I'm coming to the next evolution of the Copernicus. We call it Copernicus 2.0. So this are further developing the dedicated Sentinel missions, which are developed by ESA. And this includes the expansion missions, but also the next generation of the first generation Sentinel flying now. But also additionally, we will systematically complement, enhance the Copernicus Sentinel data offer with a number of commercial new space constellations. as was mentioned by Miguel in the previous talk, for instance, these typical missions which can complement the Sentinels. And we are planning in the coming months and years to have a kind of ESA and Commission have an anchor tendency on a long-term data buy scheme. So this is our approach also to have the new space missions or new space similar missions in our portfolio. Next slide. And this would be then a fourth thread of development, which would be ESA as an anchor customer for very high resolution Earth observation data and other Earth observation data. And you see here, this would be supported also by ESA programs like InCube, where we develop new space missions or help to support, particularly in the instrument development and in the qualification of these missions. Next slide. And here you, just to give you an idea, we look, of course, as ESA also in the research and technology. So this is on the level of instruments on the platform. And also we try to qualify these instruments with airborne campaigns. I'm not reading now all these different elements, but these are just examples that we work on all areas. We have ESA program for this. Next slide. Okay, now I'm coming just to some examples, and I make this short just to give you an idea what, for instance, a land surface temperature mission could bring to Africa. So we could get a better idea of the increasing temperatures and changes in the precipitation, reducing crop productivity. So overall, to say we could really monitor climate change better and to a much better level as it is done today. So this helps then politicians or decision makers really to make the right decisions. Next slide, please. Here, just an example. Our Director General actually got a call from the Republic of Congo to help estimate the threat of the lava from Mount Nyiragongo volcano eruption on the 22nd of May, if it will reach Goma, city of Goma, and we could, as a charter, international charter for space and major disasters was also activated, and it could be very quickly mapped on the same day actually with different sensors. I didn't include here, we made also in the meantime interferograms to really determine the different motions, what happened when because when the lava flows out, there's of course also a dilatation of the volcano and so on. Next slide, just examples. Yeah, here you see also mapping the lava flow which reaches the outskirts of Goma. Next slide, please. Just to show you, of course, we do a lot of change detection here. A simple example, Google started the Earth Lab it's called Earth Time Lapse initiative, where they have a huge database and they use here as an example Sentinel-2 for these time changes. 84 is of course not Sentinel because our first one was in 2014 launched, so this is Landsat, but you can we have now so many data that you can very easily do this time change comparisons. And you see here, you can look in many other examples if you follow the link, which is here below. Next slide. This I will skip because there is a little movie, but I think here is only the PDF file, so I'm sorry that I couldn't show this with my PowerPoint slide. Next slide. Now I'm coming to data access also for Africa. As I said, Sentinel data in principle are all available on the data hub. But of course, here you are competing with the whole world. But Africa has a preferential access to this data because the European Commission concluded a cooperation arrangement with the African Union Commission. And now ESA started technical cooperation arrangements, next slide, with several institutions which were proposed by the African Union Commission. And here you see that we made over the last year several tests with these ones, and we are now ready to sign these agreements if the Commission approves them. Here with the Centre de Suivi Écologique in Dakar, with Institute in Gabon, Libreville, with SANSA, with the National Authority for Remote Sensing and Space Science in Cairo, with the RCMRD in Nairobi, in Mauritius Oceanographic Institute. So we are really working together here to give you a preferential access to an international hub where you have less restriction in terms of bandwidth, has a higher bandwidth and so on. We have 4 other institutes here as well, which are still not fully finished with the testing, but for the moment we go ahead with this 6. I think that is my talk. Yes, I'm ready for questions. Thank you.
Thank you very much, Simon, for that presentation and for the use cases that you have also shared with us. At this point, also due to the time limitations, I will request for the questions to be sent via email so that we can also give an opportunity for our final presentation for this session, which is going to be coming from the CEO at the South African National Space Agency, Mr. Valanathan Munsami, who is going to be talking to us about the African future perspective. Welcome, Mr. Munsami.
Thank you, Kizito, and very privileged for the opportunity to present. So I'll be focusing on the African future perspectives. But I'm going to limit it more from a policy kind of aspirational perspective in terms of where Africa is heading and grounding that perspective in terms of the policy and the strategy work that has been done for Africa. So just from a policy priority perspective, and I think this is particularly the priority of any government, democratic government, you know, it's focusing on economic growth, looking at the quality of lives of its citizens, and at the same time, looking at the environmental sustainability issue in terms of the requirements for now, and then also for the future generations to come. And that's essentially trying to balance all of these three, which is from a policy perspective, very critical. But when we're looking at it, either from the African or the European perspective, we always have to take cognizance of the local context. And the local context obviously relates to the social, the political, the economic, and the environmental perspective. So as much as there might be major differences between Africa and Europe, there are also some similarities, and in some instances, nuances, slight differences. And we have to take those perspectives into consideration when we're looking at sort of joint collaboration and partnerships. And so the local context becomes very important, even in terms of how you roll out space applications, products and services, and space technologies as well. So the policy perspectives are very critical in terms of finding the relevant hooks for some of these conversations. So from the African perspective, there's the AU vision, the African Union vision. And that advocates for an integrated, prosperous and peaceful Africa driven by its own citizens and a dynamic force in the global space arena. And then if you look at it more from what are the kind of policy priorities that Africa is shifting towards, there's the Agenda 2063, the Africa that we want. And there's a policy document that relates to that. And just to underscore, if you take that policy perspective and you look at it from a space perspective, we've developed this African space policy document. I think it was approved in January 2016. But there were 6 key objectives from the African space policy perspective. The one was addressing the user needs. And that's the key departure point from an African space perspective. And then the second one is accessing the space services. So providing the requisite infrastructure to make sure that we address the user needs. The third one is around developing the regional market. So R&D, industrial development, ensuring that the market instruments are all in place and so on. And then the rest, the objective 4, 5, and 6, they kind of more softer in a sense, good governance, coordination. And that's very critical from an African perspective where you're looking at 55 African countries. So governance and coordination becomes very critical in terms of how you harness the resources you have across the African continent to give effect to an African space program. And then the 6th one is obviously ensuring the intra-Africa collaboration, but also international cooperation. So the policy was very clear that we had to focus on international cooperation. And that's purely mainly from looking at it from a technical perspective in terms of whatever gaps that we have and how do we leverage these partnerships to address those gaps. Now, when you start to look at the policy perspective, the Agenda 2063, there are 20 goals from the Agenda 2063. And in fact, if you juxtapose that Agenda 2063 next to the SDGs, there's quite a good alignment between the two. And I think there's only about 3 goals in the Agenda 2063 that's not aligned. That relates very specifically to an African perspective. I think it's a united Africa, the African Renaissance, and stable and peaceful Africa, which is very specific to requirements of in Africa. But by and large, there's a very good correlation between Agenda 2063 and the SDGs. And the reason why I'm putting this up is that many countries and regions focus on the SDGs, but that's also a window into addressing the Agenda 2063. So we can minimize the duplication, even in terms of reporting around the SDGs and how we report against the developments around the Agenda 2063. Now, when we started to look at the African space strategy, we drew down from the Agenda 2063 and the SDGs, and we also noticed that a lot of the work that was done by the Group on Earth Observation was quite relevant to what we are trying to focus on in the African continent. So the social benefit areas of the GEO, you'll see clearly reflected in here. And what the technical group did, mainly from an Earth observation perspective, say, there's a set of user needs that we need on the left-hand side in terms of addressing the African needs on the continent. And then we looked at it from an Earth observation point of view. What are the spatial resolutions, the temporal resolutions? We didn't quite get down to the spectral resolutions. We felt that if there was a user requirements done from an acquisition management point of view, you would have to drill much deeper than what's presented here. But this was just a sort of a departure point in terms of the strategy. And then in terms of the user requirements, what would we be requiring in terms of navigation and positioning, satellite communication? And then we also looked at space science and astronomy. And I think there, apart from the space weather and the space physics kind of perspectives, also looking at it from an astronomy perspective in terms of geodetic reference frames and how that could be leveraged for Earth observation, as an example. So I think this is also very critical in terms of what is the agenda for the African space program in terms of priorities. And I think that was reflected in the strategy itself. And then I think my last 2 slides, the future outcomes in terms of the African space program. I just put down here the 1-year outcome and the 5-year outcome. But you'll see in the 1-year time frame, we're looking at just getting the governance elements properly cemented. The international partnerships plan, human capital and infrastructure development plan, research, development and technology programs. So this was just about setting the scene in terms of the foundation. And then by the time we get to the 5th year, we want to look at appropriate technology platforms, human capital development, strategic partnerships, and then focusing on space applications, services, and products, and then finding a funding mechanism so that Africa can really set its own agenda and drive its agenda as well. So where does that leave us in terms of this particular conversation, the collaborative perspectives? So if I look at it from an African perspective, we want to harness the potential benefits of space science and technology for those socioeconomic opportunities and challenges. I've looked at it from a policy perspective. We're also looking at the African-led space agenda through mutually beneficial partnerships. So the policy and the strategy was very clear on the partnerships. We need to pursue that quite rigorously. And then we also needed to build a local capacity where we needed to ensure that we have intelligent users of space products and services. So how can we marry that in terms of the African aspirations with regards to what Europe has on offer? And I think the sharing of experience of how you bring together government, industry, and society is very critical. From an African perspective, we at the nascent phase, if you look at it from a regional perspective, so that experience from the European side of the fence will be very core to how we set the environment on the African side of the fence. And then the last bullet point is in terms of how do we assist in bridging the space divide between Africa and Europe? So the key focus areas is obviously on human capacity development, looking at knowledge and technology transfer, and also co-development and joint collaboration. And I think if you look at the policy very carefully, we talked about equal partnerships. So we don't want to see just a donor-recipient kind of relationship. Africa needs to effectively engage, bring its own resources to the table. And I think that's where we need to move going forward. So what I try to do in this presentation, just sense out the policy perspectives and the future aspirations of Africa in terms of its own African space program, and then try to conclude on the intersecting points between how Africa and Europe can essentially collaborate going forward. Thank you for your attention, Kizito.
Thank you very much, Val, for those perspectives, especially looking at Agenda 2063 and also marrying the African perspective on the one side with the perspectives of the future of Earth observation, as we have heard from the previous speakers. And as you say, looking at how to close the space divide between the two. Thank you very much. This marks the end of our session, ladies and gentlemen. I thank you, all our speakers, for those insights and the outlook of the future of Earth observation. And at this point, I would like to give the word back to the chair. Thank you. Thank you very much, Kizito. Thank you very much to all the speakers. As you know, we are running a little bit late, but I think we all deserve at least 10 minutes break. So let's break for 10 minutes and we convene here at 16:40 Lisbon time. Thank you very much, Kizito, for moderating. Thank you very much, Vincent, for being the rapporteur. And I know that we have Veronica Sesco from UNOSA already prepared for her keynote speech. So let's just keep this break within 10 minutes and we'll be back very soon. Thank you very much, Veronica, for giving us a little bit more time. Thank you.
So hello again. Are we ready? Yes, we are ready. Good afternoon, everyone. Welcome back from the coffee break. Right now, we will have the keynote speech by Veronica Sesco, Associate Program Expert from UNOSA. Veronica, I believe you are now online, but please let me know if you need a few more minutes or if you're ready to start. I don't have feedback. Maybe we have some issues. Let's give a couple of more minutes. Veronica, are you online?
Hugo, Veronica seemed to not have access to the panel. She said it in the chat.
Okay.
Perfect, I'm here.
Yes.
Can you hear me?
Yes, Veronica is now online. Yes, so Veronica, welcome. Welcome, now we can hear you very well. Welcome to the conference, to this high-level forum. So without further ado, I will give you the floor, and the floor is yours. Thank you very much for joining us.
Thank you very much, Hugo. And of course, thank you very much to the Portuguese presidency of the Council of the EU for this kind invitation. It is with great pleasure that I delivered this keynote speech on behalf of the United Nations Office for Outer Space Affairs. Space assets have transformed the way we live. We use space for a great variety of activities. And through sustained, reliable, and timeless observation, space infrastructure has unlocked virtually limitless access to data and information. Space infrastructure goes far beyond its monitoring capabilities to actual services and applications, enabling great strides in the quest for sustainable development. In 2018, UNOSA joined with the European Commission for a study to evaluate the impact of European space infrastructures on the Sustainable Development Goals. And it was found that geolocation and Earth observation directly contribute to almost 40% of all the targets underpinning the SDGs. And if you add SATCOMs, we are well above 50%. At UNOSA, we are doing what we can to bring positive change. We stand at the center of space affairs in the United Nations, and in our role as enabler, we have sought pathways to help UN member states progress in space exploration, science and technology, as well as policy and law. Our capacity building efforts have already reached more than 24,000 people through over 400 activities. And in recent years, we came to realize how critical for the success of these efforts is to be innovative. The traditional approaches are no longer sufficient to address the needs and requirements of modern capacity building. And as UNOSA does not possess its own space capabilities, we have relied on the great network established in these decades of our existence. We started to develop partnerships with the hands-on experience element at the core. Different work streams were developed, and as we progressed, a decision was made to consolidate all of them under a single initiative: access to space for all. Access to space for all is a definition of what we call triangular cooperation. UNOSA utilizes its global reach to build partnerships with established space stakeholders to support emerging and non-spacefaring countries. Through such efforts, we ensure that access to space and the benefits it enables are made available to everybody. From ground experiments, including micro and hypergravity, through manufacturing and launch of satellites, to operational in an orbital mission, as well as access to the International Space Station and the China Space Station for educational and research purposes. Let me describe shortly joint ventures that we are currently having, just that you have a better picture of what's possible for those who might be interested in applying, but also for those who might wish to partner with the United Nations and contribute expanding access to space benefits. Our agreement with ZARM and DLR allows us to offer students the opportunity to learn and study microgravity science by performing experiments using the Bremen Drop Tower in Germany. And so far, 6 rounds have been completed, benefiting students from all over the world. Our partnership with the European space agencies focuses on the opposite end of the gravity spectrum. And through the Large Diameter Centrifuge Center at ESTEC in the Netherlands, students and teams will be able to conduct hypergravity experiments. And then there is KiboCube, a capacity building program that offers educational and research institutions from developing countries the opportunity to deploy CubeSat from the Kibo module on the International Space Station. And KiboCube broke records and helped African member states such as Kenya and Mauritius to enter the list of spacefaring nations. Through the UN SPIDER, the UN Space-Based Information Platform for Disaster and Emergency Response, we work with governments to better integrate space solutions into decision-making and to improve access to reliable, accurate, and timely information by emergency rescue and relief organizations. In 2020, we supported countries such as Tunisia, Nigeria, Niger, and Mozambique in monitoring and dealing with flood and drought. And we're also actively helping states to follow international space law and other relevant measures. Through space law for new space actors, we support emerging space players in developing an enhanced understanding of the fundamentals of international space law, and also to implement existing international agreements such as the Outer Space Treaty. This is just a glimpse of the work we are doing with partners in Europe and Africa and beyond. Overall, the long history of productive multilateral collaboration through the United Nations in the space sector is a great example of what the international community can achieve with robust institutional support, political will, and a common goal. And please do not forget something. Everything we do in space must be done responsibly. To enjoy space benefits, a safe, secure, and sustainable space environment is a must. The unprecedented growth in the number and diversity of stakeholders represent both opportunities but also risks. A true stakeholder space economy must be born. To explore this complex topic of space economy, in 2020, UNOSA organized a series of online events dedicated to unpacking the component of such a complex concept. The expertise from representatives from the public and private domains allowed us to dive deep into the theme from various perspectives. We explored how different countries strengthen their respective space sectors and how different stakeholders can help to scale up commercial entities and enable access to finance to foster entrepreneurship. The focus was also on exploring the nexus between government, industry, and academia for innovation and growth. In January, we published the 2020 Space Economy Outcome Report that highlights success stories and lessons learned to create and strengthen healthy national space economies. We have explored avenues to continue shaping the discussion on this subject, and on June 30th, UNOOSA will hold an open virtual conference entirely dedicated to the African space sector. High-level representatives from UNOOSA, African Union, Portugal, and space companies will engage in peer-to-peer exchange of good practices to foster economic growth. This activity provides a unique platform at UN level to bring together the commercial space sector in Africa to discuss how to grow strong, responsible, and sustainable space economies. Looking forward, we must move to a knowledge-based society driven by science, technology, and innovation. By embracing cooperation, inclusiveness, and diversity, we can get there. These are the values that are at the core of the United Nations. And UNOOSA stands ready to support the future efforts in identifying the needs and developing the right solutions to space-related issues. Being a broker of international cooperation for the space and non-space community is a mission which the office has successfully carried out since its inception, and we will continue to do so. I thank you very much for your attention, and I wish you a fruitful session and discussion. Thank you very much.
Thank you very much, Veronica. Thank you for your great speech. And I think we should move directly to session number 5, so we ensure that we will not lose any more time. And session number 5 will be about capacity building, innovation, entrepreneurship in the downstream applications. This session will be moderated by Marianne Diop-Kane, Program Manager of COMET, and the rapporteur will be Marie Menard, from the Communications Officer from OISPA. So thank you very much both, and thank you all the speakers that will now engage on the next session. So Marianne, I will give the floor to you, and thank you very much for joining us.
Thank you, Igor. Good afternoon, good evening, everybody from wherever you are. From East Africa, where I'm from, the night is falling and we are running very late. So I'll be your moderator. And I'm Marianne Diop-Kane from WMO Regional Office for Africa, based in Addis, and in charge of the African Ministerial Conference on Meteorology, COMET. So welcome to this last session, but not the least, because we know that capacity building, innovation, and entrepreneurship is very important for Africa, as it is a young continent. And capacity building is key, really, to achieving anything. The African people need good mass training, need to be innovative to develop the product they need in whatever field, and here, space as observation. If the continent have to aspire to achieve the AU 2063 agenda and SDGs. So this capacity building needs strong cooperation. And the previous speakers have spoken about it. We had a very good insight from the Chief Executive of SANSA on partnership and collaboration. You just heard the speech of Veronica and how important it is to have good space observation and capacity building, partnership, free access to space to all. So without further ado, I will call on my speakers and I will ask them to be short and keep on to the 5 minutes. And this session will be in 3 parts. The first part will be looking into the existing initiatives and programs. The second part onto the opportunities for entrepreneurs. And the last part, we'll listen to some success stories. At the end of each session, we'll be having some question and answers, and you can post your questions on the chat. Without further ado, I will call on Mesrak Ndiri to tell us about the GMS Africa training program.
Thank you, Dr. Marianne Diop. My name is Meshak, and I'm leading the training of GMS in Africa. And I had shared the presentation in the event that it is not ready. I'll just speak through in order to save my 5 minutes. Well, let me say that the capacity building component of GMS in Africa was entrenched within the African Space Policy and Strategy, which was presented earlier today by Dr. Tidiane. And in that strategy, it calls for the revolution of skills in the continent, as well as enhancement of the needed capital development to support the African Space Program. And this, in this case, particularly on the Earth observation. So what happened, I will give you the process of how we went through developing our capacity building component in GMS in Africa, which we developed, first of all, a training strategy, which is a guiding principle on where we're going. And within those principles, we had key highlights on them. One of them was that we are going to use 3 modes of training, which is either classroom or online or on-the-job training. And we have implemented all the 3 components through the trainings that we have held. And the other one is that we're going to hold these capacity building activities within an academic setup. And the reason for that is that in the previous programs that we have had, the capacity building has always been, short-term oriented, and we wanted to bring in the academic sector to involve them in the capital development so that the students and those who are the teachers and the professors can take advantage of the data and the materials to breed long-term capital development. And the other one is that the training to focus on the training of trainers and building on the existing, which is the capital or the capacity utilization component, a very useful fact in the human capital development, which was mentioned earlier today. And we started that by mapping out the existing capacity within the continent that has been produced over time through other programs like MESA, MSD, and PUMA. And we documented all that. Then we went on to matchmaking kind of activity by building on what has been there already and building and using that capacity to train the others on the continent. Well, involvement of the private sector, which is a very important component. This topic today deals with innovation and entrepreneurship in the vis-a-vis of capacity development, and I'm going to talk about that in a moment. And use of free and open source software, as well as the important one that we focused on is the integration of other technologies like ICT with Earth observation, things like cloud computing and virtualization. Well, so what happened is that we carried out the training needs assessment from all our institutions, and we developed a training catalog out of those needs and categorized into courses the different needs that we got from the consortium. So we ended up having inputs of about almost over 100 needs of courses, and then we categorized them into different courses that we developed with the consortium. And then after that, what happened is that we did what we call the division of labor between the African Union Commission and partners like JRC, UMETSAT, ESA, at the continental level, focusing on the cross-cutting needs. And then we went further ahead to allocate some of the needs or some of the courses to the consortia themselves, which were specific to different regions. Then after that, we went into implementation of the strategy as well as the catalog. Implementation of the catalog, but respecting the strategy. And so far, we have been able to carry out a lot of trainings. As I'm speaking, we have been able to do over 3,000 trainees have been impacted. And we have done, we have also done what we call offering of scholarships to over 40 masters and PhD students, and allowing them to contribute to the development of services within the consortia by supporting them with what they learn in classroom and practicing it in the consortia. And we still have hope that by the end of the program, we are going to have more masters and PhD graduating from this important project. And we have created what we call the GMS an Africa network of universities, which we have activated and operationalized, and we have also created the virtual networking platform for it. And in fact, we have held different meetings with these universities, and in the next two weeks, we are going to have another one. We have within our database over 20 universities that are collaborating with us, and we want out of that to breed what we call a network that can bring out programs like what happened with the case of Erasmus Mundus, and we hope that with collaboration with the European partners, we can be able to sustain this network and also have more exchange of information as well as the knowledge. And on top of that, we have created what we call the digital learning platform, which hosts about 100 courses. And currently it has about 700 users who are registered and taking those courses. This allows us to, it has really helped us within the COVID context when we couldn't have the online classrooms, and we have been able to train people through this platform. Well, what we have learned, and I can speak in general in terms of conclusion, is that because we are marrying between entrepreneurship and the academia, well, first of all, we understand that developing countries are in the middle point, and they are faced with the pressure of shifting from the business as usual model of short-term investment and also investing in the long-term technology. But at the same time, we don't expect, developing nations, the governments to disrupt themselves. So this disruption is going to come from the private sector and combination of that private sector and academia, and we must facilitate that. In our trainings, we have involved both academia and the private sector. In some cases, the private sector was offering the trainings, and in some cases, the academia itself was doing the training. But we have seen that through the working of African countries, what works best is actually the combination of the three of them. You have a public institution that is probably, or the consortia that is developing the services, and then you have the private sector that is bringing the innovation, and you have the academia, which itself is bringing the long-term view in terms of capacity development. So, what I would like to, the ideal way is for...
Think about summarizing, please.
Okay, sorry, just a minute. So I would conclude by saying that, well, we have to be innovative because for me, the academia brings the innovation and the private sector brings what we call the invention of these services. We have moved from development of products themselves to service delivery, and the private sector is very vital in terms of deploying these innovations in our mobile phones and other devices. So I would say that the combination of both private sector and academia in this context is very helpful to sustain the services in the continent.
Thank you very much for this very nice presentation. Showing mass really training of Africans and bringing together the private sector and the academia. So a good example of public-private partnership. So without further ado, I'll call on the next presenter, Christophe Obrecht, Program Coordinator, Global Development Assistant from ESA. He will tell us about the space for international development assistance, sustainable Earth observation adoption within development finance. Christophe,
thank you.
The floor is yours.
Thank you very much. I hope you can hear me well and also see my slides by now. Can you please confirm?
Yep.
Perfect. So it's a pleasure to be a part of this panel, and I will actually dive right into it. What I'm going to talk about today is a new initiative that ESA is jointly implementing with partners in the international financial institutions, such as the World Bank and the Asian Development Bank. But we are envisioning also the African Development Bank joining us very soon. So this initiative is called Space for International Development Assistance. And it has actually a long heritage, which, let me see if I can advance the slides here. Yes, which really builds on this inflow, massive inflow of data that we are observing over the last couple of years, increasing and increasing. I mean, we feel the pulse of our planet now, and there's really no justification anymore also for the development community not to use all these types of data that we are collecting, including from Copernicus, from the Sentinels, and also commercial missions. So basically, what we focus on is not the data anymore. What we focus on is the problems that these data can help us solve. And that's basically the key objective of the programs that we have set up at the European Space Agency in support of international development. And this slide gives you a brief history, basically 10 plus years back. We started back in 2008 with an initiative called EO World, which supported the World Bank. Then we had one initiative, EO TAP, that supported the Asian Development Bank, and another one supporting the European Investment Bank. And it was all about demonstrating at a small scale, demonstrating the value that Earth observation can bring to development operations. Then we tried to become more strategic and scale this up. And created the still ongoing EO4SD, or Earth Observation for Sustainable Development Initiative. And this had several changes compared to EO World. It did not focus on small-scale demonstrations anymore, but rather on thematically oriented clusters, large-scale integration in development projects. And it added a strong capacity building component to it. So it was not just anymore about demonstrating the services and illustrating that it works, but actually building capacity both with IFI teams and clients in the developing countries and counterparts and stakeholders there. So this was extremely successful, and I will show you a little bit more on the next in the next 2 minutes. But we are now already thinking about the next step, which is now a completely new ESA program, the Global Development Assistance Program, which in fact is now part of a larger scale initiative, the Space for IDA initiative I mentioned at the beginning. So we try to programmatically transfer ownership to the development banks and integrated the whole thinking on satellite Earth observation also in development finance and their standard working processes. So it's all about mainstreaming and transferring. And a lot of this has to do with capacity building, which I'll now elaborate on. So nothing of this, EO services, EO information products will have lasting impact unless we build sustainable capacity on the ground in the countries. In EO4SD, we have invested quite substantial amount of time and resources on that. And I just, highlight a few here examples of capacity building initiatives in Africa, across the continent, across different topics, from climate to disaster resilience, to marine environment, to agriculture, water resource management, etc. An interesting case also is this second one here, the online course on basically an overview on geospatial information technology in fragile contexts, where more than 1,300 people attended. Due to COVID, obviously everything online now. It's in 3 languages, English, French, and Arabic, and many countries in Africa had representatives there. So another, basically in the same spirit, capacity building activity is the EO Africa R&D facility and the Space Academy therein, which really focuses on co-creation and co-design of learning material, both in-person and online capacity building in a joint manner between Europe and Africa. My colleague Benjamin already alluded a little bit to that in session 2 earlier on today, so I won't spend too much time on this. So maybe to wrap up with 2 more slides, we often encounter these challenges, and I label them with the 5 A's on what those challenges we need to overcome to really create sustainable sustainable impact. Availability and accessibility have really been addressed or are being addressed through Copernicus. Awareness raising, we've started more than 10 years ago. The acceptance level of these services has been, massively increasing over the last years. And we now need to go beyond capacity building and even, include skills transfer activities to ensure full adoption and go beyond the disruptive technology stage. And that's what we are trying to do now with Space for IDA. So this is the framework here. It has two components, one funded by ESA through GDA and another component funded through the development banks. And I skip this here now to actually get into the content. So the GDA program has a number of themes that it will focus on, and it will basically, in direct response to IFI and client country needs, develop services and tools that address those main challenges. And then in complementary manner to that, the development banks actually mobilize resources that complement the GDA technical developments and focus on capacity building and skills transfer activities. And actually by now we have mobilized more than $100 million that include around 66 million dedicated to capacity building. And I just highlight two examples here, one by the World Bank setting up a Digital Earth Partnership Program and the Asian Development Bank setting up an EO program for development and digital transformation that will focus on coordinating these aspects. So I leave it with this and look forward to the other presentations in this session. Thank you very much.
Thank you very much, Christophe, for this very nice presentation with nice initiative of capacity building, and which is even nicer when you think about sustainability, because what Africa really needs, and your efforts in resourcing, in mobilizing resources. Thank you very much. So I will call on the next presenter, Caroline Sa, Earth Observation Officer from the Portuguese Space Agency. She'll be telling us about FP-CAP, if I'm pronouncing it right. This is an EU initiative to increase Copernicus user uptake, example from Africa.
Yeah, thank you very much. I will be presenting the Framework Partnership Agreement on Copernicus user uptake. And actually, I'll just be giving voice to the presentation that was prepared by the coordinator of this project, Julia Rurig from DLR, who was not able to be here today. And I will be here representing a partner, Portugal Space's partner in this framework agreement. And so what is this framework partnership agreement? Picking up on the words of Christophe before, is a program supported or funded by the European Union that focus on the awareness, acceptance, and adoption of the Copernicus data. So is intended to enhance Copernicus user uptake, and it has a bottom-up approach. So the partners of the consortium propose specific actions that then are approved and implemented. This consortium has more than 40 partners from 23 European countries. So this allows to have very diverse backgrounds and experience and to focus in specific groups and topics. We have already more than 150 actions being implemented so far. And why is this relevant also for this conference is because this project is also allows activities outside Europe, so also South America, Asia, and in Africa. And we have actually 12 partners from 8 countries already implementing activities with African partners. What kind of activities are supported or have been proposed by partners? So we have the more classic raising awareness and acceptance, so information and training events. These information and training events can be more general. So as the picture there shows, the Greek partner organizes different webinars with Tunisian scientific and academia community, for instance. But then we have also partners focused on specific topics, like DLR focusing on technical support in the disaster management or disaster risk reduction, or for instance CNES that is promoting some activity trainings on the oceanography topics, for instance. We also have activities more focused on the establishing of dialogue between actors, so establishing user fora. It's very important to address the user needs and identify best practices. So this example shows how we can connect also African users with other users from different countries that might have same needs and can interact to establish best practices. We also then have something, activities that are more practical and more regarding the adoption side. So identifying the needs, can we develop and pilot some downstream applications? So an example here from DLR trying to identify environmental indicators to support management of African cities. And then we have also activities more connected to business and innovation activities. So some of them more targeting networking and internationalization of SMEs in different countries, and also others promoting innovation challenges. So once user needs are identified, can we find the relevant stakeholders to develop solutions for these requirements? So we have here an example in Côte d'Ivoire that needed some support in illegal mining, and an innovation challenge was launched by the CNES partner. The fact that we have these very different types of activities, there is a basis here that I should highlight, is that all of them take in account the users and the user needs. So it has been mentioned this morning that engaging with the user and making them feel the ownership of the data is very important, and we try to have involvement of the users in having their feedback and involvement in all the actions that we promote. We need to, what also is very interesting in this consortium is that we can promote synergies between the different partners, and we now are trying to have more activities joining the different partners from the different countries, and we are promoting now or proposing now an action specific for training of trainers and tutoring programs in different countries, involving 12 European partners and 17 African countries with 3 different languages for the materials we are doing. Very important to mention is that this development of training materials are intended to be done in cooperation with the different African countries. So different countries have different needs, and these training materials and tutoring programs will be adjusted to the needs of the different countries. And these activities should run until 2025. So just if you want to get involved, please visit the website. There we list there all the opportunities. You can participate to the opportunities that have been announced, or you can participate in the different events or trainings. And you can directly contact Julia if you are interested in any specific action. If you are from a Portuguese-speaking country, you can contact me directly, and we would be happy to involve you in the activities that we are promoting. So thank you very much. I think I used my time very wisely. Thank you.
Thank you very much, Caroline, to have kept to the time and to present us this very interesting initiative. It is very important as you are making us know the Copernicus data. Copernicus offers many opportunities and people don't know much about it. So running such initiative and interacting directly with users to identify their needs, raise their awareness is very important in Africa. Thank you very much. I'll pass on to the next speaker, Issa Mama Sani, the Director of the Department of Environment and Social Safeguard and Compliance from the African Development Bank. Issa, the floor is yours. Is Issa connected? It doesn't seem. So I pass on to the next speaker and come back to him later on. So it's Ruud Grim, Program Manager, Space for Global Sustainable Development from the Netherlands Space Office. Ruud,
Yes,
you have the floor.
Do you hear me?
Yes,
Ruud,
Ruud.
yes.
Okay, thank you. Hi, everybody. This is Ruud Grim from the Netherlands Space Office. I'm now starting to share my presentation. And I want to inform you about a program from the Dutch government that was started in 2013. And in this program, I think a lot of the elements that have been discussed in this session, but also earlier today, come together. Let me see, next slide. So now we all are speaking about a lot of satellite data and all the ICT and mobile connectivity. And the question now is how all this data and technology can support farmers in developing countries. And for that purpose, our government has set up a partnership program. And in this partnership program, we have 25 projects and partnerships developing services for farmers and pastoralists in 15 countries in Southeast Asia and in Africa. And what is important that within all the different projects that we see is that it is really a public-private partnership. So we see that government organizations, private sector and the NGO sector, and also research institutes are working together to develop and to deliver the services that support the farmers and pastoralists. The NGOs, of course, are very important because they have a long relation with the users and also extension officers from the agricultural department. The program is now, let's say, within 2 years ending. But we see now our, let's say, a lot of results. And now at the end of my presentation, I will show you a slide where you can see more of our results and resources of our program, because we do also a lot of lessons learned gathering, and we make that publicly available in publication, but we also have a dedicated website for that. Our program, in fact, can be seen as an early adapter because last year the Global Commission on Adaptation set an ambition to reach 300 million farmers in at least 12 African countries by 2030. And our program is in fact aimed to reach 4.5 million farmers. So that's only 1.5% of the target from the GCA. But we hope that our program, that our lessons will be taken over by other donors and other organizations and also private sector and impact investors to really scale up this kind of digital services that contain the satellite data. And I think it is important to notice that we speak a lot about the use of satellite data, but please understand that many of the farmers, let's say, will not have access to the satellite data themselves, but they have access to specific services in which the satellite data are embedded. To give you some examples, this is a project in Mali, where the pastoralists are giving advisory service to go from one place to another place where it's sufficient water and sufficient biomass for the cattle. And what we also see is that to deliver a value-added service for the users, often this type of services has to be bundled with other information. And in this case, the information is bundled also with market information so that the pastoralists have better information to decide to which region they travel with their herd. Satellite data are more and more used in index-based insurance. This is an example of a project that run in Uganda. And in Uganda, this has been very productive, also because the government of Uganda provided a 50% subsidy to the premium to be paid by the farmers. There are many more initiatives ongoing in the world, and we believe that this is one of the nice examples how satellite data really contributes to, let's say, to the bottom of the pyramid. This is a project where also, in fact, information services are provided to farmers in Burundi, where, in fact, one educated farmer goes in the village and really provides information and trains another 50 farmers at least in this village. So by doing this and by reaching out to many villages, they really are able to scale up to a very high number. So the target now for this project is set at 400,000 people to be reached in this year. Another project has run in South Africa, where the meteorological office from South Africa, together with the ARC, the Agricultural Research Council from Africa, are developing the services and delivering the services via extension officers and by SMS services. And they are now looking into this potential scaling to neighboring countries, but also they are interested to scale to other countries in Africa, for instance, in West Africa. And then we have, okay, there is of course the relation a little bit with Portugal. We have a project running in Angola, and there are also Portuguese ICT companies in the background of this project involved. The project started late and still has to develop this and validate the various services. Now, what is important to realize is that by making use of this kind of technologies, let's say for the farmers, we see that more and more young people are, let's say, making use of this kind of services. So it's making agriculture also more and more attractive to young people. And that is also especially important for Africa, where the average age of a farmer is in many countries above 50. So by bringing and making use of this kind of technology, also innovation in agriculture is, let's say, made possible. If you want to know more, this is the website where you can find more information. You can scan it, and if you have any questions, you can always contact me. Thank you very much.
Thank you very much, Rod, for this very interesting presentation, showing projects down to projects that are delivering information down to local users, community at community level, and a very good example of public-private partnership, putting together the academia, NGOs, and all people to process satellite data and deliver relevant information to local users, farmers, herders, and so on. Thank you very much. I think Issa is now connected. Issa, if you want to get the floor.
Thank you
from
very
the African
much.
Development Bank.
Thank you very much. I will have only one slide. Just to make some emphasis on two key points already raised by my predecessors, which are the adoption aspect and opportunities that exist with a development bank like AFDB. I will skip all the previous two bullets that I have on my slide here, and just state that when we talk about this issue in Africa in terms of capacity, one will see the challenges that we face in promoting and making this type of capacity being promoted very well in Africa from the demand side on how we use data at national level, right? Because I strongly believe this should be demand driven. We have various and many sources of supply in terms of institutions that are providing these technologies and expertise from outside. Even from Africa, it is growing, but the momentum is not sufficient in terms of end users, demand for this type of information and data. And I think we have to put more emphasis on that aspect when it comes to capacity building, because it goes with costs, and who will bear the cost in a sustainable manner, not on project by project basis. And having said that, let me just focus on what we are not an institution that is developing, these technologies or producing data. To some extent, we are ourselves, users. We are we need this data for our own business. During project preparation that we carry out with our regional member countries or even private sectors, stakeholders, or during project implementation where we have responsibility to support them, be it by providing advice or data or technical support or finance sometimes. We have two ongoing initiatives that are very closely, related to this type of initiative. The first one is a broader one. We have a capacity building center for African countries that is finalizing its own strategy, which include many things. Among other, we have this data collection and processing and dissemination aspects. And we have our units that we call the African Center for Natural Resources, which is also a unit internally that has a mandate to, to prepare country diagnostic and profile to support our RMCs in managing very well their natural resources, broadly speaking, forest, ocean, fisheries, fertile soil. And my department, my own department, the Environmental and Social Department, which is involved with operational sectors to support projects that are being implemented in countries, and for which we always need data, either when we go to the field to work with our partners, or like in these very specific circumstances that we face, over the last year with COVID, when we cannot, due to restriction or security issue, go to the field, but we need to collect data and monitor what is going on the field. So these are aspects that are very important for us. And I will finish with this. We are financier, we are not solution developer. We are also end users. So the opportunities that exist, with us, sometimes we may have small grants, to support institutions that develop that, which will be case by case basis. But most importantly, I think for the sustainability matter, we need to sensitize countries so that they mainstream this kind of demand when they come to our institution to look for, financial support to develop their program, disaster risk management program, agriculture program, and all these programs that require this sort of data for development purposes. We are also currently developing or deploying very specific product for youth and women in terms of entrepreneurship, SMEs, through specific funds that are going through financial intermediaries. It is not only dedicated to this, type of initiative, but these are initiatives that are also eligible to this fund. And I will urge people who are interested to go to our website and from time to time, check and see whether there is something they can tap on. Thank you.
Thank you very much, Issa. And thank you to, it's good to know that you are having project on gender and youth. It's good to let us know. And it's been very good that you are stressing on end users. We need to develop the capacity of the end users. This is very right. And the after project sustainability. Many projects are going on in Africa. After the project, this is the end. So we need to build this sustainability. Thank you very much, Issa. And I will open the floor for questions. Quickly, we are running very late. I don't see any in the chat.
Maybe we can move forward. I don't know if there's no questions.
Yes.
Perhaps this would help us. Thank you.
Yeah. Yeah, we move on to the second part, boosting entrepreneurship in Africa, opportunities for entrepreneurs. And I will call on Fiametta Diani, the head of market development.
So thank you, Marianne, and good evening, everybody. So my name is Fiametta Diani, and I'm head of market development at the USPA, our new agency, EU agency for the space program. So let me share a few slides with you. Okay, so I'm going to address how the synergies between the satellite navigation and the Earth observation, and in particular our programs in Europe, European programs, can enable opportunities for entrepreneurs in Europe and in Africa. So as I said, we are the European Union Agency for the Space Program. We are newborn, but we build on the legacy of the GSA, the Agency for Galileo. And we link the space to the user needs. We want to be a user-oriented operational agency that contribute to sustainable growth, security, and safety. So we have this mindset of the end users and of enabling them to really make the best use of our space systems. As I said, I will focus on synergies because we do believe that using together, for example, Galileo and Copernicus, enable a set, an array of synergies and application that benefit out of it. We also made a study together with UNOSA, the United Nations Office for Space, and we found out the contribution to the Sustainable Development Goal, in particular by the combined use. So if you are curious to know about it, you can also learn this contribution. And also let me say that Galileo today is a user basis of 2 billion users.
Your slide
yes?
are not moving. Your slide
okay.
are not moving.
Okay, so no problem. I will verbalize. So let me see. So you can see moving?
Not at all.
Not at all. Okay, so I will. 1 second. I try in one other way. Doesn't work.
And now the presentation.
Okay, can you see now?
Try moving. Yeah.
Marianne, can you see now correctly?
Yes, it's fine, yeah.
Okay, great. Okay, so thank you to you. So I was saying that with Galileo, we have a user basis of 2 billion users. This user can use Galileo via smartphone. So it's a device that can be everywhere in the world, also in very simple smartphone. And there you are enabled for the use of Galileo and to invent applications that will enable a set of many innovative things. So, but let me make 3 examples of this combined use to go in more concrete. So the first one is related to precision farming and to agriculture. So with Copernicus, that deliver free data all over the world, as it was said also before, we can have maps, prescription maps that tell us what to do to optimize, for example, our use of fertilizer. And with precise positioning delivered by Galileo all over the world, we can then calibrate how to distribute these substances. And so we can have a more efficient and less environmental impact for our agriculture. Another example is related to the renewable energy. So with Copernicus, we can help to optimize the selection of the sites for solar farms, for wind farms, and evaluate the energy potential and also the environmental analysis. And then with the satellite navigation, precise satellite navigation, we can do the fine site selection, we can survey the construction phase, and also optimize the maintenance, making it longer life and lower cost, as well as synchronizing the networks. Last example, the construction of infrastructure. So with the Copernicus, we can provide the actual state of the land use and land cover. And then with the satellite navigation, we can trace and track the construction assets, and we can do the topographic mapping and other application. So these examples are to say that this kind of application can be an opportunity for entrepreneurs, because often is SME, is also startups, so entrepreneurs that provide the solution, the software solution that enable then the use of this technology in these fields. And in the USPA, we promote young entrepreneurs in different fields. We cooperate with the Commission in the Cassini initiative for entrepreneurs. And among other things, for example, we had last December Farming by Satellite contest and a special prize for Africa to stimulate ideas of how to use satellite technologies in agriculture. And our winners, that was a cooperation between Kenya and Italy, developed an application for the assessment of coffee farms in central Kenya, indicating the changes over time in areas where the farmers could increase the yield. And last but not least, our EGNOS system that today is functioning in Europe is planned to be extended to Africa. There are different projects and activities and different scenarios. And this will also open opportunity for entrepreneurs in different fields that you see here some example in precision agriculture, in geomatics, but also in drones operation, and in the future also in aviation and emergency helicopters. So this is also another area of opportunity that is upcoming. Before concluding, let me say that at USPA, we will soon start our new activities to support entrepreneurs and startups, so stay tuned with us. And we will also launch the Horizon Europe course on space downstream that will foresee also international cooperation calls. So this will be concrete opportunities upcoming soon. Thank you.
Thank you, Fiametta. Very nice examples of opportunities for entrepreneurs. You've shown us how the data that are being offered by Copernicus and Galileo, how do they allow the startup to develop application to produce information to users, farmers. And I'll have a question for you in these opportunities. Have you included or worked with any African team? You can come back to that later on. I'll call on to the next speaker, Frank Salz-Jaber, Head of Innovation and Venture Office, SA.
Thank you so much, Marine, and Thank you much for everybody to join us at so late hours. A little bit background, because I'm not a space engineer, I'm an industrial engineer. I worked for Apple, had my own startup company, and I can only do business. I can do business, startups, I can not do projects. I can support products. So this is the reason why ESA hired me nearly on the day, I think it was 2003, and first with commercial development, and then since 16 years, we support startups, because it's another way of tech transfer. And since this time, we have supported over 1,200 startups across Europe. And these are the companies we have supported and promoted. And I want to share with you a little bit what is the lessons learned, where we have burned our fingers. And I remember that our old director general once said to me, Monsieur Jacques Dodin, Frank, he said, I'm a mechanical engineer. And when you do something new in mechanical engineering, you have friction. And if you have no friction, you do something wrong. And my answer was, okay, then we do something terrible, right? Because we have a lot of frictions. So that's a good sign also for a startup. When you do something and all the people say, no, you cannot do that. Or even when some organizations say, no, that's the wrong way to do it, most likely you're on the right track. So the first lessons, what we learned is when we support entrepreneurship, and we do that in all ESA member states. And I just was speaking on a congress in the morning around Morocco about the same thing. It's about cooperation. So you don't have to do all the things by yourself. You have partners, learn from them. There's a nice saying, unexperienced artists imitate, experienced artists copy. So copy what it works and adapt it for your needs. So cooperation, this is what we discuss also in this great symposium today. The second is you have to walk before you run. So therefore, see what you have already. And a lot of regions have great entrepreneurship minds. They have good universities for some other areas. And I'm coming from IT, and I remember that Kenya has developed the BRIC as a connectivity tool, or we had PESA as a payment tool. These are great innovations. So I think these are good examples where we can do it. So therefore, every business is local. The people locally know what to do. And this is also what we in ESA adapted with our incubation center, which is much more than a funding program. Because what we have to see, we have to support from the day of the idea until the company is really running. That makes a sustainable business. It's the same what parents are doing. So I always say we are the uncles and the aunts, we are the good fathers and the good mother, from the birth, from the early days to the kindergarten and the creche, to the school, to the university. If you do all things right, what you get is a Hanukkah card, it's a Ramadan card, a New Year card, or a Christmas card, to be religious completely free. So I think this is also what we do. We have to guide them as governmental organization. The Irish have a good saying. They say, on the giants, on the shoulders of the giants, you see further. We are the giants for the entrepreneurs, and we have only to allow them to climb on our shoulders, and you have to group other giants. And what I also learned, technology is never a problem in the cases of our startups. It's never. Last year, our startups we supported, and we count them still later, received over 700 million venture support. They don't need us in the later stages. They still call us when they have trouble and problems because they trust us. We don't take shares. So how we do that is really to see where are the local partners. In Switzerland is the ETH Zurich. In the Czech Republic is in Czech Invest. So our incubation centers are built on local excellence, and we as ESA help with our framework, with our tools to share best practices, to share trust, and also bring startups together, because startups do very fair business. And I know that there are talks with CNES related to Morocco. I know that Portugal looks into that. I know that Italy looks into it. I know that other member states looking to help that, because we in Europe have built a framework which is built on trust and cooperation. So local business, every business is locally. It's built on trust, it's built on relations. And as I said, you have to help in the innovation funnel. You don't have to do all the things yourself. When you build a house, you don't do yourselves. You find partners doing that. So it's the same. You have hackathons for the idea competition. Then you see making business plans out of it. helping with university, helping with technical support, helping with funding. The only thing what you have to take care is that the handshake between one level to the other is there. This is the reason why we work so well with our member states, with the other agency and with our industry, because when the people have one goal, it works together. Last but not least, what you have to see, when we speak about space, software is easy. Software, it does not take very long. Hardware is hard, it takes more time. So therefore, be patient and take always the example of my kids when we were building a house. Other people did that, and they said, which tree you want to have? And they said, they like nuts, and they said, we want to have a walnut tree. And I said, are you sure? Yeah, we want to have it. The problem is, it's not about only the sun and the shade. It takes 15 years until you can do the first harvesting. So we have to understand when we invest in entrepreneurship, we have to be patient because it takes time until they grow and bring the turn. So my offer is, I'm happy to connect the colleagues which are interesting to some of our member states. Portugal, for example, is doing an amazing job with the innovation cluster. And thank you all for Portugal Space also to being so much supportive. And we really started with 6 companies. Every year we supported 220 startup companies. We have the first companies raising billion-dollar evaluations. And when you want to have a forest, you start with a small plant and a small tree. And this goes for all applications, navigation, Earth observation, and do not forget telecommunication. It's about the connectivity. So that is what I think I want to share with you, and the offer to connect to the right people, because jointly we can hammer a hole into the universe. Thank you very much.
For sharing the lessons you learn when supporting this good number of startups. And you can put in the cooperation, which is fundamental, the trust and cooperation. Technology, you say, is not a problem, and especially working with local partners, you have to learn and copy and adapt to your needs. So this is well done. Thank you for sharing that. So now the floor is open for questions, if you have any. I don't see any on the chat. So I'll come back to Fia Meta about my previous question, whether you work with African companies. Fia Meta? Maybe
Marianne, yes, I'm here. We had some problems to hear you. Can you repeat me the question, please?
Net is breaking. I asked you earlier whether you managed to work with African institutions, African companies, if you have any collaboration in Africa.
Yes, as I was explaining, we have this project of extension of EGNOS in Africa, for which we have cooperation with both public and private, public institutions and private companies in Africa. We had also several capacity building projects to prepare for this evolution. And in several countries, actually, so covering different areas of Africa. And also with this prize that we do in the agriculture field, we built a cooperation with the startups and young entrepreneurs from Africa that we would like to continue to support in the future.
Thank you very much. I may have missed it because my internet is breaking. Thank you. So we'll go on to the last part of this session, and we'll hear about some success stories. And I will go on to Kizito, the Chief Executive Officer of Agribora.
Yes, thank you very much, Marianne, for giving me the opportunity. I just have 3 slides and would like to take 5 minutes to give some of the information about where we have reached with Agribora And of course, just taking the power and energy from Frank and showing you where Agribora, as a baby of ESA, has made strides in the last 4 years. A brief snapshot of Agribora: we were formed in Darmstadt in Germany back in 2018, supported by the incubator at the European Space Agency. And we now have a subsidiary in Kenya, where I am also at the moment. And we are in the agriculture sector, which is one of the most important and relevant sectors across the continent. And our business model is revolving around making these farmers, enabling these farmers to trade better with their business partners, from input providers to output markets. So far, we've been able to convince 40,000 farmers to look at how they can leverage space data and opportunities to improve their productivity. And we are looking at getting 1 million farmers on our platform within the next 3 years. I just want to talk about briefly about where we see the relevance of Earth observation data, especially now in entrepreneurship and business. And I want to look at this from a perspective of, on the one side, there is technical innovation, which I think is already quite advanced if you just look at what is already available even in the European market. But on the other hand, you look at process innovation. And I think this is where Africa and Europe get to work closely together. And as Frank has said rightly, look at partnerships. There is no need for us in Kenya to try and reinvent how to generate field or crop monitoring analytics if this has already been done by colleagues and partners in other parts of the world. So how do you improve, how do you get that to work for a smallholder farmer? And as Rod said earlier, it's all about how you can develop services that use this data. So you're not really expecting a smallholder farmer to understand what Sentinel-1 and Sentinel-2 data does, but basically looking at which services do you want to offer. And if you look at the connectivity issues that are affecting the continent in terms of access to internet, access to smartphones, you want to look at how this data can still be available and accessible to farmers through simple feature phones or USSD technologies. And at Agribora, we are looking at basically how we can make smallholder farmers more visible, accessible, and bankable. And to do that, we want to leverage on data to help us develop products and services that enhance the productivity of farmers and help them to better engage with their business partners. Why? Because agriculture, while it is providing jobs for most of the people across Africa, it is also the one that has most risk, where people are not also willing to invest. So how does this look like? You basically have to have an opportunity to look at the market from the side of input provision to the output market. So how do you enable trust in this ecosystem? And this is where data plays a key role. And one of the activities we are doing currently, thanks to the support of ESA, is we are now looking at how to expose the traceability of crop production for agri-processors, so off-takers of high-value crops such as maize, sorghum, sunflower. And we are talking to these partners to show them how they can be able to basically improve their analytics of which farmers are growing which crop in which regions of the country, how much rainfall is there, what is the biomass diversity, what are the quantities that we are expecting. And all this requires data. All this requires data from Copernicus, from Sentinel, weather data, to be accumulated together, and then together with research data that has been used for crop modeling, for example, look at how you can develop a business case for these farmers. And we have been successful in doing that so far because we have been able to connect smallholder farmers to market. And while many people are still quite critical about how can data really improve my business, we're looking at contextualizing the services that you can develop out of data. Makes a lot of sense, and you're able to look at actually sharing in that value with other partners who are investing in that business. Thank you very much. I'll be happy to connect with you to connect European technology and local process innovation in Africa, especially in Kenya. Thank you so much.
Thank you very much, Kizito. Very nice example. I'll come back to your questions. So I'll pass the floor to Pierre Fawoy, Director of Research and Development, Africa. Pierre, you have the floor.
Thank you, Marianne. Can you hear me?
Yes, you can. Please go ahead.
Oops. All right, thank you very much. Good evening, everyone. I happen to be with my brother Kizito also in Nairobi, so it seems like it's happening in Kenya. I am Pierre Sibiri Traore. I work with Dual Cap. Manobi-Africa is an African SME working on orchestrating value chain. ICRISAT is a CGIAR center, so an international agricultural research center. And we've been working for the past 10 years at industrializing EO in smallholder agriculture. And this we do through Accelerant, which is the subsidiary branch of Manobi-Africa. So you'll ask me, why do I use a photo of people in the field when talking at a space meeting? And here's the reason. Sorry. The reason is that we can look at the way we deploy putative services to farmers in different ways. In Africa, we are tropical, so rainfall determines from the climate side most of the variability in production. So you could say that if we lack a lot of rainfall data, one way to address it is the easy way where a donor comes to you with a grant and says, build, achieve impact in the last mile, which they are really obsessed with. For good reasons. So you build a nice app and then you connect it to satellite estimates of rainfall. And then you provide through an MNO advisories to farmers for planting later or planting sooner or fertilizing more or less. And you expect that it's going to be useful. Another way we argue is a bit more articulate is what we call orchestration, where we call in a private investor to develop a more frugal, perhaps, approach as far as the instrument, and that's where we, for example, worked on this concept you saw on the previous page of IoT, cheap recyclable IoT rain gauges. Why? Because as we know, the density of ground observation networks is low. Rainfall is highly variable. If you're an insurer doing parametric insurance, you're exposed to high spatial basis risk, which increases the cost of, well, the payout rate increases the premium rate. Lowers your penetration, and since insurance typically comes with credit is also affected by propagation with literally predatory interest rates. So the question you're asking today is, and I take the IoT rain gauge as an example of what we can do with EO also, is do we ask the right questions when we want to develop services? Is it more important for a farmer to receive advisories or to receive inputs? And by inputs, I mean specifically credit, because if you get even a skillful advisory and you have nothing to activate it with, you're not in a good shape. So literally, this is the generic approach that we like to propose, is that you have in one hand a sophisticated product and a simple process, and in the other hand, you have a simple product and a sophisticated process. And you could ask, who do you think, which ones of those do you think is going to be more agile to reach customers in a very heterogeneous setting? So that is why in EO as well, we believe that embedding EO services in what we call a phygital infrastructure that provides a lot of contextual knowledge, and this has been alluded already, is absolutely essential. For example, if you try to estimate fertilization rates based on crop response from satellite, this is a typical equifinality problem where many other causes could yield the same outcome. And the only way to really know for sure what level of input you have had is to actually go and ask the farmer. So combining, and that has been also said, those EO data streams and field data streams is essential. Another aspect that I like to promote is that sometimes, and Alan this morning was saying, now we have a lot of data a lot of the time, and this in no way is a guarantee that we have a better understanding of what are the best leverage points or what are the key bottlenecks in transforming a food system. And we argue that in 2050, there will not be any more subsistence agriculture. So we need to look at changing our paradigm of optimizing farm management using, for example, a precision ag, for whatever that means for smallholder farmers, to optimizing the value chain, which is a completely different scale, which might seem more less sexy for EO folks because it looks like you're retracting from high granularity, high frequency. But that is how you actually elicit and understand demand from the different partners in the value chain. So the way we do this is we work, for example, at exploiting all the advances in the intercalibration and improvements in resolution in satellite missions. Copernicus is obviously the game changer, where we can, if you see on this schematic, look at those little red and green plots and understand when is it that a farmer has actually crossed a certain management step that would allow him or her to be eligible to a new installment in credit. This is a very big deal because commercial farms today, with a very few exceptions, do not provide funding to smallholders. And this is because they don't know what's happening with the money. In Nigeria, you find all of a sudden BOA or CBN that discovers at the end of the season that their recovery rate on smallholder loans is 2%. So if you didn't have the mid-sized farmers and the federal government bailing you out every year, you don't have a sustainable business. So we're working at developing an information system that will allow a bank to understand how is it that the farmer complies with practices that would make him or her eligible to credit, and essentially disaggregates credit over space and time. However, you also have to be mindful of what EO can and cannot do. For example, when you look at harvest, we realize that sentinels cannot see farmers who would harvest at night and side sell, hence breaching the terms of a farming contract, defaulting on the loan, collapsing the system, and making it intractable for industry to actually carry the cost of EO and field data exploitation. So this is, for example, one of the few applications where we believe drone technology has a pretty good chance. So to conclude, I'd like to propose, and I think of the many others, colleagues have said it already, it is very critical that we look at what are the low-hanging fruits in terms of EO utilization for food systems transformation. We were fairly fortunate, I would say. Well, we're happy that the EU Innovation Radar rated us as market ready, but that's not sufficient. What's really critical is how you engage with the policymakers, with the youth, and we have a youth, I would say, dividend to capitalize on in the coming 20 years, and also with finance, because finance is really the key to credit. So I want to say that it has been working pretty well. This is mostly outputs from a project funded by the European Commission called NADIRA, for Nurturing Africa's Digital Revolution for Agriculture. It has led to the Islamic Development Bank really taking on the role of a pioneer in development finance to help us establish Accelerant with the EO support at scale for 2 million smallholder growers of rice. And in the post-COVID area, I think it has particular resonance because we've discovered or we've rediscovered to what extent Africa was dependent on food imports. And we need to probably change our paradigm from food security to food sovereignty. And we believe having efficient data ecosystems in the local value chains is essential for that, but not sufficient. So I want to acknowledge the other key partners that we work with. You already know ICRISAT and Manobi, but GIZ is helping us a lot. For example, setting up Accelerant Academy, where we embed those technologies in the hands of youth, and a few other partners spanning the public and the private sector as well. Thank you very much.
Thank you very much, Pierre, for this nice success story, delivering again information to farmers. So I think that I have one question for either of you, Kizito or yourself. And you are developing an ecosystem related to data sharing, supporting smallholder farmers. Are you aware of European common data space and/or AIX data space, both having an agriculture data space? Any of you?
Maybe just briefly from my side, when I was talking about technical innovation and also looking at how we can leverage on what is already available in Europe, an example is in Germany, we are working a lot with the Space to Agriculture network, where we are able to get the experience of what are some of the data spaces, data sources that are being used already in Europe, and now looking at how do you contextualize that for the local environment in Kenya. So yes, we are aware of this space and looking at how we can get the learnings from counterparts in Europe and how to contextualize that for the local market in Kenya. Thank you.
Pierre, anything to add?
Well, absolutely. I think I cannot do anything but repeat what he said, but I will probably, yes, I can do something else. I think we lack a little bit of capacity in Africa in terms of contextualizing EO services, and we're thinking of the need to develop networks of geospatial data centers that actually embed EO services into local context, where you can have access to people who have the knowledge of local value chains, who can make sure that the service is actually based and answering a demand. It is particularly important because demand is often quite covered or not very mature, and you need to work at the contact to help it grow. I've spoken to a number of bankers who have absolutely no idea how EO could actually help them de-risk their investments, but I think we're just at a juncture point. And to conclude on finance, M-Pesa was a finance innovation that didn't wait for Europeans to let banknotes. I believe that there's an M-Pesa in the making in the EO sector in Africa. We have a lot to teach Europe as well.
Thank you very much, both of you. And I see that you are making big use of space data. Any collaboration with the National Meteorological Services?
Marianne, can I add something? Because I think Pierre is totally right. And I think this is, when we're looking in the past, the people were doing one-to-one solutions. They dragged the data, they built the application, they sold it to one customer, one-to-one. This is over for a lot of people since 5 years, but some people have not understood. It's end-to-end. You don't need a satellite if you want to have an application. It's pure the superimposing of four-dimensional data. So this is the reason why you have Sentinel Hub. Up 42 is something. Within 15 minutes, you have your data. So, and I think that's the opportunity. Don't wait on the platforms and so on. Just use the platforms for the local needs to make it bankable, to get more information, to get reflections, and to have the outcome of more houses in somewhere on the world. It takes you object-oriented programming of 15 minutes in some platforms. So I think this is the future. And there with IT and software, you reach a different argument. They take space just as an asset, like something else. And I think what Pierre says, then we see stuff which we will be amazed because we don't have all this history and entourage of the past, because there will be people making just a shortcut.
I agree.
Thank you very much, Frank.
Yeah, I think it was all said. And to answer your question, Marianne, we do work with various, I would say, success with African National Hydrological and Meteorological Services. Last month, I was with NIMET in Nigeria, where they really embraced this idea of this IoT rain gauge, because they realized that maybe it's not that important that we cannot achieve, the WMO standard of 0.2 millimeter accuracy, and that with a 1 millimeter rain gauge, but an order of magnitude higher observation network, we're achieving social value but much more significant. So we've been working with them. We also work at a local level with the Kenya Meteorological Department on testing those instruments. And the same really can go with EO or any other kind of data. It needs really to be embedded in the local capacity. And yeah, I think that's what I can add.
Yeah, thank you very much, Pierre. This is really the way forward, working all together, good collaboration, good partnership. So I think that this will end this session. I don't see any more questions. As a takeaway, I can say that we realize and we see and we confirm that capacity building, innovation, partnership are really key to sustainable development. Thank you very much for your active participation, your contribution, and I give the floor back to the chair. Thank you.
Thank you. Thank you very much, Marianne, for moderating this session. Thank you also, Marie Menard, for being the rapporteur of this session. And of course, thank you to all the speakers, because this is the last session of today. Everybody is tired, but thank you for staying and for this valuable input for today. Before closing today, I'll just give briefly the word to Tidiane. The floor is yours.
Thank you, Igor. I would not say more quickly. It has been a lengthy day, and we learned a lot. 4 segments were covered: infrastructure and data, services, including research and development and operations, training, called capacity building, and including also another aspect of infrastructure, and awareness. We also learned a lot on the achievements, lessons learned, the present and future needs, very important from both sides. And most importantly, we also heard about policy, strategic and operational approaches, synergies and cross-fertilizations. On the top of all that, the last discussions led by Mariam, and including, I would say, my later brothers, Kizito and Pierre-Claver Sibiri Traoré, are really underlining the fact that things are changing in Africa in terms of how to use Earth observation and what are the limitations of Earth observation. And small farmers financing are guiding today the agriculture in Africa. Again, I would say that is just the example of the agriculture. We have to think in our future collaboration about adapting the new technologies developed in Europe or elsewhere into the African context. That will be done with Africans in the driver's seat. Thank you to all of you. On behalf of the African Union Commission, I would say we were very, very happy. We've taken note in collaboration with the Portugal presidency. We'll look at with our colleagues, and tomorrow our senior managers will be very well briefed, and they will come with the conclusion. Thank you very much.
Thank you very much, Tidiane. For all, we have this brief report from Tidiane right now, but tomorrow we'll have a little bit deeper report during the session by Mimi Amaishigi and also Carolina Sa, where they will report based on the work done today by the rapporteurs. I don't want to extend more, so I just want to thank a few people that you don't see it, they are behind the cameras. And I'd like to thank to our translators, Teresa Estrela, Carla Basto, Emma Reis and Pedro Dorei, because without them it will not be possible to have the different languages in translation. Also, I'd like to thank the audiovisual team for the great work they did. Thank you very much. And of course, I'd like to thank Inês Dávila and Hermínia Saraiva for making this happening. And Manuela Caramujo from the presidency, thank you very much for bearing with us because of all the changes and everything. So thank you very much. And Tidiane, it was a pleasure to co-chair this session with you. So thank you very much, everyone. I'll see you tomorrow. Thank you.